Hey guys, welcome to yet another session by Scalar, and in this particular session we're going to look into Java A to Z. So once we start with Java, then we'll be looking into installation of an IDE, and also then we'll be looking into certain mini projects which you can do by yourself. So before we move on with this session, please make sure to subscribe to our channel so that you don't miss out on videos, and also leave a like if you enjoy our content. And also guys, if you have any queries, leave a comment down below and we would love to help you out. So now let's understand what exactly will be covered in this session. So first we'll start with the basics of Java. We'll understand what is programming, what is Java, why do we need it, and all that related to the very basics of Java. Then we'll be looking into data structures, we'll be looking into arrays, strings, and all that. Once that is done, we'll be looking into a little more complex concepts. We'll be looking into multi-threading, and then we'll be looking into certain OOPS concepts as well. Okay, so once this is done, we'll be showing you how to install the Java IDE, which you can install by yourself and start working on these Java programs. And finally, we'll be showing you certain mini projects in Java which you can practice and do by yourself in order to get better in Java. Okay, so this is what this session will particularly have. So now without any further delays, let's begin with it.
Hello everyone and welcome to the world of Java programming. My name is Rohan Arora and I am a freelance educator teaching computer programming to students of different age groups. I am also a Carnegie Mellon alumnus with experience in full stack web development and technology consulting. Currently, I am working as the founder for PyBook. This is a platform which is in the works, which aims to teach students based on their grasping power. It focuses on the fact that every student is different. So, what are we going to be doing in this tutorial? In this video, we will first start with the understanding of what programming really is. And then we understand how to give the basic instructions in the Java language. From there, we understand how are the different types of data stored in the programming language like Java. And then we move on to the other aspects of conditional statements such as if else, and also iterative statements like for, while, and do-while loops. All these basic constructs of the Java language help us in one of the most important aspects of any programming, maybe Python, Java, JavaScript, anything. The most important aspect is problem solving. Ability to break down a problem into different parts with the help of whatever tools the programming language has to offer. We will then move on to understanding how do we store more than one type of data of the same type using 1D arrays and 2D arrays. And then move on to one of the most important ways of problem solving, which is nothing but object-oriented programming, where we will understand the concept of what is a class, what is an object, and also understand the concept of methods and inheritance. We will then end our tutorial with the concepts of exception handling and multi-threading, which are nothing but advanced usages of the concepts of object-oriented programming. So now that is what you are up for the next 5 hours or so. So let's go ahead and get started. Do not worry if you do not have any programming background whatsoever. We will be going in a very step-by-step manner. And if you already have some programming knowledge, then great, please feel free to skip to the part which you feel is more important for you. But before we begin our introduction to what Java programming is, it would be great if you can give a thumbs up to the video and subscribe to our channel. And please feel free to comment in case you have any questions or any concerns. We would be happy to address that. So let's begin with our very first concept of what is programming. So let's go ahead and understand what the term programming really means. Now, if you look up the definition of what a program is in the English dictionary, you will go ahead and find out that a program is nothing but a plan. So now the movie theaters are opening up all over India. Let's try to now go ahead and understand how you would make a plan if you had to watch a movie with your friends and family. So you are given the responsibility, okay, that we need to have a movie out. That's our goal. Now, in the movie outing, if you are the planner to plan everything, what's the first thing that you will decide? The first thing that you're going to decide is who all are coming for the movie, right? Who are the people who will be coming? Is it your friends? Is it your family? Within your friends also coming for the movie? Is it your friends only? Is it your family or brother, sister, whoever it is, right? The next thing that you're going to decide is that, okay, which movie you want to see and what time do you want to all go and which theater you want to go to. After you've taken a decision on these things, then you will decide that, okay, how are we going to pay for the tickets, right? Is it only one person going to pay, or everybody will individually book their tickets, or how is it going to be? So basically, and based on that, we'll complete the whole process of booking the tickets online. So, and that you will take a decision of, okay, will I go on Book My Show? Will I go on the specific website, web app, or how is it? And that too, you'll decide on the mode of payment as well. How are you going to pay? Is it going to be net banking? Is it going to be, credit card, debit card? What is it going to be exactly? So you make a decision on all of these things. Once you've completed this step, then you're going to decide your travel. How are you going to travel to the theater? Are all of you coming together? Is it going to be Ola, Uber, or any other local transport available? Is somebody's vehicle, by bike, auto, bus, whatever? And then you will probably, if everything goes absolutely well, you will finally go to the theater and watch your movie. Now, over here, what you really did is that you followed a sequence of steps to achieve the goal. The goal was that you had to watch a movie and you had to make a proper plan. To achieve that goal, you came up with a certain sequence of instructions, and let me tell you, this kind of comes to you naturally, right? You don't have to think so much about it. This is because you possess the human brain. The human brain is said to be one of the most powerful processing things available out there in the world. And you do these steps in a certain order. You normally wouldn't do step number 3 here before deciding and completing step number 2. So follow a certain order. In the same way, we achieve our task by going through each step one at a time. Computer programming is nothing but a set of instructions given to the computer. In simple words, it's a set of instructions given to the computer to perform a desired task. Now, these set of instructions, and not only just you give the instructions, you also specify the step-by-step instructions. So over here, I'll just add this one more thing, a set of step-by-step instructions. So that is exactly what programming is. We want the computer to do the work on our behalf, and we are going to tell the computer, okay, computer, please go ahead and do step 1, go ahead and do step 2, step 3, step 4, and step 5. Now the question comes, why would we want the computer to do the work on our behalf? Basically, why do we want to code? One of the simplest reasons is why programming is the question. And one of the simplest reasons is that, okay, it makes our work easier. It makes our life easy. Life of humans is easy. Not only that, the computer can process large amounts of information in very less time. Large amount of information processing can be done in less time. And of course, one of the main reasons why we want the computer to do the work on our behalf is, as humans, we can make mistakes. So there are less chances, or I would say very little chance, less to no chances of the computer to making mistakes, provided we give the instructions correctly. So if we have given the instructions correctly, then the computer will follow those instructions in a step-by-step manner. So multiple advantages of why would we want the computer to do our work. So for now, what we have seen what programming is, we have also seen why we need to program. Now, let's go ahead and understand how do we communicate to the computer. Now, before we do that, let's take this step over here. The step was booking the tickets online. For some reason, assume that you are unable to book the tickets online. The website is down, things are not working well, but you still want to go and watch the movie. Then the only option that is left for you is that, okay, we will travel to the theater and go to the ticket counter, and then we will go ahead and watch the movie. So now over here, you are gone to the theater over here. This is the person at the ticket counter who is there, and he is ready to take your order for booking a seat for you. So you go to the ticket counter and say, for example, you talk to him in the French language. That please go ahead. I don't know French, but assume that in the French language, you go ahead and say that, please go ahead and book some tickets for me. The person at the ticket counter, if he knows French, great, he will do the work for you. But if he doesn't know French, he's probably going to say, I don't really understand what you're talking about. So what just happened was you gave the instructions, but still the other person wasn't able to execute them, wasn't able to perform any of the instructions. In the same way, the person over here at the ticket counter wasn't able to perform because you were not talking in a language the other person understands. It's very important that when we are giving the instructions to the computer, we speak the language the computer understands. So the question is now, what language does the computer understand? Now, to answer this, many of you who already know programming know this, but for those who don't, let's understand some very simple fact about a computer. I'm going to dumb it down to tell you what exactly does the computer really understand. We all know that the computer is an electronic device, and it has some very complex electrical circuit. And one of the main components that is responsible for performing our instructions is called the CPU, the central processing unit, or the processor, as it is called. Now, this processor or your CPU only functions, or your laptop only functions when there is battery on your laptop, right? Now, how do you provide electrical energy or battery to your laptop? You connect to an electronic socket, you switch on the socket, and that's how your laptop gets charged. Now, when you say the laptop is getting charged, what is really happening is you are providing electrical energy. This electrical energy is responsible for carrying out all the instructions that you have been giving to the computer. Whenever you, for example, press a key on your keyboard or do a mouse click or anything, basically, you are activating some parts of the electronic circuit of your device. This, in turn, is also manifested in another form of electrical energy. This whole flow of electrical energy is nothing but a series of, as you must have learned in your school, as a series of current or voltages, a series of high and low voltages. These high and low voltages are nothing but represented in simpler terms as your ones and zeros, which therefore gives us the term that what does the computer understand? The computer actually understands is a binary language. Now, please let me tell you that this is a very simplified representation of what is really going on with the computer. in the field of computer engineering, you can actually go ahead and you could really understand how is the processor made and understand how do these instructions really get manifested, and a lot of minute details that go on in the entire processing of an instruction. So, but at a high level, at a very simplified level, this is what is really going on. So the ones and zeros is not the actual ones and zeros, they are just a representation of electrical energy. Now came the evolution of something called as machine language. Now, this is the machine language which is specific to the processor of your device. Some of you might be having a HP laptop, some of you might be having a Dell laptop, some of you might be having a Mac. Now, over here, now also you must have heard that the Mac has come out with a new version, with the new processor of their own. It's the M1 processor. And the old Mac processor was the Intel processor that they were using. Now, each of these processors have their own circuitry, have their own representation of how the electronic components are placed and how much electrical energy is used to let the current flow through different parts of the circuit. Each processor has its own architecture, and on the basis of the architecture, the processor manufacturers have come up with a device-specific language called as the machine language, which is slightly better to understand than the binary language, but at the end, again, this is something which is processor-specific. As languages evolved, it was necessary for the scientists, computer scientists, to come up with a way that anybody can give any generic instructions irrespective of what the device was. And most importantly, it should be easy for the person to give those instructions. So the binary language and the machine language were called as low-level languages. Easier for the computer to understand, but slightly challenging for the humans to understand. Thereby came the evolution of something called as high-level languages. These high-level languages are nothing but, over here, the languages that we work nowadays to make different kinds of applications, including Python, C, C++, Java, and many of the other languages that are there in today's world. They are easier for us to understand, easier for humans to understand, but they are challenging for the computer to understand. I would say not possible for the computer to understand, but difficult for the computer to understand. So they were primarily designed to make our life easy. And basically the evolution of languages, just like a human-to-human communication, the languages kept on evolving based on not only the culture, but also based on the ease of being able to communicate with each other, right? The same way with the computer as well, the evolution of languages has been made so that it's easy for us humans to be able to interact with the computer. So we have understood three things so far. What is programming? Nothing but set of step-by-step instructions. Why is it good to learn programming? And most importantly, how do we communicate with the computer? There are various ways of doing that, depending on your area of liking and depending on what's comfortable for you, depending on the kind of application that you are looking for. That is what you will be using to communicate. So you have the low-level languages and the high-level languages. Now, since we have understood these basic terminologies, now let's go ahead and understand the basic processing of a Java program. Now, before I get into the terms of whatever I've written on the board over here, now say, for example, if you want to work with a Word document on your machine, when you save a Word document, the extension that you give is doc.doc or .doca. If you want to save an image, then the extension is .jpg or .jpeg or .png, different formats. Similarly, you have different formats for storing a text file, the .txt if you're on a Windows machine, right? Same way, say for example, there is an editor. There is a way to go ahead and write our Java program. We wrote our Java program in the Java language, and then we went ahead and we saved our program. Now, the extension that we need to give for our Java program is .java. And say I'm going to call it, for now I'm going to call it first program.java. Now, when I write this, I have written my Java program in my editor. And somehow, let's assume somehow, there is a way for us to instruct the processor that, Mr. Processor, please go ahead and execute my Java program. The processor, unfortunately, looks at your Java code and says that, I'm sorry, but I don't understand your Java code. As we saw over here, this is what the Java program really understands, that over here, it's the low-level language that is something which is understandable by your processor. So then what do we need to do? The same way, if you want to talk to another person who is, say, from France, and you need to talk it in the French language. The other person only understands the French language, but you understand only English. What you need in between is a translator. And the translator, what the translator does is it receives your statement in the English language. And if you're saying the right statement using the right English grammar, then the person goes ahead and then converts that statement to the French language and then tells it to the other person who understands only French. The same way, we also have a kind of a translator in between in the case of a Java language. That translator is called as, over here, the compiler. Before you give the command to execute, the compiler comes in between. The compiler comes in between, and first, what the compiler does is it checks your Java language syntax. It understands whether you are following the rules of the Java language or not. Every language has certain rules, certain grammar. Syntax is nothing but another way to follow grammar rules or just the rules of the language. Grammar or the rules of the language. You need to be following those rules whenever you're giving the instructions to the computer. If your step 1 is absolutely correct, then it goes ahead and proceeds with step 2. In the step 2, in the Java language, it goes ahead and converts your Java code into an intermediate code. This intermediate code is called as the bytecode. Now, this step is of prime importance. In a language like C or C++, the same process is followed. You write your program in the C language, the compiler compiles it, but in the second step, what the compiler does is instead of converting into an intermediate code called as the bytecode, it converts directly to machine language. Is exactly what the computer will understand. That's what will happen in a language like C and C++. Then the question comes, if C and C++ is doing this, why is Java converting it into something else, into some other kind of a language? There is a reason behind it. We'll come back to it in some time, but just hold on to the thought that over here in C and C++, it's directly the machine language. So when you execute it, it reads the machine language code that was translated and it performs it. But in Java, it converts it into bytecode. After the compilation step
is performed. What happens next is the execution. In the execution is taken care by one of the important components of the Java language, which is called as the JVM, called as the Java Virtual Machine. So whenever you install Java, you also install the Java Virtual Machine. Now, when you write this code, first program.java, after step 2, a new file gets created with the same name, first program, but with a different extension, dot class. It gets created with a different extension altogether. Now, what the JVM does when you execute the program is it looks at your dot class file and based on your machine, whichever machine you have, if you have a Mac, based on the processor of your Mac, if you have a Windows machine and an Intel processor, based on that, what the Java virtual machine does, it looks at the bytecode and converts it into machine language line by line and executes. So, a recap of what the Java language does. There is an editor where you are able to write a Java program. The compiler comes in between. The compiler first checks whether you're following the rules of the Java language or not. If your program does, then it converts it into bytecode. It's an intermediate code for the Java language. Say the code generated is first program.class. The extension it gives it is .class. The JVM, when you execute the program, converts this .class file into line by line into the machine language, which is understandable by your processor. The processor receives this language and executes the code. Quite a long process. In C and C++, however, the process is quite short. It converts it into the machine language, creates another file with the same name, of course with a different extension. And when you give it to the processor can understand that file easily. Again, let's come back to the question that we had originally. Why was there a need to convert it into bytecode? And the reason for that is platform independence. Now, what do I mean by platform independence? The thing was, whenever you are deploying any software, whenever you are running any software, you are not going to be, taking the code, the main code everywhere and to every machine and compiling and running it again and again. What you're going to be doing is you probably want to be sharing the compiled version of your program, and then people can go ahead and execute it as and how they want it. This bytecode that is generated by the Java language is independent of the machine or the device that you are using, even if it's a Mac or a Dell laptop or a Windows with an Intel processor, with an M1 processor, any processor, the bytecode is irrespective. It's the same, irrespective of the processor. What this allows us to do is that if, say, for example, your laptop you have a Windows machine, you can write the code on your machine, compile it, and just give me the .class file to my machine. I can take the .class file, and then I do have the ability to run the program. However, please note that the JVM is responsible for the execution of your code. The JVM is platform specific. The JVM of a Mac is going to be different than the JVM of a Windows versus a JVM of a Linux device. Because the JVM has the ability to convert it into the machine language. So there has to be a way where when I get the bytecode, it should be able to convert it to the processor which I am actually working with. So the JVM is platform dependent, but the bytecode is platform independent. One of the biggest advantages of the Java programming language. C++, on the other hand, had that problem. The machine language was very much device dependent or platform dependent, which made the whole concept of the compiled code not portable. You can't, if you're working on your Mac, the compiled code of a C program, I can't unfortunately run it on my device. So in order to get this platform independence and portability of the compiled code without actually sending the original source code, there was a need to come up with an intermediate language. That's what Java came up with. So that's the concept of platform independence. Quick overview of all the working of how a Java program works. You have an editor, you write a Java program, you have the compiler. The compiler compiles, and first, before it compiles, it checks whether you're following the rules or not. If you're not following the rules, then it stops you right there and gives you an error that, wait, okay, you're not following the rules of the language. It then goes ahead, it converts the Java code into intermediate code. Once it does that, then the JVM is responsible for the execution, where it converts it into machine language line by line and executes it with the help of the processor. Whereas the C and C++ language do not have the concept of an intermediate language. They directly convert it into machine language after the compilation step, and the machine language code is then can be read by the processor and be executed. So this is the basic introduction of what Java is, what programming is, why do we need to learn programming, what are the different types of languages that exist, and then finally, what's the whole process of executing a Java program, and how does it achieve platform independence as compared to a language like C and C++ with the help of an intermediate language and a compiler. We will now go ahead and see how do we write a simple Java program and proceed with the various features that Java has to provide us. Let's go ahead and see the next concepts.
All right, so we have seen now what exactly programming is, why do we need to learn to program, and we have also understood the basics about how do we really communicate with the computer, what are low-level languages, what are high-level languages. Then we've also seen the actual process of how the Java language is interpreted by the computer and what do bytecode and compiler, what role do they play in the entire process. Now the time has come to go ahead and actually start implementing some basic Python programs. So now, whenever you're starting the journey of programming, one of the easiest ways that is available right now is to use an online editor, which has the ability to compile and run your code both. So one of the famous editors that is used in today's world is called Replit, it's called. And what I'll be doing initially is I will be going ahead and writing some codes on an online editor. And then as we progress towards more important concepts and slightly larger programs, then we go ahead and install an IDE on our machine and then run some codes from there. So I'm going to go ahead and share my screen now over here. So you can see over here, I have Googled over here Replit, and the first link that opens up is the link that we have to go to. So I'm going to open the link over here. So let's go there. And now there is, the editor looks like this. You can create programs of different programming languages. So what I have created some few hours back is a basic Java program. So if you want, you can create your own new REPL over here. So you can go ahead, click on create new REPL. There are other languages available that are there. And then we can choose Java over here. And you can, by default, it gives default title, but we're going to go ahead and choose that to say that first Java program. Okay, let's go ahead and create the REPL. And what will come up is the simplest Java program that is possible. So, and here it is. All right. So now the thing is, over here, there are 5 lines of code that you see on the screen. First one is class main. That is the name of the class that you see over here. Then you have the opening curly brackets and the corresponding closing curly brackets on line number 5. Inside class main, we have public static void main and string square bracket args. And then again, a set of opening curly bracket and the closing curly bracket. Now, what is all of this? What do they really mean? Are they necessary to be there in every Java program? For now, you can understand that, yes. Okay. What is a class? What is this public static void main? The details of this is we are going to see a little later as we progress through the concepts of classes and objects. But for now, let's pay attention to line number 3 over here. And line number 3 is the most simplest line that you can have in the Java language is system.out.println. And within the quotation marks, it's hello world. This is the command to print a message on the console. Now, where is this console? This console is over here that you see, this dark black screen that is there. So whenever you run the program, what's going to happen is it's going to go ahead and it's going to print this message on this particular screen. Now, remember, as we discussed in the flow of a Java program, every program has the concept of a file. So the name of the file in this case is main.java. That's the name of the file that is created over here. Unfortunately, on Replit, we can't go ahead and change the name of the file, but we will go ahead and when we install the editor on our machine, we will be creating files with our names on it. So the thing is over here, the name is main.java. So if you observe carefully, the class name is the same as the name of the file. And this is the line which is the most important, which is system.out.println. Now, let us try to understand and see what does this piece of code do. So what I'm going to do is I'm going to simply go ahead and execute the code. There is a run button over here on the top. I'm going to go ahead and click on the run. Now you see that over here, there are 2 things that came up over here. We got the message, hello world. But if you remember from the flow of how a Java program really works, the first step was compilation actually. And over here, there's some command that is present on the screen, which kind of tells us that the compilation actually happened. Which is a command over here? It's this command, Java C. And then there's a whole long line of instruction that was given over here. Java C is the command to compile your code. Since there was no problem in our compilation, our program was absolutely correct. We were following the rules of the Java language. It went ahead and it ran the code. It created the .class file and it ran the code. For running the code, it executed another command, which is Java, and then a whole set of arguments that are there. We will get into the nitty-gritties of these as well as we proceed. But right now, this is the thing which is there. We had Java C and the name of the file, and then we had the Java, and then we executed the command. And you saw the result of the code, which is simply hello world. Now, over here, we were following the rules of the Java language. And if you observe, one of the most important rules, let's focus on line number 3, as I said again, system.out.println, your message within the quotation marks, and followed by a semicolon. Semicolon is like a full stop.
in the Java language. Now let's go ahead and let's try to get rid of the semicolon. And what we are basically doing is I'm deliberately generating a line of code which is not following the rules of the Java language. So let's see what happens when we do that. When we run the code, what happens. Now again, the command compilation is done. There was an error, and it tells you also which line number the error was on. It says main.java colon 3. Line number 3, there was a problem. And what the problem was the semicolon was expected. It's not there. And that is what was missing from the code. Since the compilation was unsuccessful, it never went ahead and created the dot class file, nor did it go ahead and execute your code. You don't see the other Java command over here. You only see the Java C, which did not happen successfully. And that's why the whole execution really never happened. So this is proof for you that if the compilation is not happening correctly, it won't go ahead with the execution. So the command over here to print a message is system.out.println. Now, what does ln really mean over here? And ln is a you can say a short form for saying new line. Now, what do I mean by this? Is this? Please pay attention to this. Whenever we print the contents within the quotation, then what really happens is the contents of the quotation mark get printed as it is. So HELLO space WORLD exclamation mark. That comes as it is. Once that is done, once the contents within the quotation marks is printed, the cursor then goes to the next line. Now, that means if there were multiple println commands on your screen, then how will the code really work? So let's go ahead and type another statement over here. I'm going to go ahead and type system. First, I'll go ahead and put the semicolon over here. System dot out dot println coming there. And let's end it to the semicolon. So what happened is, what's going to happen is we will verify our understanding by actually executing it, is first hello world will be printed. We'll put the exclamation mark. And after the hello world, after the exclamation mark is printed on the screen, it goes ahead onto the next line. Now, when it goes ahead on the next line, when the second print command happens, it will again print the contents, but this time they will be printed on the second line because the cursor is standing over there. So you have hello there, again with the exclamation mark. And since again this is a println, the cursor will be standing on the next line. So basically, with these two lines of code, what we are achieving is two different lines of output. So let's go ahead and verify our understanding by running the code over here. So it's compiling first. Compilation is successful. It executed, and you see that there are indeed two different lines in the output. Now, this is println. There's another version of the printing command, which is very famous and which is very widely used. And that command is the print command. So now let me explain to you that first before I type it out for you. So it's system.out.print without the ln. And I say hi, and I put a semicolon over here. And I go ahead and write another print command over here. Say OK. Now, what this really does is the difference between print and println is it prints the contents, but it doesn't take the cursor to the next line. It takes the cursor right next to the last character it prints. So therefore, I print H, I print I, and then I take the cursor right next to I. Then when the second print command comes in, I have to start printing, okay, since the cursor is standing right next to R, O gets printed first, then K gets printed. And since again, this is a print command, this is printed over here. So now this is the thing which is there where I will go ahead and I will print the messages using the system.out.print. So let's go ahead and verify that. And instead of the print element over here, I'm just going to make it print. Let's go ahead and run this. Hello world, exclamation mark, hello there, right? So that is how the print and the println really work. Now, what if the code is having a combination of both print and println? So let's go ahead and I'm going to erase this now and go ahead and write a bunch of code which is involving both print and println. So that's what we're going to do. So I wrote print hello world, then I wrote println hello there. And then I again go into world and I wrote system.out. So print by. Now, the first one is a print command. So that is going to go ahead and print the contents over there, hello world as it is. So we expect it is going to be hello world first. So hello world first. Once I print hello world, now since this is a print, the cursor will stand right next to the exclamation mark. The next one is a println, it's hello there. So first I'll print the contents and then I'll go to the next line. I'm going to print hello there, exclamation mark, and then my cursor will go to the next line. And now I will go ahead and the last one is a print again. So I'm going to print the contents, and this time after E, since it's a print, the cursor stops right over here. So this is the difference between print and println. Now, let's go ahead and see what all can you do within the print or the println command to generate different kinds of outputs. All right. So as you can see that the output of the code is similar to what we had discussed earlier about the difference between print and println. So the first word was a print command, so that just prints the contents as it is. So the hello world gets printed as it is. And then the cursor stands right next to the exclamation mark, and the contents of the println get printed on that same line. And since it's an ln, the cursor then moves to the next line. And that's why the contents of y appear on the second line over here. All right. So this was the difference between print and println. Now let's also understand another very important concept of something called as escape sequence. Now the escape sequences can be used within the print or the println statement. And what they basically do is they give a different looking visual output. So far, whatever we have seen is whatever we write within the quotation marks gets printed as it is. But these sequences, if you use within the print and the println, they give a different looking output. One of the most commonly used ones is called \n. So backslash followed by the letter n right after it. What it means is it's going to take the cursor to the new line. And if you probably can guess, it's similar to how println also works. Then we have something called as \t, which is a tab. This is the same tab key which is there on your keyboard. So it behaves exactly how the tab key on your keyboard functions. If you want to print the double quotation marks, then you need to write \/ with the double quotation marks. Now, why would you want to do that? Is because the double quotation marks themselves are used as a marker for the beginning and the end of your message. So if you don't do this, then Java will not be able to understand the difference between whether you actually want to print it or you want to use it as a marker. And then even to print just the \, you will use two backslashes, which will print the backslash over here. So now let's go ahead and try some code over here. So I'm going to delete this code. Here I'm going to say hello backslash end backslash quotation marks I backslash quotation mark backslash and backslash quotation mark again, and then the quotation mark. Yeah, I'm just going to erase this part of the code over here. The marks already. So now there are multiple escape sequences that are being used over here. So let's try to first understand what the output might be, and then we'll go ahead and execute and check whether we're getting the same thing or not. So first, this is the opening quotation marks, and this is the closing quotation mark. And we're going to first print the contents as it is. So we expect hello to come as it is. And then we have the backslash n. The backslash n, as we said earlier, takes the cursor to the new line. So we're going to go to the new line. Then we have the backslash quotation marks, which will help us to print a single piece of quotation marks. So we're going to print one quotation mark, one pair of quotation marks. Then we print hi, so hi gets printed. Then another pair of quotation mark gets printed, so another pair of quotation marks. So this is what the expected output is. So let's go ahead and execute and check that. Please verify. And yep, we can see that in the output. If we clear this out, yep, we can see that in the output that hello comes on the first time and hi with the double quotation marks comes on the second one. So backslash n does similar work to what the println does. So we can achieve multi-line outputs within a single print command as well. And based on the special characters that we want, there are escape sequences for them. Are these the only 4 escape sequences? Not really. There are many more, but these are the ones which are normally used in the Java language. The one being used the most is the backslash and the backslash. The tab is nothing but it gives a spacing. The number of spacing depends, so it's not a fixed space always. It may be depend on how many characters you're working with, and there's a reasoning of how many spaces it comes, but you can consider it like a nice tabbing as it is. Whenever you are writing an article and when you press the tab key, the spacing it happens, it's just exactly similar to that. So that's what the backslash t does. So this is all about the print command. So we saw the difference between print and println, and we saw the escape sequences. All right. So now let us go ahead and let us understand what else can we do with Java programming. Of course, programming is not about just printing. It's about manipulating information. In order for that to happen, what Java has said is that let us understand what the different data types are. Because we're going to be manipulating different types of data, it is necessary for us to get an understanding of what kinds of data that might be available. And so for that, Java has created many data types. Some of the main data types that are there is that what we're going to discuss right now. One of the most common pieces of information that we manipulate are integers or numbers. So one data type that is there is called as an int. Please note that int is a reserved word in the Java language. So if you write int in any IDE that you use, it will get highlighted in a certain color. That means compiler knows what the meaning of that word is, and it's reserved. You can't change it, nor can you use it for any other purpose. So int stands for integers. You can store which kind of data as integers. Examples are 7, 17, 127, negative numbers as well, -5, 0. These are all examples of integers. The other data type, which is used for storing decimal numbers or fractional numbers, is called a double. There's also another one which is quite famously used that's called as a float. Both are used. Now, what's the difference between the two? Double allows you to store decimal numbers of up to bigger decimal numbers, whereas float allows you to store smaller decimal numbers. So both can be used. So for double, let me give you some examples. It's 17.5 minus 18.234, 7.0. Even that is going to be considered as a double, and 123.5. So these are all examples of double value. Then comes the next data type to manipulate characters. So the data type for characters is CHAR or char. Char is the data type for that. And character data is always enclosed in single quotation marks. So you have single quote A is a single character, single quote capital A is another character. Then even you can have the special character, single quote question mark, single quote hashtag. These are all data types they are all types character. And then comes the fourth main important data type, which is called as the Boolean. Boolean data type is to store data of two types. One is either it can be true or it can be false. Now, how do you use the Boolean data type is what we'll see as we proceed ahead with more of our program. Now, are these the only data types that are available in the Java language? Not really. There are many versions of the integer data type as well. Okay, like for example, you have short, you have byte, you have long as well. So these are the main data types that are available. And what do they really differ in is the amount of data, how big the data can the data be stored for each of those data types. That's basically the main difference. Now, how do we go ahead and use the data? Say, for example, I want to go ahead and work with an integer. How do I work with an integer? How do I process an integer? Now, let's take the simple example. Say, for example, you are at home and you don't want to travel anywhere. You have your mom or your roommate or your partner have come to you and you want to eat something really nice. Say you want to eat pav bhaji today. Now, you go and tell your partner or your mom that, you know what, I am in the mood of eating pav bhaji. So your partner or your mom or your roommate or whoever it is says that, sure, they can make that thing for you. Unfortunately, you are out. The ingredients are not present. So what you decide that you're so determined to have that dish today that you decide that, you know what, I'm going to travel from my house. This is my house. And I'm going to travel from my house to the store. And when I travel from my house to the store, I am going to go to the store and I'm going to buy all the ingredients that are there. Now, in your journey from your house to the store, you remember exactly what you need to buy. And the reason why you're able to remember all this is because of something called as a memory. A human brain possesses the ability to retain information. The same way our computers, our laptops, our electronic devices also they also have the ability to store information or retain information. In order to retain information, there are different types of memory that are available in your computer. One of the things that is the most important in retaining information, one type of memory, which is the most common type of memory, is the hard disk. This is your permanent memory, where whatever, even if the laptop shuts down, the data that you have stored remains in the memory. The other type of memory is the RAM. It's the random access memory or the temporary memory. Now, this is the memory which is needed by your applications in order to run their programs. For example, you want to open Google Chrome. When you open Google Chrome takes some part of your RAM while you are browsing through the various sites. You're having a Zoom call with somebody else, then Zoom application is accessing some part of your RAM in order to have that meeting. The same way, Java program has the ability for you to store information in the RAM for your processing whenever you need. How can you do that? You do that with the concept of variables. So, what exactly is a variable? A variable is nothing but it's a name that you give to a memory location to store information. And what kind of a name can you give? You can give any name that you want. There are some rules of naming a variable, however. For now, just let's take a simple name. Say, for example, you want to process the marks obtained by a student. And it's any subject's marks, let's say maths. So in my Java program, I can go ahead and I can write code like this. I can create a variable called math marks. Now, if I know that this is always going to be a whole number, an integer, I will declare this as an int. So I'm going to say int math marks, and then I'm going to write equal to. And then I'm going to give whatever value I want to store. So I'm going to say I want to store the value 70. Please note, every statement needs to end with a semicolon in the Java language. When you write this line of code, what this really means is, by the way, this is called as a variable declaration. You are telling the Java compiler that, hey, listen, I am going to be using a variable which I will use it in the future, going ahead in the program for further processing. So over here, what the compiler does is the compiler helps to allocate memory in the RAM. It understands that this is an integer variable, so it goes ahead and it creates the memory in the RAM and stores the value 70. And that value, that memory location, is denoted by mathematics. Of course, what I have shown you is a very simplified representation of what really is happening. What really happens are a lot of things, a lot of activity, different parts of the memory and the computer get into the picture over here. But at a high level, this is what really happens. So you have declared a variable called math marks, and you have stored the value 70 in it. All right. So now let's go ahead and see that in our program. Okay, so let's go ahead and create a new repo so that we're going to call it working with the repo. Okay, so in our public static void main, that's the place where the program execution really happens. So I'm going to go ahead and create a variable, as I said, int math marks equal to 70 and semicolon. Now, once I have declared a variable, I can go ahead and do any processing with it. So right now, I just want to do one very simple thing. I just want to go ahead and print the value of the variable. So what I can do is I can simply go ahead and say system.out.println. And now I'm just simply going to print the value of the variables. Please note as to how I'm doing it. So I'm just writing math marks. Note that I haven't enclosed it in the quotation marks. Whenever I am referring to a variable, you will not enclose them in the quotation marks. The moment you enclose it in the quotation marks, what's really going to happen is it will consider it as a message that you want to print rather than the variable that you have created. So let's go ahead and see. So what it's basically going to do is the memory, whatever the contents of the memory location are, with the name 70 that you have given, that is what is going to get printed. So it should be printing the value 70. Let's go ahead and compile and execute and check that, please. Compiling, and you see that the value 70 gets printed, right? So now, before we go ahead and see what all we can do with the variable, let's first understand what are the rules for naming a variable. So One of the first rules is that the variable can begin with a letter or an underscore. The industry standard is to use a letter most of the times. And for the normal variables that we create, it's normally what it follows is it follows camel case. Now, since the second rule is not a must, the first rule is a must. The second rule is kind of an industry standard that is followed. If you see, I'm following a camel case. Now, what do I mean by camel case? The first letter is a small letter, and this next word that is there, it starts with an uppercase letter. That's the camel case that is followed over here. Then it can contain numbers. It can contain numbers, but it cannot begin with a number. So, for example, Rohan 007 is a valid variable. It can contain numbers. It's starting with a letter, but 007 Rohan is not, because it's starting with a number. So that's not allowed. And the next rule is it can contain only underscore. And even in the recent versions of Java, even the $sign is allowed in the variable names. It can contain the underscore and the $signs, but no other special character. No other special characters allowed. Now, what do I mean by a special character? No question mark, no exclamation mark, no space. Anything special character. By special character, I mean nothing except letters and digits. Everything else, I call it a special character. So none of them is going to be allowed. And they are case sensitive. Now, variables are case sensitive. What do I mean by that? So now if you see over here, I created a variable saying math marks. The M is small and the M is capital. If I try to go ahead and in my printing, I change my marks as small m, then if I run it, then you will get an error saying that, okay, I don't know which variable you're talking about on line number 4. Let's go ahead and see that, what the error is. Yeah, cannot find symbol. So that's what it is saying, and it's telling you which symbol it cannot find. It's on line number 4. It says, I can't find the variable math marks because you haven't declared it. So before you use a variable, the variable declaration has to happen. Since we never declared a variable with the capital M, that's why it is giving an error. And one of the final rules that is there is it cannot be any of the reserved keywords in the Java language. It cannot be a reserved keyword. So we have seen that int over here is a reserved keyword. In this editor, whatever you're seeing, whichever is highlighted in blue is a reserved keyword. What do you mean by reserved keywords? Is something which the compiler understands that has a special meaning in the Java language. So that means, are these all reserved keywords? Yes, they are all reserved keywords. Public, static, void, class, they are all reserved keywords. Main, on the other hand, is not a reserved keyword. So can you name a variable name? Main? Absolutely. Can you name a variable double? No, you can't. So these are the rules for naming a variable. And normally, your variables have to be very, very descriptive as to what kind of data that you are storing. One of the very common bad practices, I would say, that new programmers I usually see is they have variable names like A, B, C, X, Y, Z. Please don't have that, especially when your programs start becoming bigger. It's necessary to maintain that naming convention. So please go ahead and follow that naming convention. So these were the rules of naming a variable. Now let's go ahead and see how can we go ahead and print messages along with the contents of the variable. So over here, how we can do that in the print command. So I want to tell you, so this is the message I want to print. I scored 70. 70 is the value of the variable math marks in maths. If this is the message I want to print, so my code will look something like the system.out.print print or println, I scored. Now, plus. Plus is the symbol for concatenation. In simple words, it is used to attach or append. Right? So over here, whatever we write within the double quotation marks is called as a string. You will see that going ahead as well. That is attached with our variable over here. So our variable is of type integer, so I'm going to attach it to that. And I want to continue ahead with the other message. So I'm going to say plus again, and I'm going to say in maths. So what the output will be, I scored. Math marks is 70. So 70 in maths. So I'm going to go ahead and get rid of this line because I don't need this anymore. So I'm going to delete this for now. And I'm going to execute and check whether I'm getting the output or not. So let's execute and check. Compile. I scored 70 in maths. So what we have seen so far, we have seen what a variable is. We have understood how to go ahead and print the value of the variable. And over here, we have understood how to print the value of the variable along with the message, and we have seen the rules of the variable. Now, another concept related to variables is like, now, will the math marks always remain 70? Can we change it? Yes, we can. You can go ahead and change them any way you want. But remember that in order to do that, you won't write int math marks again. You just simply go ahead and give it a new value. So you have math marks is equal to say 45. What has happened is I'm going to go ahead and actually change that after this line. Yeah. And I'm going to print one more command. I'm just going to copy this line and I have now scored. So what happened was, in the memory, first, we had created a variable where math marks was, so in the memory, first time you declared the variable, and this is 70. Then you did the print command. When you referred to math marks, the compiler said, okay, yes, I know about math marks because you had created it first. So I know what are you talking about. I know which variable are you talking about. I know where to look at in the middle. I know that. So that's why it went ahead and it mentioned I scored. It found the contents. It was saying it was 70 over there. It went and printed that. Then it looked at line number 6. Over there, it says that math marks is equal to 45. So that means now the 70 went ahead and it changed. The contents of that memory location now changed from 70 to 45. So it is no longer 70. It has changed. Now I am going ahead and again referring to the same memory location, but now instead of 70, I'm going to find 45. So the first line will continue to print 70 because still line number 5, the value was 70, but on line number 7, you will see a changed value of 45. Let's go ahead and execute that and check. I have scored 70 in math, and the next time you see that, I have now scored 45 in maths. So this was all about variables and changing the value of the variables. And that's why the word variable, varying, it can vary. But the main meaning is it's nothing but a name that you give to a memory location. All right. So we have understood, we can create variables of different types. For int, for double, and for Boolean, we'll be looking at how do we create variables of all these types. All right. Now, let us go ahead and do some more processing with these variables, and we will understand the basic operators that Java has to provide. Now, let's go ahead and look at some of the most basic operators that the Java language provides. So one of the most important and the most commonly used one are the arithmetic operators. Now, which are these operators? These operators are very simple. They are plus, minus, multiplication, denoted by the asterisk symbol, or the star sign, as you can call it. The divide is the front slash. Very common confusion. Is it the backslash or the front slash? The front slash. And the next one is the modulus, which is the percentage sign. It doesn't calculate the percentage, it calculates the remainder. It's called as the modulus, calculates the remainder. Now, you can create variables and you can perform these arithmetic operations in them. So, for example, I can go ahead and I can create, let's go ahead and create some variables. Let me just type it out. All right, so let's go ahead and new repo operator. Say, for example, our problem is to go ahead and create two numbers and store those two numbers. Let's say English marks and your math marks. Go ahead and store those two numbers and go ahead and add them up. So that's the problem statement. So now one of the common practices that we do is that whatever program that you are writing, it is always a good practice to actually have the problem statement written in some form or the other as part of your program. Now, when you write that, you don't want it to be actually be executed by the code. It's not going to be plain English, right? So what you do is you give comments. And there are two ways of giving comments. One is a multi-line comment. That's what we're going to see now. So I'm going to go ahead and write that over here. Close that over here. So front slash star and star front slash. So whatever I write over here is a comment. And what I mean by that is these lines of code are not going to be executed or going to be considered by the Java compiler at all. So what I'm going to do is I'm going to write my question over here very quickly. So the program below is to add the English and the math marks obtained by a student. Now, this is what we are going to do. So what we will be doing is we will go ahead and create variables. So this is a comment. This is a multi-line comment. There's also a single line comment, which I'll be showing you very soon. Let's go ahead and start solving the problem. So I'm going to have the math marks. So I'm going to follow random case, just like last time. Math marks is 40. Now, even the English marks is of the integer data type. Since there are two variables that you want to create of the same data type, you can comma separate and you can create it. So you can go ahead and create another one over here and give the values English marks equal to 17. And you end the statement with a semicolon. If you want, you can also go ahead and create it in multi-line. So now what I'm going to do is I'm going to comment this line, the single line comment. So single line comment, only this particular line will get comment. So the other way of creating the two variables is math marks equal to 40, English mark equal to 7. Now, I want to go ahead and add the two variables that's stored in another variable called total marks. So I'm going to I'll have to first declare the variables in total marks. And either I can perform the operation on this line itself, or I can do it on the next line. So I'm going to just declare the variable, not give any value to it right now, and do the calculation of the other line. So I'm going to say total marks equal to, I'm going to add the math marks and the English marks. So I'm going to say math marks plus species for. So I use the arithmetic operators over here, the plus arithmetic operator to actually go ahead and print it. And I can go ahead and print a message saying that, okay, system.out.print. I scored a total of and total marks. So that's it. I don't want to print any other message after that, so there is nothing after total marks. To close the bracket of the print, and that is it. So now, if we go ahead and print it out, we will see that the output will be I scored a total of 110. That's exactly what it should be, because math marks is 40 and this is 70. So I can go ahead and change the value of the variable. Because I've written the expression in that way, the calculation will happen automatically when I run the program again, and you will get the updated value whenever you run it. So that's the advantage of creating a variable. You can change the value, and the rest of the code will automatically follow because you've used the variables in your expression and not the values directly. So this was the plus operator. So now let's go ahead and I want to go ahead and create another program using the multiplication operator as well. Say, for example, next one is that I want to go ahead and create a program. I'm going to write a multi-line for us to do that. So I don't want to be doing this. I can select these lines of code. I can comment this out for that because I've understood how this works. So I'm writing another question over here, the same one. Ideally, you would create a new file for doing this, but for same. So I'm going to initialize the length and the width of a rectangle, and I am going to calculate the perimeter. Okay. Now let's go ahead and create two variables. Length is 20, width is 15. Now the perimeter for rectangle is, if you remember the formula, it's 2 times length plus width. So I can do 2, then I can do the multiplication, and I can use the brackets just like how we use it in mathematics. I can put the brackets, and whatever we do within the brackets will be done first. So length plus. So this is an absolutely valid arithmetic expression. I can go ahead and I can print, say, perimeter is since I'm starting with the variable over here, so the variable comes first and then the plus and then your message over here. So let's go ahead and execute and check and compile the code. And yes, 70 is the perimeter. 10, 20 plus 15 is 35. 35 times 2 is 70. So yes, these are the arithmetic operators of plus. Similarly, you can go ahead and work with minus. Now, before we discuss the divide and the modulus operators, okay, it's very important for us to understand some nitty-gritties about the Java language. And this is one place where many students and many people actually falter in the Java language. I'm going to stop my share. All right. Now, there are two data types. The division operator, remember the arithmetic operators are normally used to manipulate numbers. That is what the purpose is. That's what we have been doing all our life in the world. However, there are two types of data that we have seen when it comes to numbers. One are integers, and the other one are the decimal values. So now let's understand double. Now the thing is, the integer data type, every data type, whenever you create a variable of a certain data type, it occupies certain size. The integer data type occupies 4 bytes of memory. 1 byte of memory, for everybody to know, is composed of 8 bits, where each bit can either store a 0 or a 1. Remember the binary form, the one that the computer understands. So total, an integer can store up to 32 bits. 32 bits is allocated whenever you create an integer variable in the RAM. 32 bits of memory is allocated. You can then go ahead and create another variable called double. Now the memory for a double is of 8 bytes. That means it's a 64-bit data type. That also means that double occupies more space than an integer. Now Java has some very clear rules when it is working with either the same data type of information or different data type information. Now let's consider this simple example. So I'll say, for example, I take a variable, say int num1 is 8 and num2 is 3. And if I do like this, int answer is equal to num1 divide by num2. Now, in the real world, when you do 8 divided by 3, when you use a calculator, you will actually get a decimal answer. However, Java has some different way of looking at this expression. Java says that if the operands or the data involved in the operation are of the same data type. Now, this is an int, this is also an int. The result will be an integer. It won't be of any other data type. Now, when you do 8 divided by 3, what will that integer be? If you remember in mathematics, you used to understand the concept of a quotient and a remainder or something like that. Simply 8 divided by 3. 3 goes into 8 how many times? 2 times. And it's 2 point something, something, something. So it's 2 whole times is what 8 goes in. So the answer of 8 divided by 3 will be 2 and not 2 point whatever. This is a very important thing. So integer by integer gives an integer. To reiterate the statement that I said, whenever an operation is done between data of the same type, the result will be of that type only. Of course, however, there is 1-2 exceptions to this, but not so important to know. But there is 1 or 2 exceptions. But majorly, it is always a result of that type only. However, whenever an operation is done on different types, the result is always the data of the higher type. Now, when I say the higher type is higher in terms of memory. So, an integer with an integer is going to give us an integer. An integer with a double is going to give us a double because an integer with a double occupies more space than an integer. So this is very important and very important for us to remember that. Now, so 8 divided by 3 gives us 2. Therefore, 7 divided by 2 will give us 3. 15 divided by 10 is going to give us 1. 4 divided by 20 is going to give us 0 because 20 doesn't go into 4 any number of times. I'm going to give 0 for that. Now, what if I would have written the expression something like this? So if I write double value is equal to 7 divided by 2. One of the common mistakes that everybody makes is that, oh, now I can divide and the result is being stored in a double. So the answer will be 3.5. Nope, it won't be 3.5. At the end, please note is first you need to focus on the right-hand side of the equation to focus on this expression. 7 is of the integer data type. 2 is also of the integer data type. 7 divided by 2 is going to give us 3, which is an integer data type. We are actually trying to store an integer in a double. Can I store integer which occupies less memory in a variable which occupies more memory? Absolutely fine. It's absolutely okay. I can store a tennis ball in a big bus. Absolutely fine. You want to store it in the big bus? Store it. However, can you store a basketball in a small tin container? If the basketball is huge, is bigger than the size of the tin container, the answer is no. So, the point that I'm coming to is I can store an int in a double, but I cannot store a double in an int. Double can't be stored in int. So that means if you try to do int value is equal to 8.2, you're going to get an error. Let's go ahead and actually check that, whether I'll be able to get that or not. Yes, I'm going to comment this line. Let's try that int value is equal to 8.3. You're already seeing the red mark over here, by the way. That means it's an error. Let's see the actual error that we're going to get. Incompatible types. Possible lossy conversion from double to int. Not allowed. Not possible. But on the other hand, if I do double value is equal to 7, absolutely allowed. There won't be any error. Nothing will be output because you're not printing a message also. It won't give any problem. It will compile and run automatically and no issues. That's very, very, very important for us to remember that. So the summary of this is a higher data type information can't be stored in a lower data type, variable, but the other way around is possible. But the other way around is absolutely possible. So two main things that we have learned so far. What can be stored in which kind of a variable? What kind of data can be stored in which kind of a variable? And whenever we do an arithmetic operation between two different or the same data types, then what's the result? So let's have a quick summary of whatever we have discussed and let's try to see some examples. So I'm going to say int value is equal to 8 by 4. I'm going to look at the right-hand side first. Integer, the answer is going to be an integer, which is 2. Can I store that in an integer? Absolutely fine. It is absolutely okay. Integer value is equal to 7.0 divided by 2. The moment I write a decimal point, the compiler will consider it as a double. Double, integer, two different data types, the result is of a double. 3.5. Can I store a double in an integer? Nope. It will give you the same error that you saw just now, the lossy compression, possibly loss of precision. Another example. Double answer is equal to 7.0 divided by 2. Yes, we saw that just now. It's going to give us a 3.5, which is a double. Can I store a double in AMS? Yes, 3.5. So what we see is in order to get a decimal value, whenever we want to perform a division, one of them has to be considered as a double. And of course, we also saw that we can also do double answer is equal to 7 by 2. It's integer, it's going to give us an integer, which is 3, which can be stored in a double. So the final answer is going to be 3.0. Just the 0.0 comes up because you are storing a double value. Very, very, very important when it comes to data types and the arithmetic operators. One of the most commonly made mistakes with the division operator.
Now we saw how do the double and the integer data type work with each other. Okay. And especially when you do the division operation, one way to get the answer as a double in the division operation is the fact that you have one of the data type, one of the values in the expression to be a double value. Now, so let's discuss another very important concept in the field of programming, and that concept is called as typecasting. Now, what do I mean by this expression? Just let's see, before I
explain to you the meaning of it, let's take an example. With an example, we'll be able to better understand. So over here, we have double val is equal to 7 divided by 2. We saw that 7 is going to be considered if you write an integer, if you write a number as on its own, it will be considered as an integer. If you write 2 on its own, it's going to be considered as an integer again. Integer by integer is going to give you an integer, which is 3. Now, so even though this is a double, we are going to get the answer as 3 or 3.0. We won't get the actual decimal answer, which is 3.5. Now we saw that, okay, one of the ways to do it is, okay, we make 7 7.0, or we make 2 2.0. So one way to do it is to get 7.0 divided by 2. So this is a double. This is an integer. Double divided by integer is going to give us a double, which is going to be 3.5. And I can store that in a double value. So double value is, instead of writing 7.0, the other way of actually going ahead and obtaining decimal answer is to tell explicitly the data type you want it to consider. You want what to consider. Now let's write the expression again. So you have double val is equal to 7 by 2. By default, 7 is going to be considered as an int. But we want 7 to be considered as a double. So in that case, what we do is we explicitly mention the data type within the curly brackets. How do we mention that? We mention it like this. Within the brackets, we write double. What we are doing over here is we are typecasting 7. We are explicitly mentioning the data type for the expression that we want it to consider. We want 7 to be considered as a double just for this expression, so this will be considered as a double. This will be considered as an integer. Double divided by integer is a double. We will get our 3.5, and which is a double. And can I store a double in a double? Yes, I can. So 3.5 will be stored in val. Let's take another example. Say I have a variable of type integer, say int say val2 is equal to say 10. Now, if I want to calculate val2 is how much, what is the fraction of 10 over 25, for example. So I am writing the expression like this. If I write double val3 is equal to val2 divided by 25. Now, over here, val2 is an int, which is 10. 25 is also an int, which is 25. So now, 10 divided by 25, since 25 doesn't go any number of times, the answer we're going to get is an integer. We don't want that. We want val2, which is an integer, just for this expression to be considered as a double. So we can go ahead and we can typecast it to a double. So space between the double val2 divided by 25. So the answer will be 10. The actual value of 10 divided by 25. This is nothing but, I think it's 0.4. Because now it will be considered as a double. 25 will be considered as an integer. Double divided by integer still gives us a double. Will the typecasting only work on values? Will the typecasting only work on variables? No, the typecasting can work on expressions as well. For example, if I write something like this, I have int answer is equal to 7.0 divided by 2. Now this answer, I'm writing int over here like this in the brackets. What I'm telling here to do is I want to typecast the answer of the expression. So 7.0 divided by 2, 7.0 is a double. 2 is an integer. This is going to give us a double, which is 3.5. But we are telling it to please consider this answer as an integer. So this answer will be considered as an int. And it won't be 3.5 now, it will be considered as 3. And the value 3 will be stored in AMS. So typecasting, what exactly is typecasting? Is explicitly mentioning the type, explicitly mentioning the type to a constant. Remember, 7 is a constant, 7.0 is a constant, 25 is a constant. To a constant, a variable, or the answer of an expression. On the right hand side of the equation. Remember, this is not on the left hand side, it's on the right hand side of the equation. So explicitly mentioning the data type for that is an example of typecasting. I mean, this is something which is used very commonly and has more usages also in object-oriented programming that we are going to see ahead. Now, let's take an example of how we can go ahead and use the concept of typecasting. Now, this is the same window where we had seen the other program. So I'm going to go ahead and try doing one more program over here. So now the question is, okay, that what we have to solve. Okay, we have a multi-line comment here. The question is, we have to initialize the base and height of a triangle. Initialize the base and height. And it has been given to us that they are integers. So the values are integers. What we need to calculate is the area of the triangle. That's the aim. Now the thing is over here, if you remember from mathematics, the area of a triangle is base into height divided by 2. Now this is an example where it is possible that your triangle can be a value which is, if the base is 7 and the height is 7, your value can be decimal point 24.5. But the thing is over here, base and height are both are given as integers. So how do we go ahead and make sure that we do get a decimal value at the end? Now let's first see what happens. I'll go ahead and say base is 7, height is also 7. And I go ahead and calculate the area as base times height divided by 2. If you want, you can put them in the brackets as well. Now, if you observe, everything in this expression is an integer. So 49 divided by 2, it's not going to give me 24.5. It's going to give me actually just 24.0, right? Because everything is an integer. So integer by integer, remember, is going to give us an integer. Let's verify our answer for the area. Let's go ahead and check that. It's compiling 24.0. We really wanted to do 24.5. So the thing is, in this expression, even if one of them gets considered as a double, either the base or the height, then our problem is solved. Because double into anything is going to be a double. And then whatever the answer we get is a double, divide by, even though it's an integer, we will still get a double. So what we're going to do is we're going to do the concept of typecasting. So over here, I'm going to typecast base to a double. Now let's go ahead and run and see whether we're getting a proper answer or not. So now base is going to be considered as a double, which is 7.0 now. 7.0 into the height, which is also an integer. Double into integer is a double. The whole divide by int is going to give us a double. So an example of how we can go ahead and use typecasting. Now, you have to be very careful over here as to how you use the typecasting. Now, what if instead of writing like this is the right answer, I'm just going to comment it so that we can come back to it. What if you write something like this? So you have to be careful of how you use the typecasting concept and you don't typecast the wrong thing. So in this case, I'm going ahead and say I write W. And I typecast the answer of this entire expression. So I calculate base into height by 2, and then I typecast. The problem here is, while the division is actually happening, the thing is already done. The precision is already lost. So you're still going to get 24, and the 24 will be considered as 24.0. So this is an example. Now let's go ahead and check whether are we getting 24 or 24.0 or 24.5. So we're still getting 24.0. So this is an example where you have to be careful. What are you typecasting? Are you typecasting a value, typecasting a variable, or typecasting the value of the entire expression? Very important concept and used quite heavily. So this is all about typecasting. So this is the right answer. So I'm going to comment this out. I'm going to run it once again so that we have the right answer on the board. So for arithmetic operators, plus, minus, multiply, and divide. Divide, very simple. Plus, minus, and multiply, very simple, very straightforward. The divide, how it works with integer and the double data types, that's exactly how we are doing. It's only, is it with integer with double also? No, integer with float, you follow the same process. The same thing you have to be aware about, how the typecasting works, how the decimal point works, and everything, all of that stuff. Okay, so these are the things which you need to be very careful about when you're working with the arithmetic operators, especially the division side. Now, let's go ahead and let me share my screen again and let's discuss the other arithmetic operator, which is the modulus operator. The modulus operator has a lot of weightage. It has a lot of usage as well in a lot of programming constructs, and especially if you do intend to get into competitive programming or any other programming aspects, you will see a lot of mathematical solutions will be involved using the modulus sign. So, and the modulus sign, although in Java, can work with decimal points as well. Primarily, it is used with integer data types. So now, over here, how does the modulus sign really work? Let's understand that. 7 modulus 2 is over here is, what is the remainder when 7 is divided by 2? The remainder over here is 1. And if you go from your basic mathematics, this is 7, this is 2. 2 goes into 7 3 times. So the remainder here is 1. The important part to notice is you don't really go to the decimal part. You don't enter the decimal part at all. And you stop before the actual decimal answer comes in, and you see the value that you get before that. What's the remainder when 15 is divided by 3? There is no remainder, so the answer in this case is going to be 0. What's the answer when 27 is divided by 10? Then in this particular case, the answer will be 7, because 27 goes into 10 2 times with the remainder of 7. The next thing is, what is the answer of 5 when divided by 10? The answer of that is going to be 5. Now, why is it going to be 5? The thing is, okay, this is 5 and this is 10. 10 does not go into 5 any number of times. So 10 zeros is 0. And that's why the remainder is going to be 5 itself. Now let's go ahead and look at a program where we can actually use the division, the modulus operators. Let's go ahead. Let me share my code editor once again. Let's look at the variable once again. Now, so this was the area. This was all about the area and the triangle and the forming this code again. Now, the next thing is, let's take, this is a simple example where what we are going to do is we're going to initialize the distance in centimeters. So now, once we initialize the distance in centimeters and we want to express it in, we want to find out the distance is actually how many meters and how many remaining centimeters, for example. Now, what do I mean by this example? Let me explain it with an example. So, for example, if the centimeters is 793, then 793 centimeters, we know that 1 meter is 100 centimeters. So 793 centimeters is actually 7 meters and 93 centimeters. If it is, say, 835 centimeters, is 8 meters and 35 centimeters. So what we need, what is given to us are these values. What we intend to calculate is the whole meters and the remaining centimeters that is there. We know that 1 meter is 100 centimeters. We know that. So if we are given, if it's given to us that centimeters is an integer, so what we're going to do is we're going to initialize CMS as an integer. So we're going to say 895. Then in order to calculate the meters, this is nothing but to get the whole meters. What we're simply going to do is we're going to do CMS divided by 100. How many whole meters can we get? And we know that integer by integer is already going to give us an integer. It's not actually going to give us the 8.95, it's actually going to give us the 8 itself. So the division operator, you see the advantage of using the division operator when everything is an integer. It will give us the whole meters in this case. Then the remaining centimeters is nothing but, in this case, it's going to be CMS, the remaining centimeters after dividing by 100. So it's a perfect candidate to use the modulus of this CMS modulus 100. So over here, then I'll simply go ahead and print it. So system.println. And if I want to put it in the fashion that I have written on the board, so then you can say CMS plus CMS, and give some spacing, is equal to over here meters plus n plus the remaining CMS plus n. Let's go ahead and verify our code whether it's actually giving us the right answer or not. We are supposed to get 895 centimeters is 8 meters and 95 centimeters. So 895 centimeters will be 8 meters and 95 centimeters. Let's go ahead and try with some other number. Say 1, 2, 4, 5 centimeters. That is, should be 12 meters and 45 centimeters. That's 12 meters and 45 centimeters. So this is an example of the modulus operator. So we have seen the arithmetic operators, and we have seen how the arithmetic operator, especially the division one, how it works with the different data types, and we have seen the modulus operator. Very helpful and can be used a lot. Now, a quick question will be, how do you actually access, how do these operators work together? If they are all appearing together, who will be solved first? One of the very common misconceptions is that, oh, you have the BOD-MAS rule. Yes, it is kind of the BOD-MAS rule, but it's not exactly the BOD-MAS rule. So you have plus, minus, multiplication, division, and the modulus operators. These operators have the same first preference. They all have the same preference. And if they appear together in an expression, they are going to be solved left to right in the order of appearance in the expression. Then the plus and the minus are going to be solved. They have the second preference. And again, if they appear together, they will be solved left to right in the order of appearance. So let's see an example. Let me explain it with an example expression. So if you have something like this, you have an expression 7 plus 50 times 2 modulus 4 minus 3 times 3. Okay. Now, some people say that, oh, the modulus will be solved first. No. Multiplication and the modulus have the same first preference. Whoever comes first is solved first. In this expression, who's appearing first is the multiplication sign. So in this expression, the multiplication sign comes first. So that is why it will be 7 plus 30 modulus 4 means 3. 30 modulus 4, the remainder when 30 is divided by 4 is 2. 7 plus 2 minus 3, which is nothing but 7 plus 2 is 9. 9 minus 3 is going to, that's what's going to be the answer. Another expression that we take over here, 9 plus 15 divided by 4 into 2 plus 1. 15 divided by 4. Both are integers. The answer will be integer. 9 plus 3 times 2 plus 1. 3 times 2 is 6. 9 plus 6 plus 1 is 15. 15 plus 1 is going to give us 60. So these are our first set of operators in which we not only saw the operators, we also saw how the integer and both the numeric data types work with each other. Remember, float works very similar to double. The only difference is the size. And whenever there's an operation between int and float, float is the answer. Very, very, very important. And these were the arithmetic operators. Now, let us go ahead and look at the next set of operators, which are used very widely in programming, in Java programming, are the relational operators. Now, which are these operators? The relational operators are greater than, less than, greater than or equal to, less than or equal to, equal to, equal to. Please note it's the double equal to, not the single equal to, and the not. Relational operators, as the word recommends, is actually going ahead and calculating it's basically finding the relation between the two sides. Now, what is the result of the relational operators? The result of the relational operators is the data type, which I said earlier that we will be visiting, is the Boolean data type. So let me give it an example over here. So we have it num1 is 15, num2 is 20. And if I write the expression as Boolean, answer is equal to num1 greater than num2. If the expression is satisfied, if the expression is correct, then the answer generated will be a true. If not, then the answer generated will be a false. Is 15 more than 20? No. Then the answer will be false in this case. Let's take another example. So similarly, if we go ahead and write that for all the other examples as well. So Boolean, if I do answer 1 is num less than num2, the answer will be true because 15 is less than 20. The next one is if it is num less than or equal to num2. This is Boolean answer 3, answer 2. If also, then the answer will still be true because it will give a true if it is less than or equal to. Then the other one is if it is num is greater than or equal to num2, this will give us false because it's neither greater than nor is it equal to. And store it in answer 3. Boolean answer 4 is equal to num not equal to num2. Yes, num is not equal. It's exclamation mark equal to. It is not equal to. Yes, num is not equal to num2. So the answer is true in this case. And finally, is num equal to num2. Store it in other variables between answer 5. Is num the same as num2? Equal to. Please note it's not the single equal to, it's the double equal to. Very common mistake that happens when many people are coding. They use single equal to instead of double equal to compare the two sides. It's this double equal to. And the answer in this case is false because the 50 is not the same as 20. Now, These are the relational operators. Now, what if the expression is containing both relational operators and arithmetic operators? Let's see the example of that. So over here you have int val is 5, and now over here you have val plus 2 is greater than val minus 4. You have the arithmetic operators over here, and you have the relational operators as well. Logically, what we can look at is, okay, the addition and the subtraction will be done first, and the result of those expressions will be then compared. So the answer in this case will be a Boolean answer with the arithmetic operators having more preference than the relational operators. So val plus 2 is 7 is greater than 1. 7 is greater than 1. The condition is satisfied. So the answer is going to be true in this case. One of the many common mistakes with relational operators is that many people try to attempt to chain relational operators. For example, if somebody says take the value 10 and you're supposed to generate a true value if the value is between 5 and 20. So one of the common mistakes that is made is over here is people write an expression like this. So you have val as 10, and if you write Boolean answer is equal to val, so 5 less than val less than 20. Now, this expression is going to generate an error. The compiler is going to complain. What is the complaint going to be all about? 5 less than val, this is going to generate a Boolean. What we are trying to compare is a Boolean with an integer, which is not possible, which is not allowed. You can't compare a Boolean value with an integer value. However, please note, in a language like Python, this expression would work and it would do what you think it is all about. Is val between 5 and 20. It will work absolutely well in Python. But in Java, goes by the rules, goes by the books, it is not going to work and it's going to generate an error. So, a quick recap. We have seen arithmetic operators and now we have seen the relational operators. How do we go ahead and use the relational operators? We will see that very soon. Now we will be going ahead and looking at the next set of operators called as the logical operators. Now, let us go ahead and look at the next set of operators which are used quite widely, and they are the logical operators. So we have the logical. Now, which are the logical operators? There are three main logical operators. They are and, or, and not. The and, or, and not. That's what the words are, and, or, not. Please note there are some small variations also to these operators. There's little variations to these operators, a few more logical operators as well. What I'm focusing on are the ones which are used a little bit more widely. There's also another operator called as the XOR. This is not the power operator, it's the XOR operator. Now, logical operators, what they do is they work on Boolean and they give result as a Boolean. They work on Boolean data and they give this and as a Boolean. Now, so if you are aware of logic gates, so those who are aware of logic gates in the concept of electronics, they will be able to associate with the logic gates that are there. If you're not aware, no problem. So how does the AND really work? So it's quite intuitive, it's quite straightforward. The word is AND. AND says, and since it works on only on Boolean data that means both the sides of the operator, it can be either true or false. So AND says that I will give the result as true only when both the sides are true. Otherwise, I will give the result as a false. That means the left-hand side is true and the right-hand side is true. That's why the word and. Okay. So let's see an example as to how you can do that. So over here you have, say, Boolean C1 is equal to true, and I have C2. You can create Boolean variables and you can give values to them directly like this as true or false. And Boolean C2 is equal to say false. And then what you can do is Boolean answer is equal to C1 and C2. Both the sides are Boolean, so this is a valid expression. Since over here, one of them is a false, the answer A1S is going to be a false. So if C1 was true and C2 was true, the answer would have been a true. Any other combination of C1 and C2 would have been given as a false. Now the thing is over here, it works with Boolean, but how do we really form expressions with the AND operator? Let's take another simple and a real world example. Say, for example, I want to generate a true. There's an integer which we have. I want to generate a true only when the number is, say, greater than 5 and it is not 30. So the way we will write this expression is so Boolean result is equal to the number is greater than 5. So val is greater than 5 and the value is not equal to 30. Now over here, if you see, there are two sets of operators that are coming into the picture. One are the relational operators and the other is the logical operator over here, which is the AND. Now if you look at the expression, the thing is the AND cannot work on 5 and val, right? Because they are integers. And we just saw the logical operators work on Boolean. That means this probably would have to be solved first. So that is an inherent precedence that always happens, is that the relational operators are solved before the logical operator. So val greater than 5, in this case 10, is 10 greater than 5? Yes, it is. So it will be true. And this expression is also going to be generating a true. So true and true is true. So the final result is a true. That's how the AND operator works. So if there's a relational operator and a logical operator, the relational operators are done first. And we also saw that if there's an arithmetic operator and a relational operators, the arithmetic operators are done first. So the overall order goes in this order: arithmetic followed by relational followed by the logical operators. Similarly, now how does the OR work? And OR says either or both the sides are true. I will give a true either when either or both sides are true, the result generated would be a true. Or, right? Either this is true or this is true, right? Even if both are true, still it will be true. The result generated. So this is the OR operator over here. Yeah. Now, then let's look at NOT. NOT. How do we use the NOT operator? The NOT operator, unlike the other operators, is actually a unary operator. It works on only one piece of information. So NOT of true is actually a false, and NOT of false is actually a true. Not true is nothing but false. So let's see an expression which involves the NOT operator. So you have int val is equal to 4. And if I write like this, Boolean answer is equal to NOT of val greater than 2. And I put this in the brackets. So the thing is, what I am saying is val not greater than 2? That's how you say it in English. So the thing is, over here we solve this brackets first, since it is within the brackets. So 4 is greater than 2. This condition evaluates to a true, and NOT of true is ideally a false. So this expression is going to give us a false because it's not true that 4 is not greater than 2. So that's how you can say. So that is false. So we have seen the relational operators and the logical operators. Now, how do we actually go ahead and use these operators in our programs? How do we solve different kinds of questions that are there? There is something called as a ternary operator, which employs the relational and the logical operators. And there's also something which we'll see going ahead as the conditional statements like if, when, if, else. So now let's go ahead and understand what the ternary operator really does. Now let's go ahead and look at the ternary operator first, which uses the relational and the logical operators, and how can we use it to solve programs. So I'm going to share my screen. So now the thing is, now say for example, if I give you the age of 2 students and I ask you directly which student is whose age is more, or print out the age of the student whose age is more. So that's the question. So I'm going to quickly go ahead and write the question as a problem, as we have seen always. This is the question. Print the age of the elder student amongst 2 students. Okay. So I'm going to create 2 integer variables. I'm going to say student 1 age. I'm going to say 15, and student 2 age 22. Okay. So now we should be able to write a program which should be able to generate the height. Of course, now over here we know it is the second one has the 23 is the one which is more age. So the thing is, how can we use the ternary operator and how does it look like? I'm going to write an expression and then we will see student 1 age. If student 1 age is greater than student 2 age, then student 1, student 2 age. So now let's try to understand what have we done over here first. Before we complete the program, let's try to understand what's really happening. Over here, the ternary operator is this operator over here. So the ternary operator looks like this. You have an expression, question mark, an expression again, a colon, and an expression again. This is an expression which is a conditional statement. And this conditional statement is the statement which is over here, which should be generating a Boolean value. And we just saw that the relational operators and the logical operators can go ahead and help us generate the Boolean values. I'm going to comment this out for something. So what are we going to have is I'm going to have expressions which is going to generate a Boolean. And then if this Boolean value generates to a true, then it will do whatever is written after the question mark and before the colon. This has to be an expression and has to be generating a value. Any value it can generate, but it has to generate some value. If this is true. If this evaluates to false, then whatever is written after the colon is going to be stored. Now, why is it called ternary, or some people call it tertiary? So something is ternary, conditional operator. That's the other thing that is there. Over here, ternary, because there are 3 things involved over here. One is your condition using the relational, arithmetic, and logical operators. The other one is an expression, which is the second one, and there's another expression over here. Total of 3 things getting involved with the question mark and the colon being there between. So now, if I look at this expression over here, I have students. So what I'm doing is I'm checking if student 1's age is more than the student 2's age. If student 1's age is more than student 2's age, then my answer is going to be student 1 age. So in my expression after the question mark, I just am writing student 1 age. The reason why I'm just writing student 1 is because that's the age that I want. That's the age that I'm interested in. Does it have to be only a variable? Not necessarily. It can be anything over here. If the condition is not satisfied, then my answer is student 2. So that is, I will get the answer over here. So now let's go ahead and just print out our older age in this case, and let's see if I'm getting the one with the older age. Just for now, printing older age. Just an understanding. It's compiling the code, and it's 23. Whichever is older, I got that, because 15 greater than 23 is false. So I'm going to go to student 2 age. Whatever the contents of student 2 age are, I am storing it in older age. Now let's try to flip around and see whether it still works or not. So this is sample maybe 25 and it's 23. We should get the answer is 25. Let's go ahead and verify that. Yes, we do get 25. So using the ternary operator, we did this. So we did this using the ternary operator. Now, let's go ahead and see one more usage of the same operator. So this entire piece of code, I'm going to comment in this piece of code expression, and let's go ahead and solve another expression. I'm keeping the yellow annotation as it is so that it's there for your reference. And then let's discuss about the next question. This is there. So for example, I have to decide that, okay, that I am a store, and I have to decide that, okay, how much discount do I want to give one? Now let us go ahead and solve the other questions. I'm writing the question over here again as well. So the question is over here. We have to, given the price of the product, we have to decide the final price of the product based on, we're going to give some discount. Given the price of the product, so we say give a discount of 100 rupees if the product is, say, less than 5,000 rupees. Otherwise, we give a heavier discount. We give a discount of 300 rupees. So we need to go ahead and calculate the final price of the product. So now, if this is our question, so let's go ahead and take some integers once again. All right. So please note, I'm showing one way of doing it. You can also come up with your own logic and solve the problem. So here I have int product. For now, giving it some random value, 1,500. And now I'm saying that the final price over here is going to be, if the product price is less than 5,000, as mentioned in the question, then the final price is, you're going to give a 100 rupee discount. So that means it will be the product price minus 100. As I said, you can write any expression over it. This is an arithmetic expression which is generating a value. Otherwise, goal, if it is not less than 5,000, then I'm going to go ahead and give the value as product price minus 300 rupees. So now, and then what we simply do, we simply go ahead and print the value over here. System.out.println finally. So in this case, we're going to get discount of 100 rupees. So the final price should be 1,400. So let's go ahead and verify whether we're getting that answer or not. We verify, yes, we are getting 1,400. Now let's say another example. Say if it is 6,500, we should get a discount of 300 rupees. We'll go ahead and execute that. And that is 6,200. So as I mentioned over here, you can use an expression, any expression in these, in the place between the question mark and the golden and after the golden as well. So these are the simple usages of the ternary operator. Now, what we will The question is over here, is it necessary? You can have any other expression as well over here. Now, let's take another expression. Say, for example, if I want to find the greatest amongst, say, three numbers, if that is our requirement, then what I can do is I can also write like this: int num1 is 2, num2 is 5, and num3 is 6. Now, if I want to find the greatest, what I can say is that, you know what, first I'll compare num1 and num2. So over here, num1 is greater than num2. Is num1 greater than num2? Okay. If num1 is greater than num2, then what I'm going to do is I'm going to compare num1 and num3, and then whichever is the greater among those two, that will be the answer. Now, between the question mark and the colon, I'm going to go ahead and another expression. So num1 is greater than num3. Yes, if it is, then another ternary operator expression will be num1 or num3. And this is this. So what will happen if num1 is not greater than num3? Then in that case, I have a colon, and then I go ahead and write. This time I will compare num2 with num3 because that is the greater one. And since our aim is to find the greatest, I have to keep comparing the greater ones. So num2 greater than num3, so num2, otherwise num3. So this is the one, and then I can go ahead and bring the greatest. So now again, I'm going ahead and going to copy this code, and then I'm going to run it. So I have num1, num2, num3. This piece of code does what? It simply finds the greatest amongst three numbers. It gives us the answer that the greatest is 6. Now, we saw what ternary operators are. So ternary operators help us do some basic simple comparisons, and on the basis of the comparison, we can produce different outputs. So ternary operators are normally used in the field of programming to make simple comparisons like the ones that we saw, where statements could be written in a single line. For much more complex ones, like for the example that we saw last was the greatest one, the expression became a little bit too complex. For something like that, you don't usually use the ternary operator. You use something called as a more versatile one, which is the if and the if-else statements. So now let's go ahead and see what are if and if-else statements. Now, say for example, as the word suggests, if and if-else, if statement, if some condition is true, then do something. So let's take this example over here. I have a value over here, int value is equal to 5. And what we are saying is, if, and then in the brackets, you write a condition again, just like with the ternary operator, this condition should be generating a value. So if the value is greater than 5, then you will print that system.out.println. This is going to be printed when value is more than 5. I'm going to put a semicolon. Please note after the if condition, there is no semicolon over here. So basically what we are saying is if the condition gets satisfied, then go ahead and print this message. In this case, my value of val is 5. Is 5 more than 5? No, it is not. The condition is not satisfied. So that means line number 6 won't be executed. That means when you run the code there, you shouldn't be seeing any output. Let's go ahead and verify that whether we see any output or not. Compile the code, run the code, there's no output because the condition is not satisfied. Now let's go ahead and add another make values 25. In this case, the condition is satisfied. So I'm going to go ahead and check whether we're getting the message or not. Yes, this is going to be printed only. The value is more than 5. Yes, it is more than 5. 25 is more than 5, and that's why the statement gets executed. Very simple, just if. Now, what I'm going to do is I'm going to comment this piece of code and copy it again. so that we can reuse it for learning another thing. What we are going to do is I'm going to uncomment this with the if statement in Java. Only with the if condition, only one statement is associated. What do I mean by that? If I write another print system.out.println, okay, you might get a feeling that both these statements are associated with the if. No, that is not true. Only and only the first statement is associated with the if and not the second statement. Only the execution of this statement only is associated with the if. The spacing or the indentation doesn't matter. It does not make a difference, unlike in a language like Python, where it makes a difference. But in Java, it doesn't make a difference. So that means the execution of line number 12 has got nothing to do with the condition. That means execution of line number 12 will happen always. So even if the condition is satisfied or not satisfied, we are going to see the line number 12 to be done always. Let's verify that. If it is satisfied, then value is 25. Let's go ahead and execute it and check whether we're getting the output or not in this case. So yes, this is going to be printed when the value is more than 5 and we get OK as well. And let's take it as 5. In this case, the condition is not going to be satisfied. So in this case, we should just be seeing OK. We won't be seeing line 11, but we'll see that's what we get. Now the question comes, how do we go ahead and execute more than one statement with the if? I want the execution of both line and 12, 11 and 12 to be associated with the if. The answer is to use the curly brackets. Now, how do I use the curly brackets? Now, that's very simple. I open the curly brackets here. If you see the corresponding close comes automatically. So I'm going to close it after this particular thing. And if you see, a good editor will highlight the corresponding opening bracket also so that it's clear for you to see how the things are flowing. And the other thing is also within the curly brackets, it's good to give some indentation only for visual understanding and clarity for you whenever you create large programs. Now, both the statements have become a part of the if. So since in this case, 5 is not more than 5, none of the statements will be executed since they both are a part of the if. So then there's nothing else that we have written. So there will be no output now when we run the code. Now it's no output, and when we run for values 25, we're going to see that yes, there is going to be an output. 25 is more than 5, and since both statements are associated with the condition, both statements do get printed. So this is about if. How many statements with the if, how the condition is formed with the if. Of course, you can form the condition not only just using the relational operators, but the logical operators as well. And now we are going to look at another very important variation of if is if else. If with an else. If the condition is satisfied, do something, else do something else. Say, for example, now this is a very common problem that you will see in programming. Let's take this. So we have to take a number and print whether it is odd or even. Now, which are the odd numbers? Or what are even numbers? So even numbers are numbers which are a multiple of 2, which are divisible by 2. The numbers which are divisible by 2 are the numbers when you divide by 2, they do not leave any remainder. That means when you do the modulus with 2, the remainder is turning out to be 0. So the way I'm going to write this thing, I'm going to first declare our numbers. Number is 24. And I'm going to say if number modulus 2 is equal to 0. If the remainder is turning out to be a 0, since there's only one statement going to be associated, I don't need the curly brackets. But if you want, you can still put them. I'm going to put that on this. It's a good practice, by the way, to just have it so that it's clear for you. System.out.println. Even if the condition is not satisfied, that means else. Remember, else does not have a condition. Else is just else. Else as if else means that if the condition is not satisfied, what should I do? This is similar to how the terminal operator has system.out.println part. Now let's go ahead and execute and check for 24. My answer should be even because then I'm going to divide 24 by 2. The remainder is 0. Please note, divisibility check. The modulus operator always comes to a rescue. This is even. 24 is even. And let's look at 27. 27 is going to be odd. Compile the code. And it's compiling. Oh, yes, it is odd. With the else, again, just like with the if, only one statement is associated. If you want to associate more than one, you put the curly brackets, just like how we discussed from lines 10 to 13. Now, we can have some more complex codes with if and else as well. So we can have an if, else kind of a structure as well. Let's take another example for that and let's see how will that work. So, for example, the question is that given a number, you are required that you need to print if the number is a 0, a positive number, or a negative number. So that's the requirement. So I'm going to write the question very quickly. Given a number, print whether the number is positive, negative, or 0. Now, what are positive numbers? All the numbers which are more than 0 are positive numbers. So, very simple. You want to first have a number again. Let's say 5 in this case. If my number is more than 0, then I'm going to simply say, I'm not going to put the brackets this time. If you want, you can put it also. Since there's only one statement, it doesn't matter. It's a positive number. Now, else. Now, the thing is, if it is not positive, then I would like to check if it is 0 or not. That means, again, I need to have another checking. That means another if. So, else if number is equal to 0, then system.out.println the number is 0. If it is neither positive nor 0, that means it's an else. Else, I simply say that the number is negative. You can be sure that the number is negative. So in this case, what really happens is the first if condition is checked, and then if the condition is not satisfied, then the else if condition is checked. So the second else if condition will be checked only when the first condition is not satisfied. If line number 31 is not satisfied, then it goes to line number 32. And when line number 32's if condition is again not satisfied, then only this line number 35 is satisfied. So very quickly, let's go ahead and run the code and check. For 5, since the first condition itself is satisfied, it won't go ahead and check the other conditions because we did else. So that means now let's check for negative 5. Negative 5, the first condition is not going to be satisfied. The second condition is also not going to be satisfied. And that's why it goes in the third condition. And of course, the 0, we will see the second condition will get satisfied. And then we're going to go ahead and get back to the number is 0. So, very versatile, very widely used. You can nest them in any order, in any way, and then you can go ahead and write much more complex programs with if and if else as compared to the ternary operators. Almost always there in majority of the codes that you usually write for the industry. Next, what we will do is we'll go ahead and quickly have a brief overview of the switch statements.
All right, now let's go ahead and look at another set of conditional statements. We have seen so far ternary statements, which allow us to write if-else kind of structures in a single line with the help of the question mark in the colon. Then we have seen the if-else statements, which are more versatile in nature, allow us to write much more complex conditions. And now let's look at switch case statements. So I'm going to go ahead and share my screen. Okay, create a new record over here. Switch case statements. Now, the switch case statements are almost like the if-else statements. Now, let us take this example. So, for example, you go to a restaurant, okay, and in the restaurant, the theme goes like this. You have every dish that you want to order as a dish number, okay. And now, say, for example, over here, dish number one, I'm writing that as a comment over here. So, assume that dish number one corresponds to masala dish. So dish number one is masala dish. Dish number two, say medu vada, for example. Dish number three is biryani, for example, right? And there are many such options like that. Now, if I tell you that if you give the dish number, what is the corresponding dish that associates with that dish number? And many times when you actually go and observe how the servers at the restaurants really, when they prepare your bill, they don't really, very few times they really write down the entire dish name, or even they write a certain code associated with the dish, and then it comes up on your on their bill. So I'm going to assume the code is like an integer right now. So over here, I'm going to create a dish code. And then I'm going to say that, okay, assume that the dish code is, so if I write down, say what? If I had to do this program using if-else structure, the program structure would go like this. It's the if dish code one, then I have only one statement associated, so I'm not going to put the semicolon. So I'm just saying system dot print and then else. If this is an else structure, because it can be one or two or three. So I'm going to say two and system again. I'm just going to quickly copy paste this code. So let's go ahead and write that. I'm going to say this is appropriate and save dish code 3, and then based on whatever other dishes are there, you can have many more if-else statements. Now, if you see, the condition that is used in the if is an equal to condition, right? If dish code is this value, or if it is this value, or if it is this value. For something like this, Java has come up with another construct using the switch case. Now, how can you work with switch case? So instead of you writing the code like this, what you could do is you could write switch, and over here you switch dish code. Now, if you switch dish code, now what can dish code as an expression can take values? What values can it take? It can take, so those will be your respective cases. So I'm going to say case 1. And I'm going to say that, okay, this is the case of masala dosa. Then I'm going to have another case. Now, the other case that can be there is say case 2. Now, this can take the value over here. This is and then there can be another dish code. So case 3, that's another thing which can be there. So over here, this will be biryani. Now,
Assume that there was one more dish, but I just had one more dish only for our understanding. Say if there was a dish code of 8, for example, is equal to 8, and that was over here, say, sada dosa. Okay. So that's what it's there. So the dish code can take one more example. This case 8. Then this is the thing. Now, this is a similar structure and does the same work as what the previous code does. Now, how does the switch case really work? Let's understand that. Let's understand the nuances of switch case over here. Switch over here takes an expression. This expression has to generate either an int or any version of int, byte, short, or character, or in some of the latest or newest versions of Java, it also allows for strings. That's it. It does not allow for any other value to be generated. You can't generate anything else. If over here required a condition which allowed us to create a boolean, whereas switch over here wanted us to generate an expression which is either int or char or strings. The cases are designed in such a way that each of the cases generate a possible value that your switch expression can generate. Your cases over here, the values of the cases over here, dish code just by itself could either be 1, 2, 3, or 8, the example that we have taken. So over here, that's why my case values are also 1, 2, 3, and 8. These things with the case can only be constants. And again, these constants, based just like with the if, can be either integer, character, and version of the integer, or string constants only. That means it can't be variables, it can't be expressions, it can be constants and constants alone. Let's understand the working of this particular thing. Now, I'm going to put one more thing in between the cases, and that thing over here is somebody as the break. That's another keyword. What is the purpose of break? Something which just write this thing down. Do I need the break after the last case? Not really. Why we don't need it? Let's understand. Now, let's look at the if-else code first. If you look at the if-else if code, if the dish code is 1, then it is going to print just masala dosa, and that's it. The other conditions are not going to be looked at because they are all else ifs. In the case of switch case, what's going to happen is, say for example, if in this case the dish code value is 1. So when the dish code value is 1, it is going to look for the corresponding case. When it looks for the corresponding case, it starts with line 24 and say that, okay, the case value over here is the actual value of the variable. Now, since this case value is satisfied, what it really does is from line 25 onwards, it keeps on going till the end of the switch, until and unless you explicitly stop the flow of those statements. And the way you stop it is by using break. That's why this break is a must if you want only this statement to be associated with the. So now, if dish code is 1, I'm going to go ahead and print this. So over here, you will see 2 outputs over here. One coming because of the if-else, and the other coming because of the switch case. So I'm just going to write for us to understand that this is coming because of if-else. I'm just going to write an if over here so that it's clear. It's happening because of the if. This is happening because of the switch case. I'm going to just quickly write C over here. That's it. Okay. Now, let's go ahead and run the dish code as well. It's compiling the code. compilation is successful. Both the if else and the switch case structure generated the same output, if and switch case. Now, as I said over here, if you don't put the break, it will keep on going till the end of the switch or till the first break it encounters. So now let's see what happens if I remove the break on line number 26. Now, if I remove the break on line number 26, then what is going to happen is the dish code value is 1. It found the case where it is. And from that line 25 onward, it's going to keep on going. That means it is going to print both Masala Dosa SC and Medu Vada SC. And then the break is getting encountered. So that is why it is going to go ahead and stop. Let's go ahead and verify our output. The if condition should generate a Masala Dosa. That is it. And if you see, it's a Masala Dosa SC and Medu Vada SC. So the break is very important, especially in the scenario where you want only one case. If the case value is something which you want only one scenario to be satisfied with, that, then the break is a must in this case. Now, in coming back to the if-else structure that you see over here, I'm going to create the annotations. And now I'm going to have another structure over here. What's going to happen is else. If none of the conditions are satisfied, I'm going to simply say, okay, system.out.println, that is an invalid code. I can simply say that with an else in the if-else if structure. How do I say that over here? You see that with something called as a default. So you say default. Default means if none of the case values are the values generated by the expression of the switch, it will automatically come to the default and generate that particular value here. So now the thing is over here, I'm going to set invalid code. So again, what is needed over here? Between case 8 and the default, we will need a break now because we introduced another thing. Why? Because if case 8 gets satisfied, and if we allow it to keep on executing, it will execute and execute the statement, the default as well. So now let's try to see the dish code, say 15. It's not there. So I'm going to see invalid is from the if and invalid code is from switch case. Let's go ahead and execute and see whether we're getting that or not. Invalid. That is right. Now, let's assume that in the system, however, somehow for Sada Dosa, the dish code is either 8 or 18. In the if-else structure, I can simply go ahead and add another condition saying that all dish code is equal to 8. Now, in this case, either be it 8 or 18, and in that case, I want Sada Dosa to come. Now, what we want in the corresponding switch case code is there are two case values for which we want the same output. That means over here, we want line 35 to be done for case 8 as well and for case 18 as well. So what you might think that, okay, you know what, we'll go ahead and add another case and write the same thing again. Not necessary. Let's take the advantage of the fact that even if when one of the cases is satisfied, it keeps on going ahead and it executes till the break is encountered. So what I'm going to do is with case 8, I will have nothing written and I'll immediately write case 18. What's going to happen is if it is 8 or 18, if it is 8, it will come on line 34. It will keep on going. There's nothing after case 8. Case 18 is also going to be looked at, and then you just come on line 36 and print that statement, which is Masala Dosa SC. If the dish code is 18, then also I have no problem because it will again come on line 35, it will continue with line 36, and it will stop the processing over here. So now let's go ahead and check with both the values whether we're getting the same answer or not. So over here, yes, yeah, Sada Dosa. Yeah, yep, Sada Dosa if and Sada Dosa is C, right? And let's look at 18 as well. 18 should also give us the same output for both. So this is how a switch case works, and this is how if else work. The thing is, it's a much cleaner and much simpler to understand code using switch case. However, not every program written in if else can be written in switch case. For example, if I have a very complex condition saying dish code is 1 and dish code has some more restrictions to that particular statement, or if it is an even number or an odd number, or if it is a number which is divisible by 4 and 5 or something like that. When the conditions of the if start becoming more and more complex, it becomes difficult to translate to switch case code just because of the requirements that we have. That switch statement has to take an expression which has to either generate an integer, character, or a string, or any of the other versions of the integer. And the case values have to be the constants. And again, that's why where you see that if structure come out to be a little bit more versatile for any kind of complex conditions and any kind of code that you intend to write. All right. This is the end of conditional statement. There's one program that we had seen using ternary operator, which is the smallest amongst the three numbers. We used a ternary operator and try to do that. Let's see how we could go ahead and do that with the help of if else, and we'll see the actual usage of the relation of the logical operators of and as well. So we get an idea of how those operators also come into the picture. That's about conditional statements. Before we go ahead and progress to the next set of statements that Java programming has to provide, one thing that we have to focus on is this particular concept over here, where we use the ternary operator to solve the greatest amongst three numbers. And we saw there were a lot of conditions, and this particular way of writing turned out to be a little more tedious. Now, the same question, let's try to go ahead and solve that using if and else if statements. And what I want to show is how we can go ahead and use the logical operators that we discussed. So that is the thing over here. So I have, again, so num1, num2, num3 is going to be there. And I'm going to comment this code. And then I'm now going to say, now, let's think of the scenario, when will num1 be the greatest number? So num1 is going to be the greatest if num1 is more than num2. One assumption that we are going over here with is the fact that all of them are distinct numbers. None of them are same. Okay. So with that assumption in mind, when will num1 be the greatest number? If num1 is more than num2 and num1 is also more than num3. Then in that scenario, I can say that num1 is the greatest number. So num1 is the greatest. I'll just keep this over here just for a moment. Otherwise, if num1 is not the greatest, then there are two more possibilities. Either num2 can be the greatest or num3 can be the greatest. So now if num2 has to be the greatest, so you have num2 has to be more than num3 and num2 has to be more than num1. If that is the scenario, then we can go ahead and then we can write that num2 is the greatest number over here. Num2 is the greatest number. Otherwise, if neither num1 nor num2 is the greatest, then we can assume for sure that it will be num3, which is the greatest number. So I'm just copy pasting the code over here, and this is num3. Right. So the same piece of code can be written in if-else if statement, and this is an example of how you can go ahead and use the logical operators. Let's quickly verify whether they're getting the right answer or not. We should be getting that 6 is the greatest amongst 2, 5, and 6. And yes, we are getting that output. So this is all about the conditional statements. Now, before we progress to our next topic, which is the iteration statements, the loops, as they are famously called, there are two more operators that I would like to discuss. First, over here, I'm going to discuss it over here itself. And I'll give you a brief explanation of those slightly important and used quite heavily. I'm going to comment these lines of code. And I'm going to just take this look now. The first set of operators are the assignment operators. Now, these are the operators which, by the way, we have been writing right since the beginning, and that is the equal to sign. So the equal to sign is the simplest assignment operator that we know about, and that is nothing but how do we use that? The usage of that is also very simple. There is a variable on the left-hand side, which is equivalent to some expression on the right-hand side. So the right-hand side can be any expression, whereas the left-hand side has to be a single variable only. So that's how the thing is. So that means this if you have two variables A, B, three variables A, B, and C declared over here, you cannot write B plus C equal to A. This is invalid, but we can of course write A is equal to B plus C. So this is the assignment operator. And not only that, there's one difference as compared to the other operators that we have talked about, that this particular operator operates from right to left. That means if I have A, B, C declared, and if I write something like this, A is equal to B is equal to C is equal to 15, 15 will be assigned the value, 15 will be given to C first, then C, whatever the value of C will be given to B, and that value will be given to A. That's how the assignment happens from the right to left. This is, however, the simple assignment. There's another version of the assignment called as the compound assignment. Now, how does the compound assignment work? Let's understand. And what are they, first of all? So it is majorly all the arithmetic operators followed by equal to. That means plus equal to, minus equal to, multiply equal to, divide equal to, and modulus equal to. Not only this, it's all the logical operators also followed by equal to. And there are other sets of operators also which can be followed by equal to. They form the compound assignment. The one that is I would like to stress on are the arithmetic compound assignment operators, the ones which the equal to sign which follows the arithmetic operators. Now, how does this particular thing work? So if I write int val1 is 2 and val2 is 4, if I write val1 plus equal to val2, then in this particular case, this is equivalent to saying, I'm writing as a comment, this is equivalent to saying val1 is equal to val1 plus val2. So basically, this is like saying increase val1 by val2. So either you write val1 plus equal to val2 or val1 is equal to val1 plus val2. They both will do the same. And if I go ahead and print val1, you will see that the value has changed and the value would be 6. Let's verify that. Val2, by the way, remains unchanged and it remains 4. And that is correct. It is absolutely right. It is 6. Now the question if val1 plus equal to val2 is the same as val1 is equal to val1 plus val2, then what's the point of having these two different operators which kind of do the same? Yes, some people say that okay, this is a shorthand operator, it looks shorter. Yes, that probably can be called as one of the advantages, but one of the main differences between the two is when it comes to the concept of casting. Now, if you remember, we had discussed about integer and double. The value of a double cannot be stored in an integer. So that means if I try to do like this, int val is equal to 4, and I have double val2 is equal to 5.7. Should be equal to sign. Now, if I try to do val is equal to val plus val2. Now, over here, now let me comment this code for that. if you see, it is giving an error. Line number 52 is not allowed for a reason. We know that an integer and a double, when you try to add it, it is being tried to, we are trying to store the answer in a integer. I can't store a double answer in an integer, and that's why we are getting an error saying cannot convert type mismatch from double to int. We know that. However, we can write val plus equal to val2. If you see, the error is not coming up. There's no issue whatsoever. Why? Because the compound assignment operators automatically take care of the typecasting. That is one of the most important differences between the simple assignment and the compound assignment. So now if you print val, what would the answer be? So if you do 4 plus 5.7, the real answer is 9.7, but it's odd since you're trying to store it in an integer, the automatic typecasting will happen and it will be stored as a 9. And that's what the answer will be. Let's go ahead and verify that whether they're getting 9 or not. Yes, we're getting 9. So these were the simple assignment, which you've been using for a long time, and the compound assignment, which is used multiple times in programs. And we're going to use that in some of the programs that we'll solve ahead as well. Now, these were the assignment operators. Now, there was another set of operators which I would like to discuss, are called as the increment and the decrement operators. Now, what are they? They are simply called as the plus plus and the minus minus operators. Now, what do? Plus plus increases by 1, minus minus reduces by 1. Very simple. However, plus plus and minus minus both have two versions to it. One is called as the pre-increment and the other is called as the post-increment. Now, let's see the example and what happens really. So I have int val is equal to 4 and I simply write val plus plus. This is the post-increment. Then what happens if I do system.out.println and I print val, then if I print val, the val's value would have increased by 1, and that would be 5. The thing is, what would have happened if instead of val plus plus, I would have written plus plus val. This is the pre-increment. This would also increase the value of val by 1. It increases the value of val by 1. The thing is, if pre and post both are doing the same thing, then what's the difference between the two? The question comes as to when are we doing the pre and the post increment. Now, let me go ahead and share another example over here, which will make the difference very clear. So I have int val is equal to 4, and I have say int val2 is equal to val plus plus. This over here is an example of post increment. Now, how does the post increment really work? Post increment, post means later. Post is equivalent to increasing later, not right now. Now, what do you mean by later? At this point, at this moment, the value of val is going to be 4. The increasing of the val will happen either while going to the next term in the expression, or while, if there is no next term, while going to the next line in the expression. Now, there is no other term in this particular expression. So at this instant, value of val is going to remain 4, and that 4 is going to be assigned to val2. That means val2's value is going to be 4. Once I finish the execution of this particular line, and just before going to line 66 or 67 in this case, val's value will then increase to 5. So that means if I print val, the value of val will be 5, but the value of val2 will remain 4. So that is how the thing is. Let's go ahead and execute and verify our understanding. So compile. So val has changed, but val2 was the value, which was the value at that line over there, which was 5. So this is how the post works. Remember, increment increases by 1, decrement decreases by 1. So it's the same thing. The only difference being it is decreasing it by 1. Now, let's go ahead and try to see another usage or another operator that is there. Now that over here is the pre-increment. Now the pre-increment, how the pre-increment is going to do is val3 is equal to, I'm going to say plus val again. For simplicity, I'm going to comment this, and this I'm going to say val3. Now plus is when I put in front of the variable, it means it is pre-increment. Pre means right now means immediately. That means val will first be increased by 1, and then the value will be assigned to val3. So that means val will first become 5, and then the value of 5 will be assigned to val3. That means both of them in this case will be 5. Let's go ahead and execute and verify. Both are here 5. All right. So that is what the difference between the pre and the post increment is. Now let's take another example where there is an expression. So val3 is equal to say val plus into plus val. Now this is the expression. In this case, what's going to happen is that the value of val is going to be, since it was post, at this moment, it's going to remain 4. Since there is a next term, while going to the next term, val would change to 5. So when it came over here in this term in the expression, it was 5. And now since it is a pre-increment, it has increased from 5 to 6. Because when it came here, it was 6. So the answer of val3 is going to be 4 times 6, which is 24, and val will be 6. Let's go ahead and verify our understanding. 6 and 24. That is right. So these were the increment, and the same way you can work with the decrement. As I said earlier, instead of increasing by 1, it reduces by 1. And these are the main operators and the conditional statements and the ternary operators. We now move on to the iteration statements. Now, let's go ahead and work on the next set of statements called as the iteration statements. The iteration statements are nothing but, I would say, also called as the looping statements or the repetitive statements. Iteration stands for repetition. So now there are 3 major iteration statements in the Java language. Now, which are those iteration statements and how are they going to be used? We're going to be writing some programs also using them. The first one is a for loop. The second one is a while loop. And the third one is a do while loop. Now, iteration. Iteration means repeating. Sometimes we have to keep on repeating a certain set of tasks till we reach a certain goal. Now, let's take an example over here. Say, for example, for the guys and the girls of today, many of you might be a fitness freak and you might like going to the gym. Now, your trainer has a goal for today. Like, that you are supposed to go ahead and say that your training is over if you have made the total thing of 20 push-ups. If you've done an exercise of 20 push-ups, then your goal for today is complete. In this activity, your aim is to complete 20 push-ups. It's the same activity which you keep on repeating a total of how many times? A total of 20 times. Now, keeping this activity in mind, we're going to look at our first iterative statement. That's the for loop. Let's look at how the for loop works. So I have for. I have the initialization, which is the starting point. I'm creating a variable called I, whose initial value is 1. Then it's a semicolon. Please note this is a semicolon. Then I have I is less than equal to 4. Now, the next set of statements that what I'm going to write over here is I is equal to I plus 1. Now, I is equal to I plus 1. Now, how do I go ahead and what do I do over here? And then I'm writing over system.out. That's short form. Understand. System.out.print and then I'm going to say hi. So the first part over here is the initialization. It is my starting point. The next part over here is the condition. This is the condition which is similar to the condition that you used in if. This is an update. And over here, what you have is the body of the loop. Now let's go ahead and go back to the push-up example that we talked about. In the push-up example, initially, before you began, you had done 0 push-ups. That was your starting point. That's like the initialization over here. Then after that, you said that the task would be over if this number reaches 20. So you checked whether this number has reached 20 yet or not. Since it has not reached 20, you went ahead and you did 1 push-up. You did the activity of doing a push-up. This is the body of the loop. In this case, it is printing the message hi. After you did 1 push-up, the next thing that you did was, okay, since you did 1 push-up, you increase the number of push-ups that you have done so far to 1. This is now 1 push-up. This is the update of your loop. Then you check again. Is this number 20 yet? It is not 20 yet. So you repeat the process again. You go ahead and you do 1 more push-up. Just like how we have done this activity of completing 20 push-ups, so on and so forth, we can do that. Same way, the for loop also works like that. The flow of this loop goes like this. You start from the initialization. From the initialization, you go to the condition of the loop. So I is 1. Now, then you check, is 1 less than equal to 4? The condition is satisfied. The condition is true. Since the condition is true, I will go ahead and perform my body. Just like with if, by default, only 1 statement is associated with the body. And if you want to associate more than 1 statement, then you go ahead and use the curly brackets. So you go ahead and enter the body. And when you enter the body, what is happening over here? It's over here just printing hi. So it's going to print hi first. Since we have done the activity once, I'm going to go to the update. Now, when I go to the update, what I'm doing is I'm increasing I value by 1. So I is 1. Now I has become 2. So it was 1, it became 2. Now I go back to the condition again. I go back to the condition again. And then I say, okay, is 2 less than equal to 4? Yes, 2 is still less than equal to 4. I enter the body again. I print hi 1 more time. I go back to the update. I increase I once again by 1. I becomes 3 because I've written I is equal to I plus 1. That's increasing I by 1. I check the condition again. 3 is still less than equal to 4. I enter the body again. I print hi. I go back to the update. I increase I by 1 more. It becomes 4. Is the condition satisfied? Yes, 4 is still less than equal to 4. So just updating. We skip 3, 4, 4 is equal to 4. Condition is still true. I enter the body again. I print hi once more. I go to the update. Now I becomes 5. Is 5 less than equal to 4? No, the condition is not satisfied. The condition is false. If the condition is false, I step out of the loop. So the process is very simple again. Initialization to condition, from condition to the body back to the update, back to the condition. Keep repeating this cycle till condition becomes false. Now, let's go ahead and simply try this program very quickly on the editor. Stop my share and share my. Yep. So here it is. I've already created one that will. So I'm going to int. So I'm going to have a for int I is equal to I is less than equal to 4. I plus plus. I can also go ahead and use the increment and the decrement operators that we just saw. And then over here, I simply do system dot out dot println and then as I said, even if I don't put the curly brackets, it's fine because there's only one statement within the loop. If you want to print more than one statement, then the curly brackets become a must. So I'm just going to go ahead, compile the code is getting compiled, and we see that our 4 highs are getting printed. Now, some important points to note over here. The thing is, the most important one over here is this. I created a variable I in the initialization of the for loop. The thing is, whenever I do this, if I create a variable either in the initialization of the for loop or in the body of the loop, then this remains the scope of the variable I. You can't go ahead and use I outside of the loop. Now, how can we prove that? Very simply, let's go ahead and write over here system dot out dot println. We should get an error over here. Let's see what the error is going to be. Cannot find symbol variable I, right? Because I is currently outside of the loop. Because we created I within the initialization of the for loop, the scope is only within that loop. Please note this also holds true if you create variables within the within the body of the if statement. What do I mean by that? Let me just quickly show you that. So over here I have int val is equal to 4, and I say if say val is greater than 3, and in the body I create int y is equal to 5. Now, if I try to print y outside this, I will get the same error which I got over there. And the thing is over here, the editor itself is going to get highlighted and it gives you the error saying that y cannot be resolved to a variable because we created the variable inside the body of the if. The scope is only till that particular thing. Very important to remember, especially when you're working with large pieces of code, you need to be understanding what's the scope of the variables that you are using. Okay. Now once you've understood the scope of this, I'm going to just quickly comment this out. Now, well, let's go ahead and understand, and let's go ahead and solve some basic questions using a for loop. Now, one of the most common things that is asked using a for loop is, does the initialization have to start from 1? No, not necessarily. Initialization can start from any value depending on the requirement that you have. Say, let's solve this particular question. And the question is, now let's take a number, given a number n, number n. It doesn't show these numbers. We need to print all the odd numbers from 1 to n. So, for example, if n is over here is 12, then our output should be 1, 3, 5, 7, 9, 11, because these are all the odd numbers from 1 to n. So now, in this case, I'm going to start doing it from 1. So the thing is, my for loop will have your I starting from 1. I have been given n, so I'm going to create my n over here for right now, giving it as 12, but it can be any value. I is equal to 1. I is less than equal to n. And now the thing is, after I go through 1, the next number I want to go through is 3. So I am not, instead of increasing I by 1, what I'll simply do is I will simply do I is equal to I plus 2. I will increase I by 2. And I always have the habit of putting the curly brackets, a system dot out dot println. And what will I print this time? I'll print I. Now let's do a quick dry run. In loops, one of the ways you can go ahead and verify that you're doing the right thing is just by doing a quick dry run. So how you can do that? You can start I is 1. So I is equal to 1. 1 is less than equal to 12. The condition is satisfied. I enter the body of the loop. I'm printing I. Currently, the value of I is 1. So 1 gets printed. Then I go to the update. I becomes 3 now. I is equal to I plus 2. I becomes 3. I go to the condition again. 3 is less than equal to 12. The condition is satisfied. I enter the body of the loop. I print 3 on the next line. Similarly, I keep on going till I becomes 11. 11 is less than equal to 12. The condition is satisfied. I print 11. And I is equal to I plus 2. I becomes 13. Now, 13 is less than equal to 12. The condition is 13 is less than equal to 12 is not satisfied. So you won't enter the loop and you will not be printing 13. So you will have all the numbers from 1 till 12, the numbers which are odd. Let's go ahead and I'm going to clear this screen so that you can see the output very clearly. Let's go ahead and run the code and verify this. Compiling 1, 3, 5, 7, 9, and 11. Now, this is one way of doing the code where we have a different update. Is there a way that we can still get the same answer where the update is the usual update that we just saw earlier, I++? Is it possible to do it that way? Absolutely. Now, for that, I'm going to just copy the code, what we had written earlier, and we will go ahead and do that. One comment, these lines of code quickly. And I'm going to come back to I equal to I plus 1 or I++, any of those things. Now, in this particular case, if I keep as I is equal to I plus 1, what is going to happen is I is 1. 1 is less than equal to 12. I'm going to print 1, but I is increasing by 1. That means it is actually going through all the numbers right from 1 till 12, not skipping any numbers. So in the previous example, we were skipping the numbers. We were going from 1, we were directly jumping to 3. And that's why we had no problems because we were actually going through only the odd numbers. But this time we're actually going through the even numbers as well. So what to do? In this case, what I will do is I can put an if condition over here. And if or an if else or anything that we have seen earlier, I can go ahead and do that. So I'm going to say if I modulus 2 is not equal to 0, if it's an odd number, that's the check that I do for odd numbers, then only I will go ahead and print the I. Again, if you want, if you put the curly brackets, since there's only one statement, I'm not going to put it. But it now does the same thing because 1 modulus 2 is 1, 3 modulus 2 is 1, 5 modulus 2 is 1. So now the printing is only dependent on the value of I. So let's go ahead and execute this and check. We should be getting the same answer. Yes, we are getting the same answer. So this is another thing which is there. Now, one of the most common things that are there that are achieved using the loops is the concept of having some form of accumulation or counting or continuous adding. This is one of the most commonly used scenarios in a for loop. Say, for example, if the question is, okay, say, let's take this hypothetical scenario. You are traveling from Mumbai to, say, Lonavala, for example. And you have been given the task that on the route, you're going to stop at every restaurant. You need to tell at the end of the journey how many Chinese restaurants you saw. So the way you're going to do is you're going to start from Mumbai. You're going to initially, before you began, you're going to have a counter which is going to keep track of how many Chinese restaurants you saw. So, say, same way over here, we are also having a similar program. The question here goes like this. The question is, I am writing the question. Given n, count how many numbers exist from 1 till the number which are either divisible by 3 or by 4. So the check of the whole Chinese restaurant is a requirement of whether it is divisible by 3 or by 4. So what we're going to do is something very simple. So initially when we begin, we are going to have a counter. So have a counter, which before you start your journey, your count is 0. And you have been given your N6. Now, the thing is, you start your journey from Mumbai, your ending is till Lonavala only. So that's your normal route. So you're going to start from 1 over here in this case. And you're going to go till N. And every time you're increasing by 1. You're going to look at everything. Now, if you encounter a Chinese restaurant, so you're going to say if. Now, our Chinese restaurant over here is a number which is divisible by 3 or 4. So if I modulus 3 is equal to 0, or I modulus 4 is equal to 0. It is either divisible by 3 or by 4. If the number is divisible by 3, so if I find a Chinese restaurant, what do? You have a counter. Initially, if it was 0, you make it 1. Initially, if it was 3, you make it 4. So initially, with the first Chinese restaurant that you're going to encounter, you're just going to simply increase your count by 1. So what are we going to do with the count? I'm just saying count is equal to count plus 1. I'm going to increase my count by 1. Or simply saying you could have also written what? Count plus plus. Just increase the count by 1. That is what the increasing of the count would do. You keep on doing this process till the end of your journey. Once you have reached Lonavala, what I mean by that is once you have completed your journey, that means in this case, once you have come out of the for loop, what you're going to do is you're going to simply go ahead and print the count. So you're going to tell how many numbers are there. So that the count is the final value. Note that you're printing this outside of the loop. So let's go ahead and check. So from 1 to 15, the numbers, by the way, which are divisible from by 3 or 4 are, so for n is equal to 15, so the numbers are 3, 4, 6, 8, 9, 10, no, 11, now 12, 15. These are all the numbers which are divisible by 3 or 4. So the final count should be 1, 2, 3, 4, 5, 6, 7. So 7 should be the final answer after the whole process is over. Let's check. 7 or not. Compile the code. And yes, so that's the final count which is there. So you find the Chinese restaurant, you increase your count by 1. Simple logic. Accumulation. One of the ways of having an initial value and keep accumulating it as and when you proceed. Now let's see another example of accumulation over here. Now the thing is, let's see over here, given n, you need to count. Given n, you need to count all the sum, calculate the sum of the factors of the number from 1 to n, but not including n. If the sum is equal to n, then you need to print that the number is a perfect number. Otherwise, you print the number is not perfect. Now, Let's see an example of this. Now, an example of this would be, say, for example, if n is 6. Now, is 1 a factor of 6? Yes. Is 2 a factor of 6? Yes. Is 3 a factor of 6? Yes. Is 4 a factor of 6? No. Is 5 a factor of 6? No. And we are not supposed to check for 6 because the question says from 1 to n, but not equal. So, now, the sum of all the factors, that is 1 plus 2 plus 3, is 6, which is also equivalent to the original number whose factors we were calculating, that is also 6. So over here, in this case, this is another form of accumulation where we need to keep accumulating the sum of the numbers. So 6 is a perfect number. So this is perfect. Now, let's see how we can write the code for this one. Just scroll up a little bit. Now, comment this piece of code so that it's easier for us to. Yeah. So I have my n. My n is 6 in this case. Here I need to accumulate the sum. So I'm going to create a variable called sum. Again, initially, I haven't seen any factors. I haven't seen anything so far. The sum is 0. Again, I need to start checking from 1. So my I'm starting from 1. But this time, my I don't want to check for anything. So I is less than, not I less than equal to. Then I press this 1. I need to first check whether this I is a factor of n or not. Basically, I need to check whether n is divisible by I or not. Remember, I is continuously changing from 1 onwards. So I'm going to write here if n modulus I is equal to 0. If it's a factor, if I divide it, then in this case, I need to increase the sum by the actual factor value. That means my sum is equal to sum plus I. I is the factor. I need to increase, if I see 1, I need to increase my sum by 1. Next time I'm going to see 2, which is also a factor. I'm going to increase my sum by 2, so 1. And it then becomes 3. When I look at 3, it's still, that's also a factor of n. That's going to become 6. So that is how it's going to be. At the end, again, once I have calculated the sum, that means after I have gone through all the numbers, that means after 958, I'll simply go ahead and check if sum is equal to the number or not. If it is, then simply print the sum. The sum is perfect. Or I would not say the sum, the number is perfect. Otherwise, else say the number is not perfect. Just quickly copy paste the link is not perfect. Let's go over here. Ahead for 6, we should get that the number is a perfect number. Number is perfect. Let's try for 12. The sum of the factors of 12. So 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor. So if you see 1 plus 2 plus 3 plus 4, that is then 16. 16, unfortunately, is not the same as 12. So it is not perfect. So I'm going to go ahead and run this, and we're supposed to see that the number is not perfect. All right. So another usage of for loops to keep accumulating. Right. And you can have if else constructs within the body of the for loop. All right. Another very important thing that I need to tell you before we move on, another usage of the for loop is that you can have any number of initializations. If you want to have more than one initialization, you can separate it with a comma. So that means you can have something like this. So I'll just show you that. So you can have for and n1 equal to 4, comma, n2 equal to 8. Multiple initializations separated by a comma. You can have any number of updates as well. n1 plus plus and say n2 minus minus. The other thing that is there, however, you can have only one condition. If you, by the way, don't give any condition, it will be considered as true or it is correct. That means this loop will keep on running forever if you don't provide a valid condition, or if you don't provide any condition, it will keep on running. However, if you want to give a condition, you can give only one condition. So if you have multiple conditions, you need to use the logical operator that we see. For example, just n1 is less than 5 and n2 is more than 3, something like that. So yes, this is absolutely valid, just like the conditions that we use in if and else. So this is another very important statement, important aspect about the for loops. And then you can do whatever you want to do within the body of the loop. You want to print it or do whatever. So this is the for loop, which has initialization, condition update, and the body. And what happens in the flow of the for loop understanding is very crucial and it is very critical. So this is all about for loops. Next, what we're going to look at are the remaining two loops called as the while loops and the two while loops. Now, we just saw what is the concept of for loop. Now, what we can also have is a concept of a loop within a loop. So let's quickly look at the concept of nested loops. Now, how do the nested loops work? Please pay attention. So I have, let's take this example for int I is equal to 1, I is less than equal to 2, and I plus plus. And inside this, I have another for loop saying for int j is equal to 1, and then I'm doing j is less than equal to 2, and j plus plus. And then I'm just saying simply system.out.println hi. Now, this is the closing of the inner loop. This is the outer. Now, how is this particular set of code going to work? Let's understand that. So I have the outer loop. So this is I is 1. So I code the initialization. Remember, this is the basic flow of any loop. We start from the initialization. We go to the condition. If the condition is true, you enter the body. Then you go back to the update. Then you go to the condition. And you keep repeating this till the condition becomes false. And you stop the processing of the loop. So now I is equal to 1. Then after that, over here, I go to the condition. Now 1 is less than equal to 2. The condition is satisfied. Since the condition is satisfied, I enter the body of this loop. The body of the inner loop is another for loop. So what I'm going to do, since I'm entering the body again, I am going to start my j loop again from the initialization. So j is going to begin again from 1. So j is equal to 1. So I is 1 now. Then j is also 1. Now, 1, j is 1 is less than equal to 2. Condition is satisfied. Since the condition is satisfied, I enter the body again and I am going to print hi. So I'm going to print hi first time. Remember, my j loop has begun and it is not yet over. I just completed the body of the j loop. So I'm going to go to the update of the j. So j plus plus, that means j becomes 2. So j is 1. Now j is equal to 2. Remember, I is still 1. I go back to the condition again. 2 is less than equal to 2. Condition is satisfied. I enter the body again. I print hi one more time. Then I go up again. Now, this time j becomes 3. And I go to the condition 3 is less than equal to 2. The condition is not satisfied. Since the condition is not satisfied, I'm going to come out of the loop. But remember, I'm still in the body of the inner loop. I'm going to come over here. There is no other statement inside the outer for loop. So I will go back up and go to the condition, sorry, the update of the outer loop. I becomes 2 now. I check the condition. 2 is less than equal to 2. Condition is satisfied. Now, since the condition is satisfied, I enter the body of the inner loop again. Now, in that, there is another loop. Again, I start my j from the initialization. So j again starts from that. Again, I check if it is condition is satisfied. If it is satisfied, I go to the body. J becomes 2. 2 is still less than equal to 2. The condition is satisfied. I print I again. You go up. J becomes 3 now.
the condition is not satisfied. I come here. There are no other statements in the body of the outer loop. I go back to the top. Now I becomes 3, but 3 is not less than equal to 2. So the whole program stops. So the output is high getting printed 4 times. Very important flow over here to remember. For each value of I, your J is going to begin right from the beginning. The entire loop of J will be executed for each value of I. So when I is 1, J will do the whole process starting from 1 till the condition of J is not met. Similarly, when I is 2, the same thing will happen that time also. Now, let us go ahead and let us try to go ahead and solve a question using the concept of nested loops. So I'm going to stop my shell. And okay, all right. So this is about the iteration statements. I'm going to comment this out. So now the requirement is this. So if, say, for example, you have been given a number and there are n people in the room and they are all numbered from 1 to n. Okay. And the question is, what are the different pairs of people that you can form? So over here, let me write this question down. Given n, find all possible of numbers from 1 to n, basically. So what I mean by this is that we give an example. So over here, if n is 3, so what are the pairs that can be possible? So you can 1, 1, that is one pair. Then the other thing is 1 and 2. The other thing is 1 and 3. That is one set of 3 pairs possible with 1 as the value. Same way, you can have 2, 1, 2, 2, and 2, 3. All combinations, all possible combinations that can be generated from one pair. And then 3, 1, 3, 2, and then 3, 3. So the thing is over here, if you look at the question, so the question is telling you to generate all possible combinations of numbers. That would be a better word from 1 to 9. So if n is 4, it would be 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, so on and so forth. Now, how do I actually go ahead and so I have my 2 loops. This is a very typical example of how I can have my 2 loops. So I have my I loop, which is going to go from 1 till n. So I'm going to have is equal to 1, I is less than equal to n, and then I plus plus. For each value of I, that is when I is 1, I need 3 combinations again. If n is 3, I need 3 again. So I'm going to have again my j starting from 1 and j is less than n and j plus plus. So just quickly let me declare n. It's 3 in this case. And then what we are going to do is we are going to print all the combinations. So the thing is over here, for the I value, the j will keep on changing. So I need to print both I and j. So system.out.println, I'm going to print I plus, in this case, plus j, and then print this. So I is equal to 1, I is less than equal to 3, the condition is satisfied, then j is 1, 1 is less than equal to 3, condition is satisfied, I print 1 and 1. Then j plus plus j becomes 2, 2 is less than equal to 3, condition is satisfied, I print 1 and 2, and so on and so forth. J becomes 3, 3 less than equal to 3, condition satisfied, I is still 1, so 1 and 3. J becomes 4, the condition is not satisfied, the inner loop is over, I go back to the outer loop. I is 2, 2 is less than equal to 3, condition is satisfied, I start my j loop again from 1. So this is how the loop goes. And let's see whether we get this answer. Compile the code. It's compiling. Yes, it's generating all the set of numbers that we thought it should. So if we change the value of n, based on that, that many pairs of numbers will get generated. So this was the
for loop and the usage of nested for loop. Is it necessary to have only one loop within a for? No, you can have as many as you want, as long as it makes sense for the problem that you are solving. Now, let's go ahead and look at the other loop, which is there, which is the while loop. I'm going to comment this out. Now, the while loop. Now, how does the while loop really work? So, a while loop is like a for loop only. The only difference between while loop and the for loop is that while only has the condition. So you have while and you have the condition over here. And then you have the body of the while loop. Again, by default, only one statement is associated with the body of the while loop. You can have more than one statement. For that, you need to put the curly brackets. So it's very similar to the for loop, as the only difference is it has only the condition. So where do we do the initialization? The initialization has to be done only once. So that means it has to be done before the while loop. And the update will be done inside of the body of the loop, since that has to be done every time. So, like for example, now let's go ahead and see this. I have n is equal to 5. If I want to print hello n times, so again, I can have my I is equal to 1. And then I can do the same thing. I is less than equal to n. And I can go ahead and print my hello, print my hi. Now, since the update is going to be done in the body of the loop, I'm going to have an space. So I is going to get printed inside the body of the loop. The flow is exactly the same. So I is 1. 1 is less than or equal to 5. The condition is true. I enter the body of the loop. I print hi. Then I becomes 2. Then I go back to the condition. When 2 is less than or equal to 5, the condition is satisfied. I print 2 again. As I print hi again, and I becomes 3. So on and so forth till the condition is satisfied. So now let's go ahead and print this particular thing over here. Hi. Hi gets printed a total of 5 times. Now the question comes is over here, when should we use the for loop and when should we use the while loop? Remember, if you're writing a code using a while loop, can you write it using a for loop? Absolutely. And if you're writing using a while loop, using a for loop, can you write it using a while loop? Absolutely. You just saw that one example of how I converted a for loop code into a while loop code. Ideally, while loop is used in those circumstances where you know when to stop the repetitive process. And when the process of the update in the for loops that you saw, where there was a very typical update, I++, increasing I by a certain value, updating I by a certain thing. In this scenario, normally you would go ahead and use the while loop where you would not have a very typical update, or the update is not very well defined. Now let's take this particular example. I'm going to give you an example where we are going to solve a question where the update is not very typical. So in the field of mathematics, there is a sequence called as the hailstone sequence. And the hailstone sequence goes something like this. So the thing is, it starts from a number and it keeps on going till you don't reach 1. The moment you reach 1, you stop the process. So the thing is, how does it go? If n is odd, then you update n as, then n is updated. Then n is updated as 3n plus 1. Otherwise, n is updated as n by 2. Now, how do I go ahead and write the code for this? Now, the thing is, if you see, the update over here is actually dependent on it. But I know for sure that I stop the process. I stop the process when n becomes 1. I stop the process. So, given any value of n, so n, let's say 10. If n is 10, I keep on going till n is not equal to. So while n is not equal to 1. And every time I do that, the thing is what I'm going to do is I'm going to first print the value of n. Now, I just print the value of n. And after I print it, I will check if n is even or not. So if n modulus 2 is equal to 0, then I can write n is equal to n divided by 2. Or, by the way, you can use the compound assignment operators also, and you can write n divided by 2. Any of that is fine. Both mean the same. Otherwise, else, I'm going to update is n is equal to 3 times n plus 1. So now, for 10, the sequence should go something like this. So I start with 10 first, and after I look at 10, then it should be 10. Then I print 10. 10 is even, so it should become 5. This should become 5. I won't go in the else. There's nothing else there. I go over here. 5 is not equal to 1. So I print 5. So this will print 5. Now 5 is odd. This condition is not satisfied. I come here. So now n becomes 16. 5 times 3 plus 1 is 16. I go again to the top. The condition is not the condition is satisfied. I enter the body of the loop and it becomes 16. I print the 16. It is even. N becomes 8. 8 is not equal to 1. I print 8. 8 is still even. N becomes 4. 4 is not equal to 1. I print 4. N is 2. 2 is not equal to 1. I print 2. And then finally, n becomes 1. 1 is not equal to 1. The condition is false and my process stops. So this is the headstone sequence for n is equal to 10. Let's see whether we're getting this output or not. So let's go to execute that. 10, 5, 16, 8, 4, 2. So this is an example of while loop, a very good way to use for a question like this, because I know when to stop, but the update kind of depends on how the value changes throughout the iteration process. So this is your while loop, and you have your for loop as well. Now, we have understood what is a for loop and a while loop. There are certain important statements called as the jump statements. These jump statements, when you use within the concept of a loop, it does something to that. Now, let's see that with an example of the while loop only first. So I'm going to erase this code. And now, the question is, say for example, using the while loop, is you keep on take a value of n, okay, and you keep on reducing the value of n till you encounter a number which is divisible by 7. So for something like this, one of the approaches that can be used to solve a question like this is a form like this. So I can have a value. Now the thing is over here, I have to keep on doing this. So one approach is to have a loop which is called as a while, and there's no condition. In that condition, give a while true. So let me say 17. So I'm going to say while true. Now, again, so before I proceed, I'll just quickly write down the question over here. The question that we are solving is taken and we'll keep reducing it till you encounter a number which is divisible by 7. So this is while true. True, the condition is always satisfied. That means this loop will keep on going. But you need to stop the process when you encounter a number which is divisible by 7. So I simply write if my n modulus 7 is equal to 0, then I want to stop the process. We're going to use a jump statement, which we also saw in switch case, which was between the two cases. What we saw was a break. That's the same thing. What we're going to do is we are going to use break. What does break do? Break takes the control out of the loop. it stops the loop. If the condition is not satisfied, then you simply reduce the value of it. That is, you simply do n minus minus. And once you keep doing that, you keep printing the value of n as well. So system.out.println, I'm just printing n before reducing. So now let's go ahead and understand how this code will work. So I have 17 condition is true. So 17 modulus 7 is equal to 0. This condition is not yet satisfied. So I'm going to print 17 and then n becomes 16. From 17 it becomes 16. The while loop condition is still true. I enter the body. This condition is not yet satisfied. I print 16. N minus minus it becomes 15. The while loop condition is still true. The condition is not yet satisfied. I print 15. And finally my n becomes 14. The while loop condition is still true, but my if condition is now satisfied. I break takes the control out of the loop. And I'm on line 125. I've written nothing, so nothing will get printed. So let's go ahead and check whether we get the desired output or not. And here, 17, 16, and 15. Can I use this concept in the concept of for loops as well? Absolutely. You can use jump statements in the for loop as well, and it does the same thing. It stops the loop whenever it is encountered. So normally you put a break statement when a certain condition or a criteria is met. Then only you can go ahead and you do the process. So this was the while loop, the nested for loops, and the jump statement called break, which does the same thing as in the for loop, which is similar thing which it does in the break of the switch cases as well. Now, there's one more jump statement which we are going to see next, and we are going to next look at the do while loop. Now, let us go ahead and look at the other jump statements. So we talked about break, and whenever a break is encountered in a loop, you come out of the loop. Remember, a very common mistake is to use break within just if and if else or else if statements in those kind of blocks. You cannot go ahead and place them inside if or else if statements. You can do that as long as those constructs are within loop. So as you can see over here, line 119 is an if construct. It's within a loop, you can place the break statement. But if it just is a standalone if or if else construct without any concept of loops, then you cannot use that. The next statement, the next jump statement that we are going to consider is called as the continue statement. So what does the continue statement do? I'm going to this code. Let me tell you the for loop how it works. So having the I is equal to 1, I is less than equal to 1. And I say that if I is equal to 3, I continue. That's the next jump statement. Continue system dot out dot. What continue does is that whenever the continue is encountered, rest of the statements of the body of the loop for that particular iteration are skipped and it directly goes to the update. So when I is 1, so let's see the flow of this program. I is 1, 1 is less than equal to 5, the condition is satisfied. Okay. And then is 1 equal to 3? No, 1 is not equal to 3, 1 gets printed. I go to the update of the for loop, I becomes 2. Is 2 less than equal to 5? Yes, it is. The if condition is still not met, and I go ahead and print 2. And plus plus I becomes 3. Now is 3 less than equal to 5? Yes. Is 3 equal to 3? Yes, it is equal to 3. What happens is you continue. Continue means the control in this case goes directly to the update of the loop. That means over here, the control directly goes over here to I plus plus. So that means I becomes 4, and there's no other condition for which the if condition is going to get satisfied. So 4 will get printed and 5 will get printed. So this output in this case is just simply going to be 1, 2, 4, and 5. Let's go ahead and execute and verify our output. 1, 2, 4, and 5. That is what the output is going to be. How does the continue work in a while loop? In a while loop, what really happens is, again, it does the same thing. It skips the rest of the body of the while loop, and the control goes directly towards the condition of the loop. There's no update as such in the while loop. That's why the flow directly goes to the part which is there, which is the condition of the loop, and it works exactly the same way otherwise. So this was the for loop, and this was the while loop, and the jump statements of break and continue. Now let us look at the last loop which is there, and that loop is called as the do while. Now the do while loop is slightly different looking. It is just like the for and the while with one major difference. Now what is the difference? Let's understand. It's written like this. So let's see this example. And this is pretty fun. And I write do, open the brackets, and we write while, say, n is greater than 0. And then there's a semicolon over here. And then I'm writing over here in the body of the loop, I'm writing system.out.println, and then I'm doing n minus minus. What we are doing in this case is that first we are entering the body of the loop. We are going to be doing this activity at least once, or once for sure, even before we check the condition of the loop. Therefore, the do while loop is also called as a post-tested loop. Because the testing is not checked on entry of the body, it is checked on the exit of the body. That's why it's also sometimes called the exit control loop. And this loop will be executing at least once for sure. So the thing is over here, n is 5. In this case, 5 will get printed, then n becomes 4. 4 is still greater than 0. The condition goes back to the body, and it keeps on processing till n becomes 0. So let's go ahead and verify what the output is. 5, 4, 3, 2, 1. That's exactly what this piece of code is doing. Now, what would have happened if I would have written say something like this, n is greater than 10? Had it been a for loop or the while loop, the condition is always checked first before you enter the body. In that case, since the starting value of n is 5, you would never enter the loop at all, and nothing will be happening because none of this will, because the condition itself is false. But in this case, what's going to happen is 5 is going to get printed, n is going to become 4, and the condition is going to become false. So that means it's going to happen at least once, will always be there because you're testing the condition after you have performed the body. So you will just see 5 in the output when you run the code. So if you have something where you want to do at least once, it's a good idea to go ahead and use the do while loop. Okay. So 3 basic iteration flows: for loop, while loop, and the do while loop. Now let us go ahead and move on to working with huge or more amount of data at the same time using the concept of 1D and 2D arrays. Now, let us go ahead and proceed with the next concept of one-dimensional arrays. Now, what is an array and how does it work? In English, if you see the definition of an array is a collection of items. That is what it means. Now, the thing is, in Java, an array is a similar thing. It is a collection of items again. But one small thing, it is a collection of items of the same type. You can create an array of integers. You can create an array of doubles. You can create an array of booleans. Now the question is, why would you want to be working with this another thing called as an array Why can we just not go ahead and create some variables? Now, let us assume that we are making a system for the code scenario in place. There are a lot of lot of startups which are actually going ahead and kind of analyzing data on how the patients are. So are the hospitals. Now, the thing is, for example, there is one particular hospital which wants to analyze the data of all of its patients. Now, if the hospital wants to just store the information about age of each of the patients, now the thing is, first of all, we have a maximum capacity, like, okay, what is the maximum capacity the hospital can have? Say, maximum patients at any given time can be 200. So now, if I really want to go ahead and manipulate that much data, the thing is, I will have to create 200 variables just for manipulating the age. That means I will have to store an integer P1 age, then P2 age, and then P3 age, right? And I will have to store that information. And the thing is, I will also have to store the information in those scenarios where, say, for example, patient number 100 is no longer a patient at the hospital. Then the thing is, maybe there has to be some indication of, okay, maybe I make that variable patient number, patient 100 age is, just write it as patient 100. So if I want to write int patient 100 age was initially, say, 38-year-old person was there. It's known that patient has been discharged, so I want to update it. 5, 6 patients get discharged. So I will have to actually go ahead and figure out, okay, which variable is this? And then go ahead and make the changes over here. I'm managing so many variables just for one piece of information. Remember, it's just the age of the patient. And you know that there is so much more information about the patients that I have to maintain, and it's just not the age. Our code will be extremely, extremely complex, and we might as well have a pen and paper to maintain that kind of information if we have to write that kind of code. That is why every programming language comes up with something called as a data structure, a way to store data. Now, every data structure tries to give you some advantage. And one of the advantages of an array is to store similar data together. For what purpose? To make access easy, to make manipulation easy, to doing some processing very easy. A few lines of code and you will be able to understand, and you will be able to access and do anything that you want to do with the age of the patients, for example. So now, how do I create an array and what the concept of an array really is? We're going to understand that now. Now, let us go ahead and see how do we create an array for storing the ages, for example. So over here, I'm going to create, and since all are going to be integer, so I'm going to say int. And over here, I'm going to mention patient ages. This is not a single integer, it's going to be an array. There is a notation for an array, which is the square brackets. Now, either you can write patient ages square brackets, or you can write square bracket patient ages, both of them is equal to. Now, say, for example, I want to go ahead and give some values to it. So I will go ahead and give some, say, first patient is 15, the second is 58, 68, 71, 19, 45. Assume for now there are only, for simplicity and understanding purposes, I'm just taking 5 patients for now. So this is called as an array of 5 patients. This is the first patient, the second patient, the third patient, the fourth patient, and the fifth patient. Now, how do we access individual values of the array? Every value in the array is at a certain position. The position number, please note, does not start from 1. It starts from 0. So over here, this is the first patient is actually at position 0. This is at position 1. This is at position 2. This is at position 3. And this is at position 4. Now, if we have to go ahead and access the value of a certain patient, then we simply go ahead and write it like this. I have system dot, I'm just typing short form for now, out of println, and then I'm going to write patient ages. That's the name of the value, using the subscript notation. So the subscript notation, square brackets 0. If I go ahead and do that, this is going to print the value 15 for me. This is going to print the value 15 for me. All right. Similarly, if instead of 0, if I go ahead and write 2, then it will print the value 71 for me. Let's go ahead and quickly type this out and check so that we can verify our understanding. I'm going to go ahead and create a new reference for IDEs. For that, it's getting created. It's getting created. All right, this is the print. We want to erase this. I'm going to write int patient ages square bracket. This is 15. See, I can remember the values 59, 67, 31, 55. So I have 5 patients, and over here I am separating it with a comma. As I said over here, if I want to go ahead and work with the first patient, the patient system.out.println, and I have patient square bracket 0. That is going to give us the first patient in the array. The position begins from 0. So let's go ahead and print and check whether we're getting that or not. Compile the code. 15. That's what we're getting. 15 is a good answer. Now, let us go ahead and I'm going to copy this code and then try to go ahead and write another thing over here. The patient ages of 2. That's going to give you the third patient's age. Remember, positioning begins from 0 again and not from 1. So when I combine this code and run this, for the first one is 15 and the second one is 67. Now, unfortunately, I entered the third patient's age incorrectly. And I want to change it now. So I can go ahead and change. I can say patient ages of 2 is equal to, and say I want to make it 2 now. Instead of 67 to 68. And then if I want, I can go ahead and print it again. And that array, it would go ahead and change the values in the array. It will become 68 now. So I can go ahead and verify that before the change, it should be 67. And then after the change, it has become the value that we gave. Now the array is of 5 values. What happens if I try to give a position which does not exist? Now let's try to do that again. Now over here, what if I use patient ages of 5? Remember, 55, the last patient over here, is at position 4. The position 5 doesn't really exist. Now let's see what happens when I try to run the code. Now when I run this code, I'm going to get something called as an exception. Now, what is an exception? And this is a very specific exception called an array index out of bounds exception. It tells you which line number and what the reason is. You're trying to access 5. You're trying to access index 5 out of bounds for length 5. The length is only 5 and try to access an index which is 5. And it tells you the line number where the issue happened and it happened on line number 8. This is an exception. An exception is an error that happens at runtime. It's a runtime error. And the moment an exception occurs, your program terminates. And that's why you see an exit status of 1. That means your program didn't terminate normally because of an error that was encountered at runtime. Some of these exceptions there are predefined exceptions that always happen whenever you run your Java code. If you don't pay attention to your code. And this is one of the most common ones, especially when you're working with arrays of different sizes and you're trying to manipulate different positions of the array. So we have to be very careful about it. Remember, once an exception occurs, whatever code you try to write after it, it will never happen. So the thing is, now let's try to say, for example, to check how it really works, I'm just going to go ahead and write system down just for our understanding. I'm just going to say hello. We will verify, we will see that the hello statement will never get executed because line 8 created a problem. Let's verify whether that happens or not. Yep, it never got executed because there was an error on line number 8. So very important, and we have to be very careful with this exception, is the array index out of bounds exception. Now, there's another important property. I'm going to comment this line for now. And now the thing is, the next one is an important property, which is a property of every array, which is called as the length property. What it does, as the name suggests, it gives the length of the array, which means over here, it talks about how many values are there in the array. The name of the array is patient is dot length. Now, length is a property whose value gets assigned automatically. You cannot give the value to it. So you cannot say patient ages dot length is equal to something. Okay. And you see that the length is 5. Just before hello, we see that the length has come out to be 5. So this is about the basic idea of what an array is. Now, let us go ahead and work with this particular array. Say, for example, now, if we want to find out over here, we want to print all the values of the array, one at a time. All right. So that means I want to print the 0th array, 1 array, 2, 0th position value, 1st position value, 2nd position value, and so on and so forth. That means we need to start from 0 and we need to go till the length of the array, not including the length. Please note, because if the length is 5, we need to stop at 4. And we need to keep printing the value at each position. So in that particular case, what is the best thing to use is, let's go ahead and use a for loop. I can go ahead and use a loop over here. You can even use a while loop if you want. So I can write for, my position is starting from 0. So I is going to start from 0. I is going to go till the length of the array. So I'm going to say patient ages dot length. It's less than and not less than equal to. Remember, if you try to do less than equal to, that means you try to access 5. And we just saw that when you access a position which does not exist, I get the exception. Like the system out patient ages square bracket. Now over here, the square bracket now thing is over here. First it should be 0, then 1, then 2. I is the variable which is getting updated again and again. So I'm going to say patient ages of I. That is what is going to give us the answer. Let's go ahead and verify whether we're getting all the values of our array or not. It's getting combined. And that's the output. Note that the code that we have written from line 11 to line 14 is actually irrespective of the length of the array. So even if the array was 200 values, it would have, these 3 lines of code would have still worked. Imagine now, to our first point that we had made, if we had 200 variables for each of the patients, and we had to just do a simple activity of printing them, we'll have to write 200 print statements, right? Because they were all different variables. And over here, irrespective of the size of the array, these 3 lines of code, including the brackets, that is going to be helpful for us. Now, one of the most commonly used or commonly asked things in interviews and in school or college exams is, how do we find out the highest value in this particular array? Now, it's a very simple logic. The logic goes like this. We take the maximum and we just assume the first patient is our maximum age person. Let's assume that. The thing is, our assumption we'll keep changing this assumption as we keep going through the array. So we'll go through the array. Since we just assume the first value to be the maximum, I'll start from the second value, which is at position 1. And I'm going to go I less than, again, patient ages dot length and I plus plus. And I'm going to say, I'm going to compare if that patient's age, I assume my max to be 15 here first. If the next age, which is now I'm starting at 59, if I is 1, patient ages of 1 is 59. If the 59 is more than my assumed maximum, if my current value of the array is more than the maximum, then I'll simply go ahead and change my assumption. I'll simply go ahead and change my assumption. I'm going to go ahead and change my assumption. So now let's go ahead and actually see how this is going to work. So first, this is going to be 15. I is equal to 1. 1 is less than 5. The condition is true. Patient ages of 1 is 59. So max was 15. Now, is 59 more than 15? Yes, it is. So I'm going to change my max to 59 now. 59. Patient ages of 1. Then I go to I plus plus. I becomes 2. 2 is still less than 5. Condition is satisfied. Patient ages of 2. Now, patient ages of 2 is 67. My maximum so far was 59. And since 67 is more than 59, I'm going to go ahead and change my maximum to 67. Then my I becomes 3. 3 is still less than 5. The condition is satisfied. Is 31 more than 67? No. 31 is not more than 67. The if condition is not satisfied, I am not going to change my maximum. Same way, I'll go to 55. I'll reach I is 4. 4 is still less than 5. 55 is not more than 67. So that is not going to get changed. And over here, the final value of max is my maximum age. So when I print it once my loop is over, it should be 67. Let's go ahead and verify whether we're getting that answer or not. And yes, 67 is our answer. Now, let us understand this basic requirement. We created the array. When we created the array, we gave the values of the patients right then and there. That is not going to be the case in a general scenario. The thing is, for example, let's take a hospital. The hospital just knows that, okay, I can have a maximum of 200 patients, but I don't have the values of each of the ages of all the 200 right now. But I know for sure that there's a certain size for which I know that this is the maximum size that can be addressed, because this is a 200-bed hospital, for example. Now, in this scenario, wouldn't it be better that if we go ahead and have the opportunity of just creating the array and make sure we create enough memory for it? And then later on, when we know the values, we can go ahead and we can modify the values the way we want it to. Now, how do we do that? Now, we could do that in this particular fashion. I'm going to comment this and I'm going to get rid of these notations over here. And also, I'm going to comment this line for us right now. The way we do that is like this. We write int. Again, we have patient ages. And please note this is important, and this is the normal way of creating an array, because you will very rarely you will have the scenario like the way we described in line number 3. But this is the one which is going to be this case more than 95% of the time. So I'm going to say new int, and I'm going to say the size in this case, as I said, 200. Now, what does this line really mean? Before we understand this line, there's one important concept that I want to discuss about. In this example over here, when we created the array like this, the name of the array also indicated something very important. If you go back and rewind a little bit and you understand that I discussed right in the beginning that for an integer variable, 4 bytes of 4 bytes of memory is allocated. There are 5 integers, so a total of 20 bytes of continuous memory is going to get allocated. So I'm going to have 20 consecutive bytes getting allocated. 3, 4, 5. In the first 4 bytes, we are going to have 15. The next 4 bytes, we're going to have 59. We're going to have 67 in the next 4, then 31, and then 55. Every byte number in your computer memory has a memory or as a memory number associated with or as an address associated with it. So over here, let's assume that starting values byte number is say 720. We do not know what it is going to be. Wherever it finds 20 continuous bytes, it's going to allocate it over there. Let's assume for now it's going to be 720. The name of the array is actually the reference of the first value of the array. So this is the reference which is actually pointing to. So this is the value of the actual location of the memory of where the entire array is residing. And that's why the name of the array is also called as a word. This word is the word which will be used a lot. It's called the reference to the first value of the array. It's the reference, and that is why over here an array is sometimes called, or anything with reference, anything that's related to references, whatever we'll be looking at next will be all related to references. Anything that is related to references is a secondary data type, or the reference type, or the non-primary data type. Int, double, boolean, char, they are all primitive data types or primary data types, whereas the arrays, 1D arrays, 2D arrays, and whatever next we're going to do, they are all secondary data types because they themselves are not storing the data. They are actually pointing to the location where the data is stored. So that is what an array really means. A very important concept to know, especially when the program becomes large, it becomes very important for us to know that. Now, coming back to line number 23, when I go ahead and write this line, what I mean by this line is new. New means create memory. Create memory for what? Create memory for integers. Create memory for how many integers? Create memory for 200 integers. And wherever you create the memory, whatever is the first value's byte number is, please go ahead and assign that to patient ages. So that means a total of maybe like 800 bytes is going to get allocated, all these 200 values that are going to be there. Please note the default value is going to be 0 in all of them. They are all going to be 0. That's the default value that is given whenever an array is created. This is, say, location 1800, for example. We don't know. So then in that case, patient ages will be 1800. To verify our understanding, so let's go ahead and check whether the values are going to be 0 or not. Just for now, simply I'll just copy this piece of code from here and paste it, comment these lines of code for simplicity. Now it's 285 so that you can see all the output. And I'm going to run my code. Here you see that all of them will be 0 right now. All of them are 0. I can then go ahead and I can manipulate it. I can individually put the values just like how I saw in, just like how we saw in line number 6 over here. And also, if you want, you can go ahead and give any value in the for loop if you want to give it on the basis of a certain thing. Now, if you want, now let's create another array over here. Say over here, there is a new hospital that is coming up, which is going to take all the patients from the same hospital, which was there. So the new patient ages. is equal to. Now, if I write this to be equal to patient, now this is very important. What are we doing over here? What we are doing over here is we are not creating a new set of 200 bytes and allocating it, but basically we are copying the references of the array. That means, let's take this. If patient ages over here, as I discussed, if patient ages was over here was 1,800. Now, when I do line number 29, what's going to happen is you will have new patient ages, which is again going to be 1,800 again. That means there are two references to the same array. If over here, now how do we verify that it's really happening or not? Let's see that over here. Over here, I can go ahead and check patient ages of 1 is equal to 25. Okay. So over here, I change the first values to be 25. Now, over here, I change new patient ages of 1 to 44. Since both of them are pointing to the same array, what's going to happen is this. Now, let's understand this. Let me explain. So line number 28 is going to make this value as 25 and new patient ages of 1. That is the same array. It's the same set of 200 values that is going to get changed to 44. So the 25 is going to get overwritten by 44. So if I print now system dot out dot println patient ages of 1, it will be that changed value 44 because both of them are pointing to the same memory. Let's go ahead and verify that very quickly from our understanding over here. Yes, it is 44. This is the zeros of this particular for loop. So this is 44. That means gives us a proof that yes, both of them are indeed pointing to the same array. If they were different arrays altogether, then patient ages 1 would have remained 25. That wouldn't have changed. But the fact that when I did line 29, I made it point to the same set of values. And that is the thing we have to be very, very careful about whenever you are working with references. So this is the basic concept of 1D arrays. There's another way of going ahead and going through the values of an 1D array. That is what we're going to look at next. I'm going to very quickly clear the screen now. Now, for just 1D arrays or for anything which is related to a collection, a new concept was created of traversal. This concept of traversal is the for each loop, or also called as the enhanced. Remember, this is for the traversal and traversal alone. Let me uncomment this original patient ages value. The way we do it is like this. It's for int val colon patient ages. So now the difference between the regular way of traversing versus this is over here, val will automatically first not take the position, it automatically take the value from the 1D array. That means first the value will be 15, then it will be 59, then it will be 67, then it will be 31, and then 55. So over here, let's go ahead and verify whether we're getting the same output or not. Yes, we are. So indication that we don't have the positions, we have the values of the 1D array. Another loop, enhanced loop, normally used to just go through the values, used when you do not want to make any changes to your array, used when you just want to go from the beginning till the end and not in any special direction. So you have to be very careful about when to use this particular for each loop. Now, let's go ahead and look at the enhancement of 1D arrays called as two-dimensional arrays. Now, let us go ahead and understand the concept of two-dimensional arrays. Now, let us consider the scenario. Say, for example, over here, you have a school, you have a class which has to maintain the details of the marks of all the students in each of the subjects that they can take. So, say for example, for simplicity, for now, there are 3 students and the class only 5 students in the class. Each one of them can take up to 5 subjects. You want to be able to store the information of all the subjects for all the students. Now, for one student, we're going to have 5 marks. That is a 1D array for one student. If we repeat that for each student, we have nothing but a collection of one-dimensional arrays. That is what the next concept is. It's a 2-dimensional array. So I am creating marks, which is a 2-dimensional array, which is nothing but the collection of multiple one-dimensional arrays. So over here we have a 2D array where the definition is it is nothing but collection of multiple 1D arrays. Now, how do we go ahead and actually write that thing? How do we actually go ahead and create a 1D array? So, a 2D array. So over here, let's go ahead and this is the first student's marks. So I have say 5 marks, 15, 6, 18, 12, 10. Then I'm going to have another 1D array for the second student. So I'm going ahead and I'm writing like this. This is say 25, 10, 11, 15. Then I have another student's array, which is 30, 40, 4, 6, 10, and 15. So over here, what is happening is I have multiple 1D arrays. The collection of that is nothing but a 2D array. Now, in the memory, how is it going to get? How is it going to look? Let's understand that. Now, the first array is an array, so I'm going to make the memory for the array for the first array. The values are 15, 6, 18, 12, and 10. Assume that this location of this array is 700. Remember, every array has a starting byte number. That's the reference of the array. Now, let's take another example over here, which is the second array over here, which is 25, 10, 11, 15. This is location, say, 900. It can be any location. It need not be continuous, but the values in a single array will be continuous. And then over here, you have the third array over here, which is something like 30, 4, 6, 10, and 14. Let's assume that this array is at location 2000. Now, the collection of these multiple 1D arrays is marks. So what happens extra apart from the creation of this arrays? Another array gets created which stores the references of these arrays. So this is 700, 900, and 2000. This array is at a separate location, say for example 5000, and the name of the 2D array is nothing but the reference to this particular array. This is pointing to this is pointing to this, and this is pointing to this, and this is pointing to this particular array. So what is a 2D array? It is nothing but a reference to an array of 1D arrays. Now, I want to access the third subject's marks of the first student. How do we do that? You remember that every array has a position. Every array value has a position. So these references also have positions. These values also have positions. So 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, and 0, 1, 2, 3, 4. This one is not one. Clearly, I'm going to delete it. This is one. Each of these arrays are the arrays, the 0th array, the first array, and the second array, which is nothing but the references over here. In order to get the third subject's marks. So if I need the third subject, so that means for the first student, that means I'm interested in this particular value over here. That means first this is my 2D array's name. I first go to that particular 1D array. I get the reference and then I get the value at that particular position. So first I get the to that particular array number. So how do I do that? Very simple. It's the first array system dot out then println marks square. You can see that's the first student's array. Within that array, I need the third subject mark, which is this position number 2 or index number 2. That is going to give us 18 in this particular case. Now, say for example, I want to go ahead and change the second student's marks of the first subject to, instead of 20, right now it's 20, I want to change it to 25. So I can simply go ahead and say marks of the second student, that is nothing but marks position 1, and the first subject, that is 0th index. I change it to 25. So I'm going to go ahead and change it to 25 over here. Now, a very common way of representing a 2D array, it's also called as is a matrix. That's the other word that is used. It is a matrix. Where a matrix, if you know, a matrix in mathematics comprises of rows. These are the rows, which are nothing but the number of the multiple 1D arrays. And these are over here, the columns, which are the columns of the matrix. So the columns actually are nothing but the size of each 1D array, and the rows are nothing but the how many 1D arrays are there. So if I want to get this, how many 1D arrays are there, then if I want to get that information, I simply go ahead and write system.out.println, and I go ahead and say marks dot length. That is going to go ahead and give us the size of this references array, which is nothing but also the number of students, which is nothing but how many arrays are there in this particular thing. So which is going to be 3. If I want how many values are there for each student, I need to first go to that array, and then I need to go ahead and get that information. So system.out.println, I do marks of 0. The first student, if I want to do, that is how I go ahead and do that. Now let's go ahead and quickly run our things and check whether all of this is coming properly or not. 18 is the value for marks 02. That is what it is. Marks 10 got changed to 25. We are not printing it, but it has been changed. Marks.length is the number of arrays, which is 3, and marks of 0.length is 5. That is absolutely correct. Now, if the requirement is that let us go ahead and print all the values of the matrix. To go through all the values of a single 1D array, we just saw that we need a for loop, where we start from the 0 position and we keep going to the size of the array. We need to repeat that process for every 1D array. So we have to go through every 1D array. So I'm going to have a loop to go through all the arrays. So that is nothing but marks.length plus plus. For each 1D array, I need to go through the individual values, for which I need another loop. This is an example of a nested loop. J is equal to 0. J is less than marks of I dot length. The ith array's length. Whatever is the length of the ith array, I will go ahead and then simply I will go ahead and then print the marks at the ith position and the jth column, ith row and the jth column. So this is how this particular thing Yes. Let's go and find marks. And is gone. This is a column. Now let's go ahead and execute and check whether we're getting all the values. Yes, we are getting all the values. It's hidden behind all of this, all of the notation over here. I'm going to just see that if it is clear or not. So if you see the first second, I'm just going to comment this printing first so that you can see the values of the array. So 15, 6, 18, 12, 10. You can see that in the output over here. So 15, 6, 18, 12, 10. That is the first row or the first student's marks. Then we go ahead and print the second student's mark, then the third student's marks, and so on and so forth. Now, one of the questions that is asked that is it necessary that every array has to be of the same size in the matrix? No, absolutely not necessary at all. This can be say 25. There can be one more value. The second student has taken one more subject. The thing is, you still do not have to change anything from line 50 to 54 because you have written marks of I dot length. So marks of 0 dot length is 5. Marks of 1 dot length is 6. When I become 1, automatically that the inner loop will run that many times. So that is the beauty of a 2D array, that you can have collection of multiple 1D arrays of maybe of different sizes as well. Is it necessary to have there can only be 1D and a 2D array? Can there be a 3D array? Yes, there can be a 3D array as well. And that's why there can be a multi-dimensional array. But again, if you see the diagram, memory diagram over here, it's all a play of references. So a 1D array is a reference to the first value of the array. A 2D array is a reference to the array of references, which in turn point to each of the 1D. Now, let's go ahead and approach one of the most important aspects of Java programming, which is object-oriented programming. Now, I know I told that we're going to go and see object-oriented programming. Just one more concept about 2D arrays that I forgot. I'll just quickly go through that. Is that over here you saw that how we can create the memory for a 1D array like this, right? Int patient date is equal to new int, and you can do that. Now, same way, by the way, you can do that for marks as well. If you do not know the marks originally, but you know how many students are going to be there and how many subjects each student is going to take, then you can probably just simply go ahead and write that. Again, I'm creating my 2D array is equal to new int. I first specify the number of rows, which is nothing but the number of 1D arrays. Say I'm going to have 10 students. And each student is going to get how many subjects? That's nothing but the number of columns or the size of each 1D array. So each student is going to get 5. So over here, so 10 is the number of rows and 5 is the number of columns. So, and then we can go ahead and we can assign it. Again, we can use the nested loop to go ahead and individually assign it and do it as well. But remember, in this case, we need to specify the number of rows and the number of columns as well. If you want that one of them has to be of a different size, then you can go ahead and do that as well. Say, for example, the first student took 6 subjects. What's going to happen after line 42 is all the students will have, there will be a memory location for all of them for 5 subjects. So I think it's 5 here, 5, 10 arrays like that, 10, 10, 10. And then there will be array of reference where the first array reference 7,000 is pointing to this particular array. But then you later realize that, oh, you know what? This is not what it is. The first student has taken 7 subjects. So, but that's only the first array's reference that's going to change. So you can go ahead and you can write like this: marks. Go ahead and write that over here. Marks of 0. That's the reference. And then I'm going to create a brand new array for that. So it's going to be new int and say 7. Remember, each row is just a 1D array. So what's going to happen is a brand new 1D array is going to get created. So this was pointing to location 7,000 over here, but a new 1D array will be created with 7 values. This will be at location, say 8,000, and this will now no longer point to 7,000, but to 8,000 without affecting the other rows. The other rows are still pointing to their respective 1D arrays. So this is about creating a 2D array dynamically. Now let's go ahead and look at object-oriented programming. We will now start one of the most important ways of solving problems with the help of computer programming and Java programming is the object-oriented programming principle. Now, in the object-oriented methodology, what really happens is before we actually start writing the actual logic of solving the problem, what we first talk about are the entities involved in the entire problem-solving process. Let's say, take this example. Now, we take the scenario of, say, a student wanting to apply to a college or a university or anywhere locally. And there is an online application system that has to be developed so that students can apply and universities and colleges can access the data of the students and decide and give results based on the applications made by the student. Now, this is an application system where primarily you're going to be working with data of 2 main types of entities. One is a student, and the other is over here a university or a college. Now, in this particular case, what object-oriented programming principle says is first go ahead and design these entities. First, understand who are the participating people or the main things which are there. Now, if you look at these entities within themselves, they have some features or attributes or characteristics of their own. For example, a student has certain characteristics. For example, one of the characteristics of a student is a name. Every student has a name. Every student also has age. Every student also have obtained some marks, so they are having marks as well. They can be in one subject or in more than one subject or just the overall marks. They also have details about where they live, so their residence. They also have information about which school they belong from. There is also information about what do they want to study in college, the subject that they want to study in college. Study in college subject. And there are many more attributes. If you look at them individually, they are all of certain types of themselves. For example, age. Age is going to be an integer. If you express it as a whole number, it's an integer. Now, marks can be, if there's a single marks, that can be an integer or a double. Or if you want to store more than one marks, and as we saw over here, it could be an array of integers also. And if you look at the other things over here, this is name, residence, school, and the subject that they want to study, they are all going to be words. We have seen the data type called char, which only stores a single character. But there's another data type which we will be exploring in some time. We haven't yet seen, but these actually belong to that, and they are nothing but strings. A string is nothing but a collection of one or more characters enclosed in double quotation marks. We'll be coming to that very soon. So this is the string. This is also going to be a string. This is also going to be a string. And this is also going to be a string. So over here, what you are seeing that an entity is comprised of attributes, each one being of different types. This entity in object-oriented programming in Java is called as a class. This is the class which, if you remember, in every program of ours,
there's always the class name, which we have been writing. So in reality, a class is nothing but a logical name. So a student or a class over here, this an entity is a class, and the class is nothing but a logical name given to a group of attributes, generally of different types. It is not necessary they all have to be of different types. They can be of the same types also. But this is what the concept of a class is. Now, how does that translate into code? Let us go ahead and see that. So we just saw what a class means. A class is a collection of attributes, generally of different types. Now let's go ahead and see how can we code it up in Java. I'm going to share my screen now, and I have my REPL open over here. So over here, you can see the REPL. This is our standard class main, which always has been there. And I'm going to now create my own class. Please note, I'm keeping this class as it is. So I'm going to create my own class before this class. So this is a class. I'm creating a class called student. Open the brackets and close the brackets. So right now in our program, how many classes we have? We have two classes. One is student and the other is main. Inside the class main, we have public static void main, which is necessary for the execution of our code. So the entry point of our code, when you run the program, it's always going to be line number 9. Line number 9 is going to be our entry point, always. Because the JVM always looks for the main method to start executing any Java program. What we are doing on line number 1 is we are telling the compiler, hey, listen, I am going and defining my own entity. This entity right now comprises of, just takes two simple attributes. One is age, which is an integer, and the other is marks. Since the marks can be, or I would say percentage marks. Since it can be a decimal value, I'm going to take it as a double. Note that I have declared these variables right within the class. So over here, what I have right now is this is the class, which if you look at it is just a design. We are just declaring a class. It is just a design. It's like a blueprint. Now, for example, whenever, let's take an example of any construction of any building or any house or any bridge or anything happens. First, the architect goes ahead and makes a plan on paper. And on the plan on paper, they list down all the things that are going to be there in the house, for example, right? So if it is going to be a building of 20 stories, so all that information, how each house is going to look like, all that information is on that piece of paper. That's the design of that particular class, of that particular entity. The same way over here, we are telling Java that I am just creating an entity. It is only comprising of two things. One is age and percentage marks. That is it. That is all that is there. What the compiler does, it understands that, and it understands that, okay, you are creating a design right now, which you might use in the future. Now, these age and percentage marks, they are your attributes, as we discussed earlier. One of the names for them is called as data members. They are the data members of your class. Now, the thing is, you're not going to pay money to the architect just for making the plan on paper. You are going to pay money to the architect only once the architect has constructed the house based on that plan. Now, how do we do that? Remember, our execution is starting from line number 10 now. Line number 10, that's the entry point of our program. So what we are going to do now is we are going to create the actual building based on our design. Our design
is the entity that we have created so far, and that is the class student. And it is comprising of the two attributes. We want to create an instance, an actual reality based on that entity. How do we do that? Very simple. We do it like this. We say student, student. The variable name is student. Remember, we are creating a variable of the class over here, which we have created, is equal to new. The word new has come again, and student. This is the class. Student is the class, the capital with the capital S is the class with which what we have created. So basically, what you did is just like how we've been creating int a, double value, boolean x. Same way, we have created a student of type student. Therefore, a class is also called as a user-defined data type. You have defined this data type and you are creating a variable based on this particular data type. Now, let's understand this line 11 a little bit more in detail. New, if you remember, in arrays, in 1D array and 2D arrays, new was nothing but create memory. Create memory for what? Create memory for a student design. Now, what does the student design compose of? It composes of age and percentage marks. So a memory location is allocated, which comprises of the memory for age and which comprises the memory for percentage marks. I'm writing it short right now. This is the house that actually gets created. This house gets created. This whole house is getting created at a certain location called, let's say, 4000 byte number. Student over here is pointing to the location where this house is created. So something that resembles what we have seen, a student is therefore a reference. This particular memory location comprising of the data members is the object of the class. Very important word, object, or also called as the instance of the class. Object, instance, same thing. Whenever an object is created, something is filled for each of those data members. For age, since it's an integer, the default value is 0. For percentage mark, since it's a double, the default value is 0.0. These variables belong to a particular instance. Therefore, they are called data members, also called as instance variables. All these are synonyms for the data members or attributes of a class. So we first created the design, we told what we want in our design. Then we went ahead in our public static void main, we created an object of the class and we stored the reference in that particular object. Now, let us go ahead and say that, okay, by default, the age of this particular student is 0. What if I want to go ahead and change that to, say, 15? So I'm going to go ahead and say a very simple thing, student, that's the name of the variable. Then I'm going to use the dot operator. Student dot age is equal to 15. So student is residing at location 4000. I go to 4000 and at 4000, I change my age from 0 to 15. So my age changes from 0 to 15. This is the dot operator. On the right-hand side of the dot operator is the attribute or the data member or the instance variable. On the left-hand side is the reference to the object. Reference to the object. Or I would say that sometimes many people go ahead and actually say that, okay, student is not a reference. In reality, it is a reference, but they quick way of saying student is the object of the class. Student is object of the class student with the capital S. Does it have to be student only? Not necessarily. It can be anything. Now, I want to give the value to percentage marks as 75.8. So I can go ahead and do that. I can say student dot percentage marks is equal to 75.8. 75.8 percentage. Is it necessary that I can create only one particular object on the basis of that particular class? No, not at all. I can go ahead and create as many objects as I want. Let's go ahead and create another object. I'll create another object. So student, say I'm going to create stu1. stu1, that's stu is equal to new student. What happens when you do like this on line number 24? It's like creating another integer variable. Like you have int x and then you write int y, that you create another variable. Same way you can go ahead and create another variable. Over here, stu gets created. Stu is created at some other location, say 4,500, can be any location. And at 4,500, again, you have the same things over here. You have age and you have percentage marks, and they are 0 and 0.0, and they are at location 4,500. Please note, this object has got nothing to do with this particular object. And each one of them have a copy of the instance. I can go ahead and change these values. So I can say stu dot age is equal to 15 and stu dot percentage marks is equal to 46.7. So of course, this will then go ahead and change the values in this particular location. So the age will become 15 and percentage marks will become 46.7. And by the way, this had changed to 75.8. So a lot of things we have seen. A class is an entity, which is a design or a blueprint where we define what our attributes are going to be. Then when we want to really work with the design, we'll have to first create an object of that class using line number 11, and then give values to each of those attributes. And then I can go ahead and then I can work with them. If I want to do a printing and everything, I can go ahead and do that. Please note, I cannot access the attributes directly. I cannot write system.out.println an age. Nope. I cannot write system.out.println percentage. No. I will need to find which instance, which object do you want to talk about? Take that object and then access the attributes of that particular object. This is the very base of classes and objects. We are going to now go ahead and see more concepts of classes and objects using the same class. Now, we saw that over here, how we can define a class. So we applied one principle of object-oriented programming, that's defining an entity and defining the attributes of the class. And then we also saw that in another class where we are actually going to start executing the code, we created an object of the class, and then we can go ahead and change the values the way we want, however we want it. We can print it, we can change it, we can do whatever we want. Now, the thing is, in reality, that is, again, one of the things which object-oriented programming says not a very good idea. Now, how did this example come from? Now, a very simple thing is this over here. Let's take an example of a vehicle or of a car. Now, in a vehicle, in a car, you can say that over here, a car is also like an entity. Now, in a car, I'm very poor in drawing, so excuse me for that. But the thing is, one of the things which is there is an engine over here. Normally, in the beginning of the car, it's an engine. It's my word, engine. The way for you as a user of the car to start the engine is when you enter over here. There is an option in the steering wheel close to the steering wheel to insert the key. or there can be a push button based on the type of car that you're using. That's the only way to interact with the engine. Let's take another example again with the car. You have the windows. Now, normally most of the windows nowadays are operated by a button. If you want to get the windows down, then you need to press the button and you need to get it down. And if you want to get it up, then you need to use the button a certain way to get it up. You can't get the windows down with your bare hands. Right? Just do it like that. It won't work. You can't really go ahead and access the attributes of an entity just like the way you want. You can access the attributes via the functions which have been created to access them. The function used to access a window is the button. The function which is used to operate an engine is the key. If you want to have a gearbox, change the gear of the car, there is a gearbox provided for you to change the gears of the car. If you want to clean the screen of your car again, you have a proper device which you switch on, the wiper starts wiping the screen of the car. You do not have direct access to the attributes. You have it via a certain functionality which has been provided. Another example. Let's take the example of an ATM. Now, you operate the ATM with a card machine, with a card and your machine, and the machine and your card. Now, when you insert the card, your details pop up. Can you go ahead and actually change any detail about your account on the ATM machine? I don't think so, not really. You can't go ahead and change the name on that account. No, it doesn't give you that option at all. Not only that, sometimes some ATM machines, some banks are quite restrictive and they might not even allow you to withdraw all the amount also in one go or deposit huge amount in one go. They have certain limits that are set. Again, the ATM application is giving you the access to the attribute, but it's still not allowing you to go ahead and change it the way you want. It is giving you restricted access, or I would say it in this way, it is giving you as much access as you are needed to have. With this concept of how we work with our day-to-day life, the same thing was introduced in programming as well. Now, how was it introduced? Let's go ahead and see the example. There was an introduction of something called as access specifiers. Now, a good object-oriented programming principle says that ideally, you should not be giving direct access of the attributes outside the class. Therefore, they created one of the most restrictive access specifier called private. Private means this attribute, this data member cannot be accessed outside the class. Now, remember, I can still go ahead and create a building based on my design. I have created an object, but if I try to do student.age is equal to 50, I am not in the same class. Note that I am not in the same class. I am in a different class altogether. Now, when I try to write line number 12, it should be giving me an error. Let's try to execute and see whether are we getting any problems or not when we compile code. Compiling error. Age has private access in student. I cannot go ahead and access it anymore. But then the question comes, okay, I did not give direct access to the engine, but there needs to be a way to create the key so that I can access the engine. So the data members ideally are supposed to be kept private. In most of the scenarios, you will see that they are kept private. But then there needs to be a way to create those functions which are allowing to access this particular data. Remember, what are these functions? These functions are called as methods. What is a method? It's simply nothing but a block of code which is performing a certain task. The purpose of the key is to interact with the engine and to start the engine if you rotate it in a certain way. The same way, we can go ahead and create a method. Now, let's go ahead and understand how do we create a method and which are the different parts of a method. First of all, there is a name to a method. Just like there is a name to a data member, there is a name to a method also. So over here, I'm going to call it change age. That's the method that is there. The next set are the parameters to the method. What information does change age need apart from the knowledge about the data members? What the key, when you are inserting the key, you don't need to tell where the engine is. That particular whole device of starting the key knows exactly where the engine is. That's not the problem. But what it needs to know from you is, first of all, which key are you inserting and how are you rotating the key, right? Based on that, I will decide whether to start the engine or not. In the case of change age, I am just saying that this is a method and I'm not giving any other external information. I just want to change the age and I want to make the age to be 15 always. Then that's why there are no parameters in this particular method. Then what we're going to do is we're going to define the body of the method. Now this body is the place where this guy will actually do the work. That means this is the place where actually we will go ahead and start the engine. So what will be there in this body is nothing but the steps to go ahead and start the engine, whatever the steps might be. In this case, our requirement is very simple. We want to change the age to 15. So I will go ahead and change the age to 15. So I'm simply write age is equal to 15. That is all that is there. Once I am done defining what the function is going to do, next thing is over here is I'm going to tell what am I giving back once this activity is done. Once the engine is done, the engine is started. That's it. Nothing. It doesn't give back anything. So in that case, there is the fourth part of a function, which is called as the return type, which in this case, I'm not going to give back anything. So the return type is going to be void. And this is a function. This is a method. You want everybody to be able to access this method. Therefore, the access specifier for a method is usually public. So you have the data members which are kept private, and you have the methods which are kept public so that people can go ahead and access it and use it and work with the data members or the instance variables in this case or the attributes of the class. So a quick summary of whatever we have done so far. I'm going to mark all of them annotated so that it's easier for us to understand. So I'm going to use a red ink for us. Just go to this here. So private is an access specifier or access modifier or access specifier, however you want to call it. So is public. Public is also an access modifier. Remember, public means can be accessed anywhere. Any part of the code can be accessed anywhere. This is the return type. This is over here the name of the method. This over here are the parameters. Parameters are nothing but the information needed apart from the data members. Why? Because the methods already have access to the data members. And note I'm defining this method inside the class. This is very much inside the class. And of course, what we have in the curly brackets is the body of the method. Now, let us go ahead and use this method in our main code. So over here, I cannot write student.age is equal to 15. So what I can do now is I cannot access that attribute, but what I definitely can do
is I can access the method which has been created. Which object is going to call the method? The student object wants to call the method. So I'm going to say student dot change age. You can see that it's now giving an option to call change age. So change age is the method. No parameters being passed. I will need to pass without the parameters. Now, how can we really verify that the age has been changed? Let's go ahead and create another method where I am just displaying whatever the age is. So I'm going to make another method called public void display age. And I'm simply going to say system dot out dot print demo. And I'm just going to print the age. And after I call the change age, I'm going to go ahead and call the display age. Student dot display age. And I'll do one more thing. I'll show you the display. I'll show you the age before that as well, so that you get an understanding that, okay, it is indeed 0. Now, let's understand the whole process of how the code is going to be working. Now, student is going to get created. Student. Remember, it's a reference. This is the location 3000. At location 3000, you're going to have your age and you're going to have your percentage marks. Right now, we're not working with the percentage marks, but we're going to work with it soon. So age is 0 and this is 0.0. Now, when I go ahead and call display age, your control is transferred to display age. Display age remembers, okay, I have been called by which instance? I have been called by the instance student. So it remembers that. How does it remember that? We're going to see that also very soon. And it is just going to go ahead and say system.out.println age. Whose age? The age of the instance which called the method, which is this particular instance student, and student age is 0. So this should be displaying 0. Now I'm going to call the change age method. Now my control is going to get transferred to the change age method. Again, change age remembers that who called it? Student called it. That's the same object which is called it. Now the age has changed to 15. So student's age will change to 15. And that is it. Nothing else is done. It comes back. Then it goes to line 26. Now when the line 26 is called, display age is called again. It remembers again that student called it. Now whose age? Again, it is student's age, but this time the student's age has changed to 15. So you will see 15. So the output first should be 0, and then the output should be 15. Let's go ahead and run my code. Yeah. 0 and 15. Two things proven. First, we prove that, okay, it works. 0 is the initial value that's given by default, and then change it did work, and it automatically reflected over there. So this is all about access specifiers and methods. Now let's go ahead and define some more methods. Now, the thing is, over here, I'm going to clear this annotation so that I can go ahead and write more stuff. Now, the thing is, over here, one of the important things to note is that we are allowing the age to be displayed, but we can't change age to any value we want. We can change age to only the value 15. Why? Because we defined a method which can only change it to 15. What if I want some flexibility where I'm allowed to change age to any value I want? Now, in this case, what I'm going to do is I'm going to go ahead and create another method. Public. Again, this method will not give back anything, so I'm giving it void. Change age. I'm calling it change age again. But this time, I'm going to pass a parameter. And this is the parameter, which is an integer. So integer your value. Whatever your value is, you want to give it. You can go ahead and give that value to change age. And then I'm simply going to write age is equal to your value. Remember, over here, I have gone ahead and I have created something called as a parameter.
Now, this is a parameter, which is of type integer. Very common mistake that is made. People try to use a parameter in one method in some other method. No, you can't. This parameter is local to the method. Local meaning it can be used only in this method only. You can't use it anywhere else. You are declaring that there is this particular function is going to take a parameter which is going to be of type integer. And we are saying that whatever that integer value is, please go ahead and change the age to that. How do we go ahead and use that? Now, let's try to do that with the other student that we had created over here. But I'm coming this one. Oh. Stu. Now, I want Stu's age. Now, if I call change age, Stu's age will also become 15, but I don't want that. I want Stu's age to become, over here, I want Stu's age to become 18. So for that, I will not call the change age function. I will call the change age again function. That's not a good name, by the way, but yeah, for now I'm calling it like that. But that's so Stu dot change age again. It is saying that you need to give, it's taking an integer as a value. So you can go ahead and give that value, say 16 as the value that you want to go ahead and give it. You can give it 16. If you want, you can do it like this. Or if you want, you can create another variable in your main method, which is, I remember, a local variable, say int value equal to 16, and you can pass value over here. That is also fine. Now, let's understand the whole process of how this thing is going to work. Stu is getting created. Stu is getting created at, say, different location, say 4,500. Remember, all this is the same. That execution is not going to change. At 4,500, you have, again, age, which is 0. And you have percentage marks also, which, by the way, is 0.0 only. I create a variable called value. It's a normal variable, normal integer variable, the value of which is 16. I'm going to call the change age again function. Who is calling it? Stu is calling it. So change age again function is there. The value of value is gone ahead and passed and stored in your value. So your value is a local variable, which is going to take the value which you passed. What value did you pass? You passed the value 16. So the value 16 is going to get transferred over here, copied over here. Now this is the age. Whose age? Who called the function? Stu called the function. Stu is at 4,500. 4,500 age will change to 16. That is how this function is going to work. Nothing else there. It comes back. Now let's go ahead and verify whether it happened or not. What we're going to do, we're going to do Stu dot. Which function will be called? We'll call the display age function on Stu. If display age is being called by Stu now, you print Stu's details. So I'm going to comment this for now for our understanding, and then run this and see whether the value has indeed changed to 16 or not. Yes, it has changed to 16. So this was an example where a method is taking a parameter. Is it necessary that it has to be only one parameter? No, you can pass any number of parameters. Let us very quickly go ahead and see another method where I am passing 2 parameters to this particular method. Drawings. I am seeing there is a way to update the age. Now, update the age can be increasing or decreasing. So I'm going to say public void update age. And this is the value which I wanted to update it to. Now, updated by. Now, if it's an increasing, I'm passing a Boolean. Boolean is increasing. And then what I'm doing, I'm writing our normal code. If over here, if is increasing is equal to true. Either I can just write if is increasing, or I can write if increasing equal to true. If it is true, then I will update my age by this value, age plus equal to value. Otherwise, I'm going to say age minus equal to 12, just like how we have been writing code normally over here. That is how it is going to be working. This means it is value, not value. Value is value. Now, let's go ahead and do that for Stu. Now we display the age. Now I'm going to say Stu dot, and I'm going to say, what is the method called? Update age. Update age. Yeah, update age. I want to update it by the value 5, and this increasing is false. I want to actually decrease it. So I'm passing false as a value. And let's go ahead and display age for this one. Display age. So first, Stu gets the age 16. I'm going to call the update age. The value is going to be 5. Is increasing is false. The if condition is not going to be satisfied. Stu's age itself is going to reduce by 5. It will become 11. So when you call display age, it should be 11. Let's go ahead and see that. Yes, it has become 11. So two types of method. One, no parameters. One with one parameter and one with two parameters. Now, let's go ahead and see how can we create a method which returns some values. Say, for example, I am only interested in, like, I want to get a proper, I want to print a particular output message saying that, okay, the age of this particular student is 16. I just want the age of that particular person. If I want, I can go ahead and make a method in the class and that can do your work. If not, another way could be like, so I'm going to make a method this case, and I'm going to return the age over here. Public int get age. I'm going to return an integer. This method is returning an integer. How do I do that return? I simply say return. I want to return the value of the age. Return age. Return is a keyword. What it does is it gives back the value, whatever is there. Not only does it give back, the other thing what it does is it also goes ahead and stops the execution of the function. That means if you write anything after the return, it might as well be considered useless. Why? Because that is not going to happen. Return means go back. It will go back immediately. Now, how do we go ahead and print this particular method? Let's go ahead and see that. Now use this method. Again, I have a display age, all of that stuff. And I'm going to comment these lines for now. And I want to call the get age method. So what I'm going to do is I'm going to store it in an integer. Now, this is an example where a method returns a value. If a method is returning a value, it's returning an int. So you should be able to store it in an int over here. And I say stu dot get age. Whatever the age is, that value is returned and it's going to get stored in val. And then I can go ahead and I can print whatever message I want. I can say the age is plus 1. So this is how the method is going to be working. Now let's go ahead and see if it is actually giving us the answer that we thought or not. So the change age for Stu is going to make 16. And I get the age, I'm going to get that particular age. So once again, a quick flow through the code. Get age, go to get age. Who called the function? Stu called the function. I'm going to return the age, which is right now 16. 16 is going to get returned and be stored in val. And I'm going to display the val. Over here, you saw that this particular thing just returned the value of one of the data numbers. This is one of the most common concepts in object-oriented programming, where such a method is a special method which just does nothing else but just gives back the value of the data member. Why does it give back? Because the data member is private. So you created a method so that you can access the value, just give back the value. Such methods are called as getters, or also called as accessors. Ideally, you should be creating getters. Normally, they are created for each of the data members that you are probably going to be working with. If you want to access the values for each one of them, you'll create the getters for each one of them. So for example, if I want to get the value of percentage marks, I will have public double get percentage marks. And then simply I will go ahead and I'll just return percentage marks. This is a getter. If you want to just change, now the change age over here, the change age again over here is actually setting the age to one particular value only. You're modifying the value of one particular data member. So the change age again is actually called as a setter, which is setting the value to a specific value of a data member. And ideally, the name of this method should have been, instead of change age again, it should have been set age. Set age should have been the actual value of this data member. Setters are also called as mutators. Mutators, that is the other thing. Mutator, which changes the value of the data member. Set lowercase. So we saw the example of, I'm going to get it back again because error. Yeah. So setters, getters, setters change the value of a data member. Normally the return type is void. Getters, the return type of the method is the return type of, or is the data type of the data member, and it simply just gives back the value of that particular data member. So is return, can return be used only in this particular fashion? Not really. Say, for example, I want to know whether the student has achieved a distinction score or not. I would like to know that. So another method could be public. And now if the student has achieved a distinction, I want to give back a true, otherwise I want to give back a false. That means the return type in this method is a Boolean. So has student, or I would say, is distinction score. And what it simply does, so thing is, if the marks is more than 75, is it marks or sorry, not marks, percentage marks. That's the so if percentage marks is more than 75, then I'm going to return true. Else, I'm going to simply return false. So this is an example where you're returning something based on some processing over here. Right now, we do not have a setter for the percentage marks. So I'm going to quickly go ahead and create one. So public void set percentage marks and say double value. And then simply I'm going to say percentage marks is equal to the value. Let's go ahead and do that for Stu again, please. So Stu's age and everything is done now. Let's work with marks. So Stu dot, I'm going to say set percentage marks to 76.5. And now let's see whether the student has achieved a distinction or not. So Boolean answer is equal to Stu dot get is distinction score. It does not take any parameters because it just needs to work with the percentage marks, and I can go ahead and print my answer over here. And let's go ahead and execute and check. And let's see whether Yes, it's returning true. If it was not 76.5, it's 70.5. We should be getting false. We should be getting false over here. Let's see if we get false. This is false. So this is a method. How do we create different types of methods? How do we return values from the methods? And how do we pass parameters to the methods? Let's go ahead and understand a little bit more concepts of classes and objects.
All right, guys, we are halfway there, and 2.5 hours approximately of content left for us. Just pause for here for some time and put in a request that if you have liked the video so far, please go ahead and give us a quick like and also subscribe to our channel. Now let's go ahead and proceed to our next concept.
Now, if you remember that we have been saying that whenever a method is called, the method remembers which instance called that particular method. Correct. Now, how is it able to remember that particular thing? So now let's go ahead and I'm going to call this setting. As I said, setters ideally should be, normally they begin with the word set, get or set, setter, set. Now, the thing is over here, let's go ahead and see this example over here. Now, when I have student and I'm going to say student dot set age, I want to set the age of student to say 20. Again, let's understand from the concept of references once again. Very important. I have student. This is at location, say, it was 4,000. Let's take it as 4,000. Whatever the reference originally was. So 4,000 is 4,000. At 4,000, we have age, which was 0 initially. After line number 55, it was 0. And the percentage marks also was 0.0. Now, when I call set age, over here, when you call set age, that means let's go over here, that is line number 12. Now, in the time when we call set age, inside every method that we have over here, something gets created automatically. And that something is called as this. T-H-I-S. This. This is a keyword which is nothing but going to be storing, it is going to be storing the reference of the object calling the method. Reference of the object calling the method. Student was calling set age. Down below, you saw that student was going ahead and calling set age. So that means when set age is just called, this gets created automatically and student's reference is stored in this, which is in this case 4,000. Not only that, in front of all the data members or the instance variables used inside the method, this dot is added automatically. It's automatically added. Even if you don't write it, it's already present. And that is why it was what was actually written over here, which you can also write explicitly, is something like this. This dot. It is 4,000's age, which is getting set to whatever value you passed over here. This dot age is equal to age. So that is why over here it was understanding that since student called it, I'm going to change student's age because this line was not just age, it was actually this dot age. And let me tell you, it is preferred that you write this dot in front of all the data members inside the methods. One very good purpose is so that you can understand which one of them are local variables and which one of them are the instance variables. Over here, your value is a parameter. It's a local variable. You will not go ahead and write this dot in front of that. But age is an instance variable. So you can go ahead and write it over there. Whenever your method becomes too complex, it is always a good idea to always place this dot so that anyone else who reads your code can understand that, okay, this is the instance variable that you're talking about. Sometimes some classes run into thousands of lines of code. It becomes very difficult to actually go ahead and debug, okay, which are the data members of that particular class. So writing this dot explicitly always helps. Now, that's not just the first one advantage of this dot. There's another advantage of writing this dot. And in this scenario, what I'm going to talk about, it becomes a must that this dot is used. Now let's try to make over here, we have the setter for the percentage marks. Instead of, I'm giving the parameter, the name of the parameter as percentage marks only. Can I give the parameter the exact same name as the data member? Yes, I can. So this is percentage marks equal to percentage marks. But now the question comes, which percentage marks is what? Which one is the parameter and which one is the data member? Now, if you don't write anything, both the percentage marks will be considered as the parameter, or even if you have a local variable, it will be considered as a local variable. So that means the data member percentage marks in this piece of code is never going to get changed because the default preference is to the local variable or the parameter that is there in the case when both of them have the same name. So now it becomes necessary that you go ahead and you explicitly state which one you want to be as the data member. That is why you go ahead and write, I want the left-hand side to be the data member. So I will write this dot percentage marks is equal to percentage marks. So now the left-hand side percentage marks is no longer going to be this, but it is going to be considered as the data member, whereas this continues to be remaining as the parameter. So when you call the method, this refers to the calling object. Calling object says that, okay, this is the percentage marks, this is the value. This value will be used at the right-hand side, and that will be assigned to that object's data member called percentage marks. So that is the concept of the reference of this. It is implicitly there. Many people don't go ahead and even write that, and that's a very powerful thing, to be honest. It can be used for various purposes. Many things happen automatically because of an automatic inclusion of this. Another important thing, you can't go ahead and change the reference of this. You can't assign it a value. It's automatically assigned based on which object calls that particular method. So this is the concept of this. Now, let us go ahead and see the next concept over here. Let's go back and rewind a little bit. And I'm going to clear my screen. And let's understand the concept of something which is very important right now. Let's come back on line number 55. The thing was, whenever you created the object the first time, they were getting set to some default values, 0 and 0.0 for the age and the percentage marks. And the thing is, when we needed to have the setters to set for each one of them. Imagine a class has 100 data members and you will have to be able to call set so many times. Could there be a way where we could tell, while creating the object itself, we could tell that, okay, you know what, just go ahead and set it to some values that we want as soon as the creation is done. Basically, doing some work of what the setter is doing. Yes, we can do that. And that is done by something this over here that you see. You see that I'm just writing new student. I'm writing new student and the brackets. And so far, whatever you have seen, that is normally used for something like methods, right? You see display age, the brackets, change age, brackets, right? Over here, set percentage marks, the round brackets. this is the class which is followed by the round brackets. So something like a method which is going on over here. Now, you can call it like a special method, but this thing is called as a constructor. What is a constructor? The duty of the constructor is to be used. It takes part in the creation of the memory for the data members. And this is the guy which automatically assigns the value to the data members. Just like how this exists in each of the methods automatically, the constructor also exists in a class automatically. How does that constructor look like? Let's go ahead and see that. So I'm going to go up, I'm going to scroll it, I'm going to define my constructors. Normally, just after the data members, a good thing would be defining a constructor. Remember, what I'm writing is present automatically. This is the definition by default. It exists automatically. And that's why this is also sometimes called as the default constructor. Now, how does it look like? It has the same name as that of the class. No parameters. It does not even have a return type, not even void. And it has a body which is setting your age to 0 and your percentage marks to 0.0. And do we want, what could be the access specifier of this? The access specifier for this over here ideally should be public. Why? Because we want people to be able to create objects of our design. We want people to be able to create buildings of our design. So the access specifier is public. If you see, it looks exactly like a method, but it is not a method. The major difference is it is only called when you create the object. That's the only time when it is called. And it gives an initial value to the data members. This is the default constructor. It does not have a return type. The only name it can be is the name of the class. So some points can be name of the class only, no return type, and present by default. I've already written that. Now, do you want to change? Now, the thing is, like, I don't want the by default the age to be 0. I want the by default the age to be 12. Okay, go ahead and explicitly write it like the way I wrote it and change it to 12. So now that means whenever I create an object, it will be created with an age of 12 and the percentage marks is 0.0. So let's go ahead and check whether student dot, let's call the display age function and see whether it's working fine or not. Yes, student dot display age, it is getting created with the value as 12. So over here, we changed what the default constructor is going to do. Also, please remember, if you create your own constructor, Java says that, okay, you are taking over my duty. I am not going to be creating the constructor which I was going to construct by default, since you're already doing my work. So please go ahead and do that. So absolutely fine, no problem. That is great. Now, can I create only one constructor? No, you can have any number of constructors, but there has to be a constraint. What is the constraint? I can have one more constructor, which is initializing only the marks of the student, or I would say the age of the student. And what I am going to say over here, remember the parameter has the same name as that of the data member. Again, what comes into the picture? This dot. So I'm going to say this dot age is equal to age. The data member's age should become the age value which is there. Just like how a method can have parameters, even the constructors can have parameters. So I can have multiple constructors over here in my class, but they have to be differing on the parameters. How can they be differing on the parameters? Either their type of parameters are different, or their number of parameters are different, or their order in which the parameters are written are different, or combination of one or more of these things. That means we can have the constructors and any number of constructors as long as we go ahead and maintain this particular order. This concept of having multiple constructors, they are all the same name because they have to be the name of the class, but differing in parameters is called as overloading. This is the constructor overloading. Overloading, very important object-oriented principles. The ability to have multiple things with the same name, but with varying parameters. Can I go ahead and create one more constructor with setting both the age and this? Yes, I'm just going to copy this. So I have age. See, if you see, it's already giving you duplicate method student int in type student. There's already a duplicate. Even if I change the name, it doesn't make it. It will still give that error. Duplicate method. I cannot have the same thing over here. So I think I'm going to have over here double mark. So this dot age is equal to value. This dot percentage marks is equal to marks. Again, another constructor. I have overloaded this time. I'm differing in the number of parameters. So I have one with no parameters, one with one parameter, and one with two parameters. How do I call this over here? Very simple. I can go ahead if I want to call the student. Now I want to create it with the constructor with two parameters. Then what can I do? I can simply go ahead and pass the two parameters. The first one over here was an integer and the second one was a double. So I'm going to create the first one as an integer, so 17, and the second one was double, so 77.8. And now when I display the age would be displayed as 17. Let us go ahead and execute and see whether the age is 17. Yes. So the object is now getting constructed with the other constructor, which has two parameters. Once the memory is created, whatever the value assigning we are doing, that value is going to be assigned, and then the whole thing is going to go ahead and work as always. And if I want to create it using the first constructor alone, so I will create it with the first constructor. And if I say 17 alone, still be 70 because we're not setting the marks in that case. So it will still be created. If I try to create it, now what if I decide to go ahead and comment this constructor? Okay. And then after that, if I try to go ahead and change this instead of now I try to do this, I cannot any longer do that because the default constructor is undefined. And as I said, if you define your constructors, the Java language will say that, okay, you know what, I'm not going to have my own constructors. So this is the example of constructor overloading. Now, we saw what constructor overloading is. Now, the thing is, before I move on to the next concept, one very important thing as a developer you should be knowing. If you see that this code is becoming very complex and very long, right? And okay, this is still showing an error. Let's go ahead and fix it with one of the constructors in the first one. Let's pass 18 for now. Now, the thing is over here, ideally, one of the best ways to organize your code is to have different files for each of the classes. So let's go ahead and create a file. And I'm going to call it over here student.java. It's giving the actual of that. So student.java is what I'm going to create. It gets created. I'm just going to copy and cut the code of whatever I wrote in the student class. And remember, our methods are public. That means they can be accessed anywhere. This over here I'm going to put it student.java over here. And now it's better. Now the thing is, this is main.java, student.java. So I have the different classes opened over here. So I can see both the classes simultaneously and I can go ahead and write my code. It's much more understandable and much more readable. And things still work the way it is, even if it's a different file. Remember, because they are public. And there's one more reason why they are also working, but we'll understand that reason in the later. Now, let's go ahead and see whether everything is working fine. We have given the ages. If you see in the compiling command, both the files are getting compiled, main.java and also student.java. Both the files are getting compiled. So that is absolutely fine. And it is working absolutely okay. So good practice, each class in its own file. And ideally, the name of the file should be the name of the class. Try to maintain that nomenclature. Now, let's go ahead and understand one more thing. So we discussed about constructors getting overloaded. Is it possible to overload methods as well? For example, now set percentage marks. It is possible that the marks that I want to set it to, yes, I know my percentage mark as the data member is a double, but it can be an integer as well. But the parameter right now is taking as a double. So I can go ahead and overload the methods as well. Please note, concept remains the same. Overloading of the method is exactly the same. Now, over here, copy paste this. If you see, the parameters are exactly the same, even if it is given duplicate method double. Type parameters cannot be exactly the same. You cannot have two methods with the same thing. So the thing is, then if you say, okay, what if I change one of their return types to say over here double? I return the value as well. And I do this thing and I return the percentage marks. I return this dot percentage marks. What if I do that? Still, it is not doing it. Over here, still it is not working. Why? That means in overloading of methods, very common mistake that is made is that people try to differentiate the methods not on the basis of the parameters, but on the basis of the return type. Difference in the return type doesn't make any change. It has to be the difference in the parameters that are there. Let's compile and see whether is it working or not. It should be giving us an error if we try to do that. It's compiling both the files main.java. See, is already defined in class student. So it doesn't look at the return type at all. It is looking at just the parameters because that is the thing which is making the call or which is going to be deciding which method is going to be called. Now let's go ahead and change it to an integer. And yep, error gone. Now even if this would have been void, would have been perfect, absolutely no problem whatsoever. Removing this as well. So yes, no problem. The parameter, the different types of parameters that are there. So that is why it is going to go ahead call the method. So now the thing is over here, if I want to call it, if I do student dot set percentage mark 15. Now I'm passing 15. Remember, 15 is being looked at as an int. And since it's an int, it tries to find for an exact match. Is it there? Yes, it's there. So it will go in that. All right. So this is about overloading, one of the most important aspects of object-oriented programming. Once again, the definition of overloading: methods or constructors having the same name but different parameters. The parameter difference can be in terms of the type of the parameters, the number of parameters, or both, or even the order in which the parameters are written or they're defined in the functions in one of them. In method overloading or function overloading, the return type does not make a difference in differentiating between the two functions. Now, this was all about classes and objects and the basics of classes and objects. There's one more important concept. But now let's go ahead and understand something which is very, very, very important. Now, the thing is, now Java as a programming language has made a understanding that your entire thing has to be on the basis of the concept of a class and an object. That is why you have everything as a class. Even for the most simplest of things, you need a class. That is what the whole idea is. For go ahead and make our life easy, what Java has done is Java has created the concept of a package. Java has created multiple packages. Each package has multiple predefined classes. One such package, which is available for you to be used in any way, you can use any class from that particular package. That package is the lang. And by the way, the lang package, a package, is nothing but a collection of classes. A simple definition. In the lang package, there is multiple classes that are there. And by the way, you have been using one class right since the first session that we have been writing, right since our first program. That particular class is system. System is actually a class of Java, already defined. And we have been using it to do a very simple activity of printing. The way we have been using it is slightly different than what you thought of, but we have been using it right since day one. The other class which we are going to be exploring now, and one of the most important data types that is there critical in every programming language, is string. So string is actually a class in the Java language. That means there's a class string which has attributes, which has constructors, and which has methods. What is comprised in this string class? So Java is right now being taken care by Oracle. Oracle is the caretaker of the Java language, and whatever Oracle does is fine. Now, Oracle has gone ahead and created documentation of each of the classes that it has defined. And that is what, and they are all publicly available. Whenever you install the Java in your machine, of course, all these classes, and they are dot class file. Remember the first session when we understood how the whole flow of the Java program is? The compiled file, the dot class file, gets installed, and that's something which is available for you to use. Now, what does string class compose of? How do we go ahead and work with strings? Let's try to go ahead and understand that first. Now I'm going to go ahead and share my browser again. But this time I'm going to do a Google Chrome search. I would like you to go to your Chrome browser, any browser that you have, and then just simply go ahead and say string class in Java. And the thing is, in the string class in Java, you can see that there are many links that will pop up over here. The first thing that we'll see is the String Java Platform SC7 Oracle Help Center. So you can go ahead and click on the Oracle Help Center. And over here, you have all the information about the string class. First and foremost, what you see over here is the name of the package, java.lang. I told you the lang package. It belongs to the lang package. This is the class string over here. What is all of this? We will see a little later. And over here, they have given an example as strings are constants. And this, they've given an example of how do we go ahead and create a string. As a Java developer, it's one of the very important things is you should be able to read the Java documentation. So this is the documentation which is there. Now, scrolling down below, let's scroll down. What of other information that is there? It is there since JDK 1.2. That means it's the first version of Java which was created. It's been there since the beginning. Field summary. Now, the thing is that is very important to notice. The documentation does not talk about, or it will not tell you about anything which is private. Why? Because you are right now, whenever you write your code, you're not going to be inside the string class. So there's no point of telling you what the private members are. That means it's only going to expose you to the stuff which is public in nature. That is why over here, see in the field summary is nothing but the data members or the fields. And that's why over here, there's only one field summary that you see over here. Is that only one data member in the string class? Maybe, may not be. The thing is, but whatever it is giving you this particular field summary, some case in sensitive order, something that is there. What it means right now, not very important for us, but let's go ahead and understand the constructors. All these are the constructors that are available for you to use. You can go ahead and you can create an object using any of these constructors of the string class. And then finally, you see the method summary. Very, very, very important. So over here, how do you read the method summary? This is the method and the description. So this is the name of the method. It tells you what type of parameter it takes. It gives a description about that particular method and tells you what is the return type of method. If you want to get more details about that method, then what you simply do is simply go ahead and click on it. And it should take you over there. It gets hours, you can click on it and you can see more details about this particular method. And you can see the declaration of this method. It's public. It returns a character. That's why the return type is char. The name of the method is char at, and it takes a position or an index at which the character is defined. So this is all about, let me go back. So this is all about the string class or reading any class documentation. You have the constructor, you have the method summary. There are many methods. There are many. Okay. So now let's go ahead and do some work with strings. One of the most important data types we haven't used in the class right now, but it's one of the most widely used things that are available for us. So remember that is a string is nothing but class. So what we're going to do is we're going to be creating objects of that class. So I'm going to go ahead and create a new repo over here called child strings. So we're going to just explore some of the methods of the string class, work with some of the methods and see how it really works. We'll see some of the concepts that are there. We'll work with the constructors and we will see that. So string is over here, what you can see, let's start from the beginning. You see a constructor summary. And you see the first constructor is a default constructor. It's the name is string, takes no parameters. And what it says is it initializes a newly created string object so that it represents the empty character sequence. Empty character sequence, that means it's string which has no contents in it. So if I want, I can go ahead and create a string object like this. String is equal to new string. Nothing. So if you actually go ahead and print it, nothing will get printed because it's empty. There's nothing in it. All right. Okay. Now, the other thing is that we say that's one way of creating. It's an empty string over here. There is another way which is there. This is this particular way of creating a string. And this is one of the most commonly and widely used ways of doing it. So I'm going to say string over here. I'm going to comment this one for now because something not used so much. So I'm going to say string is equal to say Bob. In quotation marks, I have created it. Remember, name is an object of the class string. That means name actually refers to the reference of where the contents of the string are actually stored. That means contents are stored somewhere else, and name is just a reference to that. Remember, an object is always a reference to that particular thing. Now, After we have created this particular thing, now let's go ahead and first print it. Just see what happens over here. So when I print name, you can see that Bob should get printed over here. Yes, and Bob gets printed. Now, let's look at one of the methods. If I want to find out how big the string is, let's go to the documentation and see if there's any method which allows us to do that. Is there any method? Yep, okay, yeah, length. So length is a method which returns an integer and takes no parameters. Remember, how do we call it? So it returns an integer. So I'm going to say int val is equal to name is the string, name is the object of the class, dot length. That's the method. And we pass no parameters. And then I simply go ahead and say system dot out dot println. So I'm going to go ahead and print that. And I'm going to see whether I'm getting the right input or not. The answer should be 3. So this is a method which the string class has already defined for us. And it is going and doing our work. And once it's done with the work, it's returning an integer. And that is the integer that we are printing. The length is 3. Now, over here, every character in a string has a certain position. And that is actually over here represented. So if I have talked about Bob, just like in arrays, the first value was at position 0, even over here, this is at position 0. This is position 1, and this is at position 2. So now we saw the caret method. Now, what does the caret method do? Let's go back over here. The caret method returns a character at a particular position. So over here, it returns a character. So I'm going to show char ch is equal to, again, name dot char at, and the position I need to pass. So C lowercase, A uppercase, I say position 1, and I can simply go ahead and print my ch over here. So if I print it, we should get the letter O here. It's compiling our file, and the letter O comes up. So this is using more method called char at. Now, I would like you to pay attention to another very important method. It's called as substring. And if you see, there are 2 versions of substring. One which takes 1 integer as a parameter, and the other which takes 2 integers as a parameter. The first one says that I'm returning a new string that is a subset of this string starting at this particular begin index. And this also does the same thing, but it starts at this index and ends 1 before the end index. So what has happened? Substring has been overloaded. That is what has happened with substring. So now let's go ahead and try to use the substring method. Now, how would we use that? Go ahead and see that. So again, string, it returns a string. Please note, it is returning a string. It is returning another string. So it's returning a string only. So the thing is, say string part is equal to, I'm going to say name dot substring, and I'm going to say position 1. From position 1 onwards, give me everything from there. So I can go ahead and say system dot out dot println, and then I say part, and that should be giving us O. Compiling, and it's giving us OB. That's the substring method with the 1 parameter. Similarly, you can go ahead and try using it with the 2 parameters. Now, there is one thing which is there about strings, which is an important operation which you've been using in system.out.println every time, and that's the plus. The plus is the concatenation operator, and that is something which you have been using right since the first program that we had done. So again, so I can create strings like this. So I can say string word is equal to hi plus. Okay, I can attach strings with anything using the plus sign. And if I print the word system.out.println word, then that is going to print hi. Okay, that is we're getting that output or not. Yes, we are getting that output. Hi, okay, gets printed. So, so this is about strings. And one last thing which I want to say is, as I said, the empty string, that one way of creating is like how you saw on line number 3 using the constructor. If you don't want to use the constructor, then you can see, you can do like this also, string var2 is equal to. That's another way of going ahead and using the empty string over here. This is just a brief, very brief overview about strings, very important data type, and you can go ahead and use it in many ways. But this was just an example of how can you use one of the built-in classes what Java has provided and how to read the documentation and apply the methods from there. Now let's go ahead and understand one very important word which has been there in every program that we have been writing is this word static. What does this word mean? Let's go ahead and understand that. Now, let us understand the concept of static data or static members, I would say. Let us take this example. Let us take this real life scenario once again. Now, most of us actually over here in India, if you're not in India and abroad, you all live in houses or areas where there are certain areas, there's a community that is normally there. In India, there's a concept like over here, many buildings are there, and all the buildings together form an apartment complex. So there is a building over here, building A, which has all the flats in each of the floors. Then there is building B, which again has its all flats on different floors. And all of us are staying in an apartment complex. Sometimes one or more apartments together, or one or more set of houses together, they form a community or an area or a region or a complex. And the thing is, over here, each of the buildings over here, residential buildings that are there, they all possess their own elevators. Each building has its own elevator. If you are living in a house and there's no concept of a building, there's a concept of just the entire house to yourself, then each house maybe can have its own garage or can have its own small kind of a lawn, a small area outside the house. But each house has its own copy of that particular garage. Each building has its own elevator. So consider the building like an object of a class, whereas the elevator is like the instance variable of the class. Now, the thing is, over here, elevator is like an instance variable. If one more building comes up in the apartment complex, a new tower comes up, that tower is also going to have its own elevator over here. However, all these stars are going to share one playground only. Very common scenario. There's only one playground, one mini stadium, one ground where all the children can play together. All of them share that particular playground. And the thing is, if you look at it, it doesn't really belong to object A or object B or object C. People from the building C cannot come and say that, okay, this playground belongs to us. This is exactly what the concept of a static member is. A static member is a member for which there is only one copy of that member created, and everybody shares that particular copy. Now, over here, how do we go ahead and create these static members? That is exactly what we are going to be keeping track of. Now let's go ahead and see that in our example that we had created. These were strings that we had created. Let's go back to our class, the student class that we had created. Let's go back to that. All right. And I have my student.java. I'm going to go play. Now, what I'm going to do is I'm going to go ahead and create a static data member. And for now, I'm going to keep it as public so that I can access it outside the class. Public static over here, I'm going to make an integer, say count of students. This is a static data member. That means only one copy of this particular data member is going to be created. And that is why this is also called as, since it has got nothing to do with the instance, this is also called as a class variable. Why? Because it really belongs to the class over here. So now let's come back to this particular example over here. And this is the thing I'm going to comment this out. And I'm going to get my other student object over here. And now I have two objects created over here. Even though I do not have any objects in right now, no objects are created. But when I run the program, since I'm compiling the program and since I'm working with two classes right now, although I'm not using the student class at all, what the compiler is going to do is the compiler is going to create the memory for the static members separately. That means a separate memory area will be created for our static member called count students. And the value that will be initialized to it will be given the value 0. When I go ahead and uncomment line number 6, what happens is over here, the memory is created for the instance. I'm creating a building right now. This variable is created at a separate location. This is student is created at 1500. And I'm using the constructor which takes one parameter, which you have seen in the student class earlier, how I have created the constructor. That is for the age. So you have the age, which is going to get the value 18 because that's what I'm assigning in the constructor. And I am going to have percentage marks. The memory is going to get created only for the instance variables at this particular location. The memory for the static members is different, is separate. When I uncomment line number 7 again, I'm going to create another object. But remember, even though I'm creating as many objects as I want, the memory created for the static member is only one. There's only one variable which is created for that particular static member. So that this string will be created at some other location. Say this location is 8,000. And at 8,000, you have over here age as 23, and you have percentage marks as 0.0. What is the age? 25. Again, counts to means only one copy is created. The question comes, if you also remember, that we had created this member as a public member for now, and it's a class variable. Now, the thing is, it is called as a class variable. Now, because it is called as a class variable, one of the ways of accessing the static data member is through the name of the class, because it really belongs to the class. Can the objects access them? Yes. People from buildings A and B, the example that I showed you earlier, people from building A and B can come ahead and they can go and play in the playground. They have full access of the playground. The real way, however, is that it belongs really to the class. The playground really belongs to that area, to the community, and the area is the caretaker of that particular playground. Same way over here, the count students really belong to the class. That's why static members outside the class are referred with the class name. So I will go ahead and write down student dot count. I think that was a static data member that we had created. Count students. Student dot count students. And if you run and check, as I said, the default value will be 0. It is going to be 0. If you want to give any particular default value apart from 0, can you do that? Yes, absolutely. You can do that. You can give that value over here if you want. So initially, when the memory is going to be created, so the count students value won't be 0. That will be over here, will be 25. If there is any information that you want to maintain about a class, which doesn't really belong to the object. Say, for example, if I want to keep track of how many students have I been creating so far, it doesn't really belong to any particular object as such. It belongs to the class. Such members are usually static members, static data members, also called as the class members. Now, if you were within the class, how will you access count students? You can access it directly. It belongs to the class, and within the class, there is no problem, and you can call the static data member absolutely. Now, over here, coming back to our original question that we had, void main, public static void main. Main was actually a method. Just like we have been creating our own methods over here, main is also a method. And the access specifier of main is static. There is the access specifier is public, but there is a modifier static over here. That means the main is also a static method. Now, why is the main static method? How do we create methods which are static? What is the concept of static when it comes to methods? That is what we are going to see. And then next, what we're going to look at is another built-in Java class, which focuses completely on the concept of static data members and static methods. Let's go ahead and see what are static methods. Now, let us go ahead and look at the concept of static method. Very important. A quick revision of static members. When a member is static, there is only one copy created of that particular variable. Whereas for instance variables, age and percentage marks are my instance variables. The number of copies created depends on how many instances or how many objects get created. Irrespective of the number of objects created, there's only one copy created for the static data members. Currently, I have kept over here count students and the value I've given it 25. Whatever initial value you want to give, you can go ahead and give it. And if I want to access it outside the class, since it was public, I was able to access it outside the class. And the way to access this is the class name. It's a class variable. So it's a class name dot the static data member name. Now, in order to manipulate static members, there was a need to create even static methods. How does a static method look like? So over here, I have public static void increase count. And what is this method doing? This method is simply saying count students plus plus. It's a void, return type is void, and that is how it is. If it was anything static, how do I access it outside the class? I can simply go ahead and access it with the name of the class. So the name of the class is students. It will be student dot increase count. That is the name I gave, I think. Let's check over here. Student dot increase count. Yes, that's the name. Student dot increase count. And then if I want, I can go ahead and print the value again of the static member after the system. Now for the system. So first it will be 25 because the default value is 25. Then I call the static method. Remember, static belongs to the class. That's why accessed with the class. And then count students plus plus. Now I'm going ahead and executing checking. It is 25 and then it became 26. Now, what's the difference between, say, the static method over here? I'm just going to get this, cut this and get it a little down. And over here. What's the difference between the change age function and the increase count function? Change age is a non-static method. You did not write the word static. And non-static methods have to be accessed with the help of the object only. That means in the main, I cannot go ahead and do student dot change age. It is belonging to an instance. It says an instance have to be called. It's saying cannot make a static reference to a non-static method change age. Over here, what we had discussed initially is on all these methods and the constructors, there was something which was present by default, and that was this. And we had said that in front of the data members, in this case, the non-static data members, this dot was automatically getting placed. And what does this refer to? This refers to the reference of the calling object. Since increase count is a static method, and since increase count belongs to the class is going to call it. Unlike in change where this was present, there is no this in a static method. It does not exist at all, nor can you create it. That means over here, inside a static method, if I try to write system.out.println age directly, it is going to give you an error. Again, the same error. Cannot make a static reference to a non-static field, age. Over here, it never gave us a problem because this dot was getting placed automatically in change age. And that is why I could use it. But in a static method, I cannot go ahead and use non-static members cannot be used directly inside a static. Then your question comes that, okay, if that is not, if I can't do this, can I create an object of this class only and then maybe access it? For example, over here, let's create an object of student. So I say student is equal to new student 14. Then can I go ahead and access over here? Then can I do over here ob.h? Yes, absolutely okay, absolutely fine. Why over here, in this case, the error is no longer there because I am mentioning which objects, non-static field I want to access. Remember, let me give a summary of all of this as an analogy. You have your buildings again. If you want to, if you are in this neighborhood, and if you ask, I want to access the playground, yes, you can access the playground. This is the static method. Inside this method, you want to access the playground, you can access the playground directly. No problem. That is why this was absolutely fine. But if you say, I want to access the elevator, I will need to say whose elevator you want to access. I just can't say I want to access an elevator. Why? Because there are multiple objects that are there and the elevator belongs to a particular building. But there's only one playground which can be accessed in a static method directly because it is a static method. Very, very, very important and very common place of mistake. Static methods cannot access non-static members directly. Line 32, not allowed. Line 34, allowed, because I'm making the object. Why? Because over here, this dot is not placed explicitly. If I want to go ahead and access a static method, I can go ahead and I will use that with the name of the class. Inside that, I will go ahead and call the method. If I want to access a non-static method, there has to be the object which is there. The object will be a student. I have to write student using the object only. I can call the non-static methods. Now, we have the concept of static data members and static methods. They belong to the class name. You will access them with the class name. Let us see a class built in by Java, which is one of the most important classes and used quite heavily. And that class is a class which consists of basic mathematical operations only. What I'm going to do is I'm going to search for math class in Java. This is Java SE8 and Java SE7. You can open any of the links. Please note, this is the official documentation of Oracle. That's why I've been opening these links. Whatever is mentioned over here is the truth. Why? Because this is the documentation written by the caretakers of the Java language, which is Oracle language. If you see in the field summary, there are two fields right now. In this math class already created by Java, there are two fields, pi and e. They both are static and they are double. That means if you want to use pi is the pi r squared, the area of the circle is pi r squared, 3.14159. That's the constant, right? The double value that is closer to any other to pi, the ratio of circumference to circle to that. If you want to use the value of pi in your program, then how are you going to use it? I'm going to simply find this out for now. I'm going to say if I want to calculate, so double value is equal to math dot pi. That is the value that is there over here. Now, this is the value. It's a static value. That is why you're calling it with the class name. Same way, you can go ahead and you can use this particular value any way you want to use it to calculate the volume of a sphere, for calculating cylinders, whatever shape, circular shape you want to calculate, the formulas that you must have done in school. Then you have the method summary. So this is the field summary. These are the data members of the math class. Then you have the method summary. If you see all the method summary, if you see all the methods over here are all static. That means in order to call the methods of the math class, I will need to call them saying math dot, the class name dot, whatever the method is. There is a method, if you see, I'm going to just showcase the usage of one of the methods. Over here is sqrt, which stands for square root. It takes a double value as a parameter and it returns a double. If you see, there are some other functions which is there, min. It has been overloaded. Again, different parameter types. The number of parameters are the same, but the parameter types are different. So there's an example of overloading in this case as well. Now, let's go ahead and just try one simple program of if you want to find the square root of a number. So over here, I'm going to say W and C is equal to, it's a static method, so math dot sqrt, and then we are going to write so 15. I want to find the square root of 15.2. I can go ahead and I can do that. And then if I want to print it, then quickly go ahead and print the system.println. And over here, I don't need the double, so I'm just going to execute and check whether it gives us the value or not. Yes, it's 3.85, whatever is the value for calculating the square root of this number. Now, I mean, if you remember the string functions, Now let me go back to the string functions. But let's put in minus and let's look at strings once again. Now, these were the string functions that were there when we had written all these string functions. We were actually calling each of the methods that we had seen using the name of the object or the instance. That means the methods that we saw of the string class, they were non-static methods. So length is a non-static method of the string. The concept of static, non-static, the difference between the two, very, very, very important. Now, let us understand some things which we have been doing right from the beginning. A quick reminder, I had mentioned that there's a concept of packages. Inside the concept of packages, there are many classes, and there was one package that we are using by default, and that is the lang package. Inside the lang package, there are multiple classes, is what I had mentioned. I had mentioned system and string. By the way, math class also belongs to the lang package. You can see that in the package java.lang. It belongs to the lang package. And as I said earlier, if you want to use anything of the lang package, you can go ahead and use it. Now, what we have been using right since the beginning, let's try to break down a couple of things of those things. System.out.println. System is a class. Let's go ahead and see the documentation of the system. So we have system class in Java. System, let's head over here. System class. Look at the field summary. In the field summary, you will see that it is out and it is static. That's why, since it's a static member of the system class, system.out. Now, look at the data type of out. Print stream. What is print stream? If you see it's getting highlighted. Print stream is another built-in class in Java. So what has happened is an example of composition. So this is how the design would be looking like. You have a class system whose data member, whose static data member, remember it's public, right? Whose static data member is actually the object of another class called printstream. And then you have a lot of some system stuff. There's another class called printstream. This is actually the object of that class. How we created student is equal to new student. Same way, out is actually an object of the printstream class. Now let's go ahead and look at the printstream class. And you will see something over there, which we have been writing right since the beginning. In the print stream, we are going to go on the method summary. And over here, you can see println. And you can see that println has been overloaded so many times. And it is void. I don't see the static word in here at all. That means println is a non-static method of the printstream class. That is why we need an object of that class. Which is that object? It is out. So, if I want to access println, first I will need to access out. How do I access out? The name of the class is system. This is a static member. So I'm going to say system dot out. This is a print stream object. For this object, I need to get the printer, and this is already an object. This is not the class, so I'm going to call it with the object. That's why you have system dot out print. That is how things have been working for us so far. That's how the whole concept, so even in the very basic concept of printing, all these concepts of object-oriented programming are involved. System, once again, system, static data member out. It's an object of the print screen class. So if I want to access any method of the print screen class, which is non-static, I will need an object. Yes, I have the object which is out. But how do I access out? This is a data member of system class and it's a static. That's why system.out to get the out and then get the method dot print. And then one thing that we have been using for so long, you've understood it's all related to object-oriented programming. Now, the other thing, let's look at public static void main. I said that in the initial stages that JVM is the one which is responsible for calling the function. JVM is the one which is going to be running the program. What the JVM simply does is the JVM knows the name of your class. And using the name of your class, it simply says, in this case, the name of the class is main. So I'm saying main dot main. It takes an array of strings as a parameter. What is it now? We're going to leave that aside for some time. But this is how the JVM has been calling the method. The JVM says that I'm not going to create an object of this class and call the main. I have the name of the class. I will please make the main static so that I can call it directly. I don't want to get into the whole concept of a constructor and all of that. That is the other thing that we have to do. So system.out.println, and we have understood public static void main. Now, the other thing that you must be wondering is that we haven't yet seen how to take the input from the user. Unfortunately, we have to know all these concepts before we actually go ahead and do that. As I said earlier, that there are packages. There are multiple classes that have been created for you to take them. One of the most simplest ways is what I'm going to demonstrate right now is the scanner class. The scanner class is unfortunately not present in the plan package. It is present in the util package. And so therefore, if you want to use something which is not in the land package, you will need to import it. So that should be the first line over here. You will select this java dot util dot scanner. The util package has many classes. Right now, I'm only interested in using the scanner class. That's why I'm going to write java.util.scanner. If there is another way that people normally they go ahead and do it, is like they write star. What does that mean? That you're telling the compiler, hey, listen, I'm importing this package and I can use any class from that particular thing. So don't give me an error if I try to use any class from this particular package. Right now, I'm using the scanner class. So I'm going to use just the scanner class from that package. Now, the first thing is we have to create the object of the scanner class. Now, how do we do that? I'm going to comment everything. And we're going to understand the creation of the object of the class. Again, let's try to understand the documentation. Class. Sure. If you can see, it's belonging to the util package. Let's see the constructor summary as to how we can go ahead and do it. Now, there are so many constructors which are there. If you remember, system.out was for printing, and that was print string. If it was an object of print string, let me quickly open the system first again. So yeah, so out was print string. Over here, there is a way to take an input, and this is particular, which takes a parameter as an input stream. Again, from system, if you see there is in, which is a parameter, which is a data member, sorry. And over here, this is a static data member again. So how are we going to create an object of the scanner class is using that constructor scanner. I'm going to say scanner SC, I'm going to call it SC is equal to new scanner. Now this are multiple constructors. We are taking the constructors which takes a input stream as a parameter, and which one is the one to how will you get the input stream? System class in is a static data member. So system.in. System.in. Now, over here, we have created the object of that class. Now, let's see in the method summary if there is any particular method which allows us to go ahead and take an input from the user. So now, as next, there is something called as next. You see next. Finds and returns the next complete token from the scheme. It's a technical word, but basically what it does is whatever you type in, it's stored in an area called as a buffer and it returns whatever you have typed. And this is used to take input as a string. There is something also for taking a Boolean input. You have a next Boolean, you have a next double, you have a next float, and then you have a next int. It's allows you to take the input as an integer. Let's go ahead and use that. And by the way, they are all returning integers and based on the data type that is, and they are all non-static because you don't see the word static. That means they have to be called with the object that we created, which is SC in this case. So if I want to take an input, so I'm going to give a small message so that we understand that we want to take integer. So enter a number. So I'm going to return an integer. So int val is equal to sc dot next int, allowing us to take an integer. Let's go ahead and run and see what happens. Compiling. Yes, enter a number. The program is waiting for you to enter numbers. So I'm going to go ahead and write 15. And the 15 is entered and the program has stopped. Now to verify whether it actually happened or not, let's go ahead and print it out. So system dot out println. So let's go ahead and do that. Verify that whatever input we gave actually got stored over here in val. 15. Yep, 15 got stored. This was taking an integer. I can go ahead and take the string as well. So we saw that the function was next. Enter a word. And then I'm using string. String is equal to sc dot. Let's then print the word. Print the name that we have taken. So first of all, enter an integer. Then we're going to enter a word. And that's how we integer 67. Enter a word. So you enter it, you press the enter key, and that's how it is. So this is one of the classes which is there. This is the only class to take an input from the user. There were other classes also, slightly more complex, but this is one of the easiest ways to take an input from the user. You first import the package, create an object of that class using the appropriate constructor that we saw. It was taking an input stream as a parameter. That's why we pass system.in. And over here, they were non-static methods to be called with the help of an object. This is the basic understanding of classes and objects. Very, very, very important. Before we proceed ahead, this has to be absolutely clear. The difference between static, non-static. How do we read Java documentation? How do we create objects and call the methods and understand the nuances between all of these concepts? What is this? When this is present, when this is not present. Next, we will be moving on to another important concept called inheritance. Now, we are going to understand the concept of inheritance. That's another object-oriented principle, which is very, very, very important. Now, the thing is over here is whenever it says that, when you're born, you inherit some of the features, facial features from your parents. Basically, there is some kind of reusability what can be said. In our day-to-day life also, there is a lot of need to reuse some things again and again. Say, for example, you want to create an application is the hospital which has been managing different kinds of patients so far. They have been having tuberculosis patients, malaria patients, cancer patients. And since the whole start of the pandemic, there was another set of patients which kind of came into picture, and those were COVID patients. Now, the system had already been developed for the patients, different types of patients that are there. A new type of patient was introduced, and they had their own set of attributes. But there were a lot of things which were common from a a regular patient that comes to any hospital. So instead of rewriting the whole information or attributes of a patient and the methods and everything for the patient, it is wise to have a way that, okay, you know what, probably maybe we can reuse that particular thing. That's where inheritance comes into picture, and that's where reusability comes into picture. Now let's try to see how we can do it. I'm going to share my screen. I have my main.java. That is going to be the place where I'll be executing. And as you have seen over here, there is a lot of the best view, lot of classes that is going to get involved over here. So our best way to do that is right from the right from the get-go. I'm going to create a new class and then do it. I'm going to create a new class and I'm going to call it patient. Choose this. And I'm going to create one more class called COVID patient. Now, this main.java is going to be, I'm going to first go ahead and create my class patient. So I'll quickly go ahead and create my class patient. Every patient has data members, normal data members, instance variables. One is name and the other is age. These are our instance variables, non-static data members. And then I'm going to have my constructor over here. And I'm going to call it patient. I'm going to call it string, each, and then I'm going to say name is equal to n. By the way, n and which is equal to n. And I'm also deciding to have a key file constructor as well. Patient, which gives name as an empty string, age as say 50. So somebody can be 0 years old, so let me say 50. That's a default constructor. And I'm going to have a simple method to go ahead and public set age. I'm going to have a set age, which will set age, and then I'm going to simply say age is equal to, remember you can use this dot also, age is equal to that. This is the method which is there. And I'm going to have a display method, which will display age. Public void display age. And I'm going to simply say system dot println age. All right, this is our class patient. Let me go back to these tabs. Now, the thing is, over here, I have my patient and I have my patient class. I'm going to create my class COVID patient. When I create my class COVID patient, I want to say that COVID patient has to inherit whatever the attributes in the patient class are. In order to mention that, I mention that with the keyword extends patient. Right now, I'm not writing anything over here. I'm not doing anything whatsoever. Even if I don't do anything, what has happened is all the members of the patient class are available in the COVID patient. All the members are available. Remember, in reality, you might be able to decide which member you want to inherit, what you want to inherit from your mom or from your dad. It doesn't happen like that over here. It's the entire thing. Whatever is a part of the patient class, everything becomes part of this COVID patient class also. Of course, there are some small nitty-gritties to that statement. We're going to see as we progress. Let's first go ahead and let's try to compile. Let's try to go ahead and just create an object of COVID patient and see whether that works. COVID patient B is equal to new COVID patient. COVID patient. Let's go ahead and run and see. And the thing is, as I said over here, the patient, everything of patient has belonged to COVID patient. So that means set age and display age are also belonging to COVID patient. So let's try to do set age. So we say OV dot set age. You can see that it is showing that. It is allowing me to do that, right? Because, and it says that it's coming from patient. So over here, OV dot set age, so 15 years old. And then we can obviously OV dot display age as well. Let's see whether it works or not. Remember, I did not write a single line of code inside the COVID patient class. And over here, I wrote everything in the patient class, the COVID patient class, COVID patient.java just went ahead and extended everything from the patient class. Now, that means all the methods of the patient class belong to COVID patient and the data members as well. That is why over here, the patient class is called as, over here, is the parent. The class from which you're inheriting is the parent class. The parent class, or also called as the super class, or also called as the base class. All these are the words for the parent class. So diagrammatically, if I have to represent inheritance in this scenario, I have patient. Over here, this is the patient class. And all the information of the patient has been inherited by the other class called COVID patient. And this is an example of this type of inheritance where it's simply one class inheriting another class. It is called as a simple inheritance. Now, what is the COVID patient class called? The COVID patient is inheriting, so it is called as the child class or a derived class or the subclass. These are all the words for the child class. Now, the derived class ideally would like to add some of its own attributes. For example, over here, one of the things that you must have heard a lot is the O2 level, the oxygen level, which is there. So this is a data member which I'm going to private O2. And there is a method to set public void set O2 level, which is int w, and then I can say that O2 level equal to. So now this is a method which is specific to the derived class. That means over here, if I go ahead and if I create an object of patient class, patient OB2 is equal to new patient. And if I try to do OB2 dot set O2 level and pass 85 over here, it's giving me an error. So the name of the method, let's verify the name of the method. Let's set O2 level and capital set O2 level is exactly the same thing. And if you see, cannot is undefined for type patient. So the derived class object can access anything of the base class, but not the other way around. Base class cannot access the of the derived class. Very, very, very important. So this is starting. So let's comment this out. Coming back to the COVID patient.java class, this is the subclass. Now we said that over here, everything of the base class belongs to the derived class. So over here, let's have a display. Public void, just display, we'll call it. And let's try to over here access. Over here, name was a data number, right? We had to send name, and we just said that over here, whatever is of the base class goes to the derived class also. So name should be accessible over here in the COVID patient class. You see, it is giving you an error. Look at the error it is saying. It's saying the field patient.name is not visible. Why? Because patient has name declared as private. Private, as I said, is an access specifier which allows you to do it only within that particular class. You cannot do it outside the class. But if you see the error message is also very different. It's saying it's not visible. So does it mean it's not inherited? That's just a very debatable thing. So many people say that over here, no, private members are not inherited. I would disagree with that. What I would say instead is they are inherited, but you can't access them. So it's like this. When you are born, and if your mom or dad have a treasure, only they have the key to it. When you are born, you also inherit that treasure, but you don't have access to it. You can't, if you don't know the key, you can't really open. But yes, people will say that, okay, that treasure belongs to you as well. Just analogy, simple analogy I'm trying to say. So remember, if the thing is private, I cannot access it outside the class. So then you'll be thinking like, okay, if that's going to be the case, then what's the advantage of making the whole thing as inheritance? I'm not able to still access it. That is where the third access specifier comes into picture. That access specifier is called protected. Protected is the access specifier where you can access the members within the parent class and also within the subclass. See, here is common. It is absolutely accessible. That is what protected allows you to do, specifically created for inheritance. You have now three access specifiers: private, public, protected. Protected in base class and in subclasses. You can also access protected in other situations as well. It's a little advanced, so we're not going to get into that. But right now, for the main purposes of it, this is the main purpose of protected, to allow the parent class members to be accessible in the subclass. So this is about the basics of inheritance. Now, let us go ahead and look at another concept of another feature of inheritance. Now, in my patient.java, I'm calling a function called display. And what this is going to do, I'm going to simply go ahead and print out the name plus the space, and I'm just going to reach. In the COVID patient.java, I already have a display. And now, and the thing is, you see that it is not giving an error. And this display over here, just let's understand, is I am just going ahead and printing, saying, hello, is for right. And here also in patient.java, I'm not printing for now. I'm just going to comment this out. I'm going to say print. Okay. You're seeing that it's not giving an error. The base class and the derived class both have methods which are exactly the same looking, but their bodies are different. In the patient class, you had public void display. In the COVID patient class, you again decided to have the same looking method with not only the same name, but also the same parameters and the same return type and also the same access specifier. Is it possible to have that in the COVID patient class? Absolutely, yes. But the thing is, we had seen the concept of overloading, but the parameters were different, but the parameters were also the same. This concept of the base class and the derived class having the exact same signature is called as function overriding or method overriding. This is, let me explain it to you with a simple example. Now, assume when you were born, you had your father. Your father, you have your father. Your father says that, okay, you know what? The definition of success is hard work. He says it is hard work. When you are born, you are inheriting from him the same definition of success. But then after, as you grow older in life, you are saying that no, 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 no. This is your dad. This is you. Now, when you were born, you are saying when you are overriding the meaning of what success means. You are saying that, you know what, success does not mean hard work. Success means smart work. And when people come and talk to you, what are you going to say? What does success mean? You're not going to say what a dad thinks. You're going to say what you think because you overrode whatever he thought. Therefore, in your COVID patient class, if you go and create an object of that overridden method, and if you do ob.display, you are going to call, right now I'm just commenting this out, you are going to call the display defined by the derived class, by the class which overrides it. So your output should be hello and not okay. And it is hello. Now the question comes, that means people outside are creating their object and asking you that's what main.java is doing. Now, is there a way to also think what your dad wants you to think? What your dad said about success? The only thing is that controls only with you. That means that control is only with the COVID patient.java class only. If you want to say that, you know what, okay, you know what, my definition of success is not just smart. It's not only smart. It's also a combination of what my dad says. It is a combination of what my dad says and what I say. In this case, what you intend to do is you intend to invoke whatever your dad was saying or whatever your parent was saying. If you want to call the overridden method of the parent class, you need to use a word called super. Super.display. Super.display does it calls the version, this is a comment, it calls the overridden version of the parent class. So you're doing that because whenever I do over here on line number 6, display, you're always going to come on line number 13. So if you want to incorporate whatever your parent is also doing, and you want to say, you want to call the display of the parent, then you need to say super.display. What would happen if you call display only? The thing is, if you call display, line number 13 will again call line number 12. That means the function will keep calling itself again and again and again and again and again. This is an example of a recursive function, a function which keeps calling itself again and again and again and again, and it never stops. So that is why the word super is important. And if you see, if I write super.display, tells over here is a special display. Now when I execute the program, I will be getting both OK and then hello. Since I called OK first, since I called the super display first, and that is what it is. So Function overriding, one of the most important aspects of object-oriented programming. When the base class and the derived class have the same name, same parameters, and the same return type, then and a same or less restrictive access specifier, then you are set to be overriding that particular method. Very, 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 very important. If you intend to call the method of the base class, only the derived class can do that. And the way the derived class can do it by using the keyword super dot. It's super keyword being used. Here, we're going to see this concept of overriding again and again for the next few minutes of our session. So, this is overriding. Now, let us go ahead and tackle another aspect of inheritance is the creation of the data members. Now, the thing is over here, when I'm creating, let me just erase everything like that. I'm sure I erase everything and do this. Now, the thing is, when I create an object, this is the patient class which is there, and this is the COVID patient class which is there. Now, the thing is, when I create an object of the COVID patient class, whose members get created first? Now, patient has name and age, COVID patient has O2 level. Whose members get created first? The answer is the base class members. The base class members get created and then the derived class members get created. Remember the beauty of allocating memory and giving values to the members. When you create object, it belongs to the constructors. We have created the constructors in patient class, but we didn't create in the coded patient class. That means, remember that if we don't create any constructor, Java puts its own constructor. And that is why in main.java, we were able to write line number 3. Now, let us go ahead and create our own constructors. How can we go ahead and do that? Let's go ahead and do that. So this is how the default constructor was looking. This is what happens in the derived class. This is the default constructor in the derived class. And as I said, that first the base class members are going to be created. And even if the data members are private or public or whatever, the duty of allocating memory for that data member, for that particular class, only is the responsibility of that and that class alone. So that means over here, there has to be something happening over here, which makes sure that we give a call to the constructor of the base class. And that call is again the word super with no parameters. This is the one which was existing by default. It was first going ahead and coming over here and in giving the name as this and age is 15 and then coming back and giving O2 level as this. This was the constructor which was existing by default. How do we prove that this is what exactly was happening? Let's comment this out. Let's keep as it is. So if we don't do it, Java will do the same thing. And let's see, this was name and age, and we'll call display age. And we'll see if the display age function is working or not. So display age, I haven't said the age explicitly. So display age is 215. That means I can understand that, okay, my default constructor on the base class was getting called. So that is what happens over here. The first line within the constructor of the derived class is the call to the constructor of the base class. Note the first line within the constructor of the derived class is please constructor, and it has to be the first line only. It cannot be the second line. It will give you an error if you try to do that. Let's see. If you try to uncomment this, or uncomment this, and keep this from here, and put it here. See, it's giving an error. Must be the first two. So that's how it's. So now, can you go ahead and create your own constructor? Yes, you can. But the thing is, by default, the call is going to be to the default constructor. So you can go ahead and create your own constructor as well with the parameters. So now this I have the N, the E, and the O2. Now, the thing is, in this case, the name and the age will be taken care by patient.java, by this particular constructor. So how do I call that constructor? Very simple over here. You say super, and you pass the parameters. See, the second example, it's giving you the options. So you have super n, comma a. So the n, comma a that gets passed over here on line 15, the same n, comma a can be taken care by the patient's constructor. And then, of course, you say O2 level is equal to O. And very simply, you can go ahead and create the object over here. So the name is XYZ, which is 55. So that is the, so just going to go ahead and automatically tell that. And when you do the display age, run this and run this. You see the display age, it should be 55 because that is what. So we have seen the super keyword in two scenarios. One, very important, overriding. Base class, derived class, methods having the same name, same return type, same parameters. Of course, the bodies are different. Whenever you call the object using, whenever you use the object in the derived class and call the method, it will be the derived class method which is going to be called. And then if you want interested, you write super dot the overridden method. In the constructors of the derived class, the first line has to be the call to the base class constructors, and you can again do that, the super keyword. Let us go ahead and understand one another very important aspect about inheritance, and then we'll see that how Java in their own classes have been using inheritance right from the simplest class that we have seen. We've seen string, we've seen math, all the classes that we have seen. They already have the concept of inheritance in them. How is it? We're going to see that very soon. Now, before we get into inheritance a little bit more in detail, let's understand the different types of inheritance that are there. So over here, it's very simple actually. First, the simple inheritance that we've discussed is class A, and there's another class which is inheriting that class, which is a simple inheritance. The next one that you have is a multi-level inheritance. In multi-level inheritance, what you can have is over here, A is being inherited by B, and B is inherited by C. That means all the members of class A are going to be there in class B, and class C is going to get all the members of A and B, both. And whenever you have the constructors or you have overridden methods, whenever you do super dot and overridden methods of display, then this display will call the display of the immediate parameters. And if this display also has been overridden and is also called super, then this will call this particular thing. So whenever we talk about super for C, it's B. When you talk about super for B, it is A. This is multi-level inheritance. There can also be a hierarchical inheritance. Hierarchical is basically your regular inheritance only, but it's like a combination of multiple classes getting involved. And over here, this is classes inheriting into this and this. Class B and C are inheriting from A, C further is going down to D and E. Basically, you can call it a combination of simple and hierarchy. So multiple classes can inherit from the same class. In Java, there is a certain rule that we have to be aware of. Every class has to inherit exactly one class. There is exactly one class that every class has to inherit. It is compulsory. And not only that, each class cannot inherit more than one class. That means I cannot have class C inheriting from A and B. If A and B are classes, this is not possible. This is not allowed. But Java still did come with a workaround to have this scenario possible. But it wasn't possible with the concept of classes. Something else which we will see consider. But coming back to this statement over here, every class has to inherit exactly one class. But I have a question over here. Let's go back to the patient class that we created. Let's go back here. Now, the COVID patient class is inheriting the patient class. But the patient class is not inheriting any class. We haven't written and we just said that we have to exactly inherit one class. Not only that, main is also a class that is also not inheriting any class. Then what is happening? There is one class in Java and only one class in Java, which is the parent of all the classes in the Java language. Not only that, if you write your own class, automatically you inherit that class. And that class is called as the object class. So we're going to see the object class in Java, the documentation of the object class. Let's open this. So class object. Class object is the root of the class hierarchy. Every class has object as a root. So that means patient has been inheriting the object class. Main has also been inheriting the object class. That means all these methods are actually all present in the object class and also the patient classes and the main classes. And then basically every class that we have been writing, all these methods are already available. There is one particular method which is of a little bit of importance and used quite widely, and that method is the toString method. If you see, it is returning a string. And it says, if you read the description, what it says, it returns a string representation of the object. Now, coming back to that, what does that method do? Let's understand. Now, this is COVID patient OB is equal to new COVID patient. Now, the thing is, if you remember, I had told you that the name of the OB is actually a reference. So, OB itself is not the object. OB is the reference. So, if I try to print OB, what will happen? Actually, the thing is, whenever I write like this, system.out.println OB, if I just write like this, what Java does is automatically it interprets this line as OB dot toString. Now the toString method, now the question is COVID patient, does it have the toString method? Yes, it does. How does it have it? Because it COVID patient extended patient, patient extended object, object had the toString method. So patient also had it, and patient then passed into COVID patient.java as well. That means the toString method is going to get called. And when I do that, I'm going to basically do whatever the object class has defined this class as. So whatever the object class has mentioned about toString method, I'm going to do that. So now let's go ahead and see what the object class has to say about toString. Let's see what it. So what it is going to do is if it returns a string representation of the object and it is equal to the value of this particular thing. It is some hash code. It is going to give the class name followed by @ and some hash code. This hash code, by the way, is kind of related to the actual memory, the reference that it's pointing. So just let's go ahead and check what really happens. So when I print this page, so you see the name of the class is COVID patient @ and some hash code which is based on the reference. Now, think about it. There is a base class which says something about a certain method, and we would ideally would want to change the meaning of that particular thing. That means, what are we going to do? We are going to override the method. So let's go ahead and override the method in the COVID patient class. Since I'm interested in the COVID patient object, I want to override in the COVID patient class. Can I override in the patient class as well? Yes, you can do that there as well. Ideally, normally you would see that the toString method is kind of overridden in almost all of the classes. And if you look at the object class, it says public string toString. That's how it's a public method. So we will go ahead and now do that. And say I'm going to say public string, and I'm going to return. It's running a string, so I'm going to just simply return the name as we had made it as a protected data member. Yes, name, and I'm going to return the O2 name plus O2 level. That's what we are going to do. So now, when we print OB, again, it is going to be interpreted as OB.toString, but this time, since you have COVID patient has overridden it, it is going to go ahead and call your overridden method and not the toString of the object class. Let's go ahead and verify that and see whether it happens or not. Yes, XYZ and 90. That means it is calling your toString method. That is the advantage of inheritance. Just very quickly, string class in Java. The string class has also been inheriting things from the object class. This is the hierarchy which is shown over here. Java.lang.object, Java.lang.string. String is a derived class of the object class. Another method which string has overridden is the equals method. We haven't discussed about it, but what it does, it's used for comparing two strings. And you can see the equals method over here. There is an equals method. It's the equals method. It indicates whether some object is equal to this one. So string class also decided to override it. See, the parameter is same, the object. And not only that, when you click on it, you see this word saying overrides equals in class object. So overriding as a concept, as I told you earlier, used very heavily and of a lot of importance. One last aspect about inheritance and parent and subclasses, we are going to discuss that next. And then we understand the concept of interfaces and abstract classes. Now, let us go ahead and look at one of the most useful aspects of inheritance. So now we have patient.java, which was the base class, and we have COVID patient.java, which was the derived class. Now in main.java, I have COVID patient OB is equal to new COVID patient, and I'm using the constructor of the COVID patient class, which we have created. That's quite straightforward. Now, whenever you create OB, if you remember, OB is a reference. And OB says that I should be pointing to a memory location, which at least consists of the data members of that particular class. Or I would say, let me not say data members, I would say the members of that particular class, at least. Therefore, over here, I can go ahead and I can write something like this. Patient OB comment is equal to patient OB is equal to new COVID patient. XYZ 55 and now how am I able to write this? OB is of type patient, which is the base class. And I'm creating the object of the derived class. How is this okay? I just said that OB is a reference which should be pointing to a memory location of at least the members of the base class. Now, if you look at the memory diagram, then what is going to happen is OB is a reference. OB, I'm doing a reference. This can be, say, location is 1800. It can be any location. We do not know what it is. Assume it is 1800. As I said first, whenever I am trying to create is the memory for a derived class. That means I'm going to first allocate memory for the base class members. So that is why over here in red box, I am going to create, this is the base class member one, base class member memory, base class member memory, whatever the members are. Remember, even the functions get some allocation of memory, but right now, let's assume simple red boxes what talk about the base class members over here. Now, after that, the derived class members are getting formed. In that, I am forming that in green boxes. So this is the derived class member. This is a derived class member. And say assume one of the derived class function has overridden the base class. So this was, say, the function which is getting overridden. The same location is now being written by the derived class. Remember, this is just a representation, just for the explanation purposes. This is the actual thing is not exactly like this, but you get a general idea. So this is derived class members. Over here, OB is a reference of the base class. And 1800, the question is, does 1800 consists of the members of the base class? Yes, it does. And that is why this line is absolutely okay. But if you would have tried to do the other way around, if you would have written COVID patient X is equal to new something, then that would not have been fine. If you would have written Y, if this would have been not been okay, COVID patient that is equal to new patient. If I write like that, over here, this would not have been fine. Why would this not have been fine? Because that would have said that I need to point to a memory location which at least contains the members of COVID patient, which is nothing but the members of patient plus the members of COVID patient. But right now I'm saying that you point only to patient, which is not correct. And see over here, it is over here. If you try to do this, it's giving an error now. Cannot convert from patient to COVID patient. I'm not able to convert that. I can't do that. So this is therefore not allowed. Therefore, one of the very important things, base class members can point to a derived class instance. What's the advantage of doing that? Coming back to this diagram, once OB is pointing to this box, which is containing the derived class object, it can only and only access the red stuff over here. That means even though it is pointing to an object which contains the derived class members, it cannot access the green boxes. It cannot access this and this, but it can access the red boxes over here. Now, let us try to look at those methods in COVID patient which are specific to COVID patient, but they are not there in patient. Let us set O2 level. Let's try to go ahead and set O2 level for that particular thing. So over here, I'm going to say O2 dot set O2 level. And see, over here, it will say that OP level is undefined. Although OB is going to be pointing to this particular thing, it is still not going to work. Let's try to run and verify and check whether it is still going to work. Nope, cannot find symbol because OB is still the reference of a base class. It will only look at the base class stuff while actually compiling the code now. Now, the thing is, what about let me highlight it. What about this particular method which has been overridden? The thing is, because this has been overridden, I can still access it, nor can I still access it. It will show the implementation of the derived class. That means if I do now over here, let's look at if any method is there. There was a display method over here, and COVID patient had overridden display. So that means even if because this is OB dot display, if I do that and if I run this program, you will see that it will actually call the overridden method of the derived class. And that's what it did. So something beautiful has happened over here. Over here, the base class number has the base class reference when pointing to a derived class object. We were able to access the derived classes overridden methods. And this is very, 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 very powerful. How is it very powerful and how can it be used? Let's take this scenario. I'm going to give you a diagram over here. So now assume this is patient. Now patient has been derived by multiple classes. One is a COVID patient, the other is a TB patient, and then there is another one called as the cancer patient. Now, and everybody has overridden display. So now the thing is, assume there is public void display here, which is saying SOPLM. Okay. The COVID patient display also has been overridden. He is also overridden display. And COVID patient display is printing B. TB patient's display, again, which is overridden, is printing C. And cancer patient's display, which is again overridden, is printing D. Now, over here, if I would have done, first of all, can I go ahead and do this? I have patient OB is equal to new COVID patient. I can go ahead and do new TB patient as well. The base class can point to an object of the derived class. Now, when I do OB dot display, what is this going to do? This is since display has been overridden, it is going to call TB patient display into display C. I can do again OB is equal to new cancer patient. And I can go ahead and do again OB.display. Now, over here, this display is now going to call the overridden method by the cancer patient because cancer patient has overridden display and that is going to print D. What you are observing is over here, the same line of code is actually giving you different outputs based on which instance is the base class reference pointing to. This is a very important aspect of polymorphism, one of the most important features of object-oriented programming. This is runtime polymorphism, or also called as late binding. Why runtime polymorphism? It is because when you are running the code, when you run the code, it really comes to know that OB is going to be pointing to which object. And based on which object it is pointing to, that particular class's overridden method is going to be called. Very important. By the way, we already saw polymorphism in some other way also, which was the compile time polymorphism in the form of overloading. Over here, when you why compile time? Because at that instant, when we were writing our methods or our constructors, the compiler needs to be very clear between the difference of the various forms, polymorph, various forms of the methods or various forms of the constructor. So again, polymorphism is one of the most important aspects of over here object-oriented programming and used very, very heavily. Now let's go ahead and see what is the concept of abstract classes and interfaces. Now, let us go ahead and understand another concept of inheritance. Is the concept of some special classes called as an abstract. Now, what is an abstract class? Let's get a quick understanding of that. I'm going to create a new program called shape.java. And I'm going to open that on a new tab. And now I'm going to go ahead and create a class called shape. Now I'm creating a class shape over here. And right now there might be some data members, but every shape has something called as an area. And what I'm going to do is I'm going to go ahead and have this shape. Every shape has at least one type of site. So I'm going to have a data member, which is private site. Now, over here, and I can have my constructor also for the shape. And the default constructor, which gives a side a default value of 50. We do not know what the exact shape is, but just some shape. Now, the thing is that I'm also having a simple display, which is going to display the shape. And the display system out print and process. Every shape has an area. But the thing is, area, I can't really give any meaning to area until and unless I really know the shape. So over here, what Java said is if you're going to have a method whose body you really cannot define, it is good enough to go ahead and create it as an abstract method. So I'm going to create an abstract public void area. And then simple. Now, the thing is, over here, if I'm making a method abstract, an abstract method is a method without a body, then the question comes, who is going to be giving the body? The responsibility of giving the body to the method relies on the subclasses only. Because my class has one abstract method, I will have to create this class as an abstract class. I will have to declare it as an abstract class. And unfortunately, the moment I declare it as an abstract class, I cannot create objects of it. I cannot create objects of this class anymore. That means this class has no use if you're not inheriting it. If you're not inheriting, then you can't create objects, you can't work with any of the things that this class has to have. But if you inherit it, then it will work. So now let's go ahead and create another class called square. I'm going to create square.java and let's go ahead. Shape square. I'm going to class square and let it extend shape. Extend shape. You will observe something. The moment I write like this, please look at what is it. The type square must implement the inherited abstract method. It becomes compulsory for this class to go ahead and implement all the abstract methods of the base class because the base class over here is an abstract class. You're saying that, no, I don't want to do it. If you don't want to do it, you will have to declare this class also as an abstract class. So I will go ahead and implement the area over here. So I'm going to say public void area, override the method, right? The moment I do this, you see the error is gone, right? And now, once again, over here, the thing is, I don't really want to have a square already has a side, and the side is already taken care by shape. So I'm going to make protected so that I can, for now, I can go ahead and access it over there. So I'll make it protected. And then I'm going to simply do system.out.println side, because a square is going to be inheriting whatever the shape. The shape already has one side, so I will just go ahead and use it and made it protected just for now. But please note, however, many of the times over here, you will see people still keeping the base class members as private and using the getters and setters to access them even in the derived classes. So over here, but right now for simplicity's sake, I have made it protected and I can go ahead and do it. So over here, now the question comes, if this guy over here cannot, if you cannot create an object of this class over here, what is the point of having the constructor? Remember, however, as I told you, the square class has to make a call to the constructor. So therefore, even if there is a abstract class which has a constructor, you can't use it directly by creating the object, but the derived class's constructor will make a call to your constructor. So let us go ahead and check that. So now let's go ahead and see whether it is possible. And please note, I can create references. So I'm going to say shape as is equal to new square. Yep, I can do that. I can do new square. Absolutely. It's absolutely allowed. And since it is overwritten, definitely I can do a start area. And now over here, remember there's also square also has another method, which is a normal method, which is inheriting from display. So I am actually, we just have to print the area. So I'm just going to print that thing. Shape is giving the side as 15. So square should be giving it as 225. Let's execute and check whether we're getting that answer or not. 225. Base class reference can be pointing to the derived class object. Area had to be overridden by square because shape had declared it as an abstract method. And using the base class reference, I can call the overridden methods of the derived class. It is going to run that. And by the way, if you try to do shape over here, you can see that we give, by the way, take out instantiate the type shape. It's going to be giving that there. Now, this was the concept of abstract classes, and one of the things which I had told earlier was that over here there is a thing that one class can only inherit one other class. One class cannot inherit more than one classes. And people liked the concept of the abstract method over here. They took it a little further, okay? And they introduced the concept of an interface. What was an interface? So over here, an interface is like a class, but in that all the methods are abstract methods. You will see a lot of interfaces created by the Java language, and if you want to kind of set a set of rules for everyone to follow, and in a way that you really yourself cannot implement those rules, you want others to implement those rules compulsorily, then it is better to go ahead and create an interface in that particular case. So instead of creating the shape as an abstract class, okay, we could also actually go ahead and create it as an interface. And not only that, we could have gone ahead and then each shape, like square, triangle, rectangle, and all of those things, they could have gone ahead and have their own data members, have their own ways of calculating stuff, have their own methods. So how would you go ahead and create an interface called shape? So I will have some interface, and I will say shape. Interface shape, and then over here, I'm just simply going to say area. If you know I did not write public over here. Why? Because in an interface, everything is public by default. What about data members? Can interface have data members? The thing is, yes, but it can only have static data members, which are final. What are final? Final means you will have to assign a value, and once you've assigned the value, you cannot change it. So very rarely you will see interfaces have such members. But the thing is over here, right now I'm just focusing on the method of it. Over here, there is a method area. And then over here, for square, it is now, I would like square to now inherit this particular thing. So now the thing is, there is no longer extends anymore. A class implements an interface. The word is implement, and it is not extends. The side was no longer there, so I will have to create all that in this particular class, and it kind of makes sense. So I'm just going to quickly copy it from here and put it in the square class, and I'm going to implement all of this. And this is not shape anymore. This is square. And I have already overridden the area method. So this is there. If there's also something called as a perimeter, so I can have some void perimeter. So that means for square, it has now become compulsory to, again, it is giving that error over here, must implement the perimeter method as well over here. Whatever the interfaces methods are, over here, you will need to implement it over here. Again, you cannot create an object of an interface. You cannot, there is no concept of a constructor at all in an interface. And you can create references. This remains exactly the same. Using the reference of the interface, you can point to derived class objects, and you can go ahead and call the overridden methods. It will work exactly the same way. Shape s is equal to new square. Now it's called the constructor of square. The size will become 15. You can make this to private, and everything will work exactly as it is. Let's go ahead and quickly execute and check this, whether we're getting yes, that's absolutely fine. We're getting the same thing. Now, the beauty of interfaces is a class can inherit more than one interface. So, if you have a scenario like this, if this is a scenario in this particular case, this can be made possible if both of them, if both A and B are interfaces and C is a class. Yes, a class can go ahead and inherit two interfaces. Or the other thing could be a class could extend a class and implement an interface. That is also absolutely possible. So over here, a class can inherit from a class and an interface both. In that case, the way you would write it, if A is a class and if B is an interface, then the way you would write this would be class C extends A. The extends has to be first and then the implements. You need to say implements. If both of them would have been, if this would have been an interface, and so is this an interface, then the declaration would have been class C implements A, comma. That is how you will do. And by the way, this is multiple inheritance, multiple one who inheriting from multiple sources. This would have been possible using the concept of interfaces. And you have something called as a hybrid inheritance. And this hybrid inheritance again would be possible if you have the concept of interfaces. These guys can go ahead and inherit from here. But the thing is, over here, one of them will have to be an interface. An interface cannot, unfortunately, inherit from a class because a class is defined. It has methods which have a body in it. But This is not possible. So that means this has to be an interface. This can be a class or an interface. This is a class. This can be a class or an interface. So this is your hybrid inheritance, which can be possible with the concept of interfaces. Please note that over here, I told you that over here, the shape is an interface which consists of only abstract methods. Oh, by the way, yeah, the methods by default are not only public, they're abstract as well. So that is one of the most important things. They are public and they are abstract. And they are public and abstract. By default, every method in an interface is an abstract method. In the latest versions of the Java language, however, they have tried to create some variations to that as well. But it has been for a very long time, this definition of interface has been used. So, and this is something which will be used a lot more going ahead as well, that an interface is a collection of either final static data members whose values have to be initialized at the line of declaration and or collection of abstract public methods. That is what an interface is. And this is how the concept of inheritance heavily decides how the various aspects of the Java language are working. All right, the next concept that we are going to be tackling is the concept of exceptions. Now, if you remember a little while back, over here, we had seen an exception when we were working with arrays. An exception is unexpected error that comes while running your code. Now, the other thing is when you're running the code, the other thing that usually also happens is the program terminates right then and there. Now, in the actual application that you are using, right, if such a situation does occur while using the application, the program terminates or there is some unwanted or you haven't thought of that particular scenario happens, you should still be able to handle it gracefully and your program shouldn't crash. That is why there was a need to understand the concept of exception handling. Let's go ahead and first generate some exceptions and see what really happens. I'm going to share my screen. And let's go ahead and let's create a new repo. It's Java. I'm going to see exception handling. Okay. Let's create it. Now, the thing is, one of the most common exceptions that can happen is, say, for example, you're taking two numbers and you take the value of two numbers from the user. And if you divide, and when you try to divide by, if it turns out to be 0, then it is not possible. So you are going to get some exception. So let's go ahead and first, let's take from util, import java.util.scan. Let's take input from the user. And I'm going to say over here, and instead of hello world, I'm going to say enter the first number into an. First of all, before that, we have to create the scanner object. So scanner C is equal to use scanner and system.in and val1 is equal to sc.extint, and then I'm simply going to ask to do the second number as well. Quickly copy this into second number and this over here, 2. And I'm going to simply go ahead and print the thing over here of the division system dot out dot print and val1 divided by 1. Now, over here, let's execute and check. And the thing is, I'm going to write some more statements to tell you what happens if an exception occurs in between. We've already discussed this for the quick revision. Now, if I'm taking my integers, I'm running my code over here. It's compiling. Yeah, enter first number 5, enter second number 2. 5 divided by 2 is 2. Remember that integers, integer by integer equals an integer, and hello gets printed, no problem whatsoever. Now, let's go ahead and run what happens when we enter something which is not, you try to divide by 5, and 0, exception incredible. Java.lang.arithmetic exception divide by 0. So, whenever such a situation occurs in the program, what is actually the JVM doing is the JVM is actually creating an object of a class. And which is that class over here? That class is arithmetic exception. So actually arithmetic exception is a class. And just like we saw the hierarchy of the object class and how everybody inherits the object class, there is a hierarchy of all the exception classes as well. You have at the top the object class, which is the root. It has to be the root, which is followed by another thing called throw. Then there's another class which inherits. Remember, this is inheriting object. There's another class called exception, which inherits throw. There are many classes which inherit exception directly. There is a certain particular class called as the runtime exception, which inherits exception. And there is many exceptions that are there, the other one which we have seen over here. One of them is arithmetic exception. And the other that we have seen is array index out of bounds exception. That's also another exception. So what the JVM is doing is JVM is creating the object of this particular class, arithmetic exception. This is the hierarchy of all the classes that is there. Now the thing is over here, exception handling says that you should be aware that such a situation occurs. And the thing is, if you have written a lot of lines of code, the line number 10, they will not be executed because you haven't handled this particular scenario. Then what we should do is whenever such a situation is about to happen, or you can think that can happen, those lines of code should be put inside a try catch block. Now, how do I do that? Is something like this. I don't expect any problems happening over here on line number 6 and on line number 8. I expect a problem happening on line number 9. So I'm going to put this in a try catch block. So try, put my statement over here. Then I'm going to have a catch. The catch block takes a parameter. And over here, it takes a parameter, which is anything of the type throwable. Any object of the type throwable. That means over here, I'm go ahead and pass arithmetic exception. It's taking the arithmetic exception E for a call. Now, and then I'm going to simply go ahead and I'm going to write for now just a simple message. So I'm just going to call it a message. But the thing is, what you will have over here is if it is coming in the catch block, that means an exception has happened, an unwanted scenario has taken place, and you are supposed to go ahead and handle that scenario and do the error correction or error mechanism to do that on line number 13. So over here, the thing is, now when I am going to call val1 divide by val2, the moment I enter 0, the JVM is going to generate object of the arithmetic exception class. Since I have put this in a try-catch block, the JVM is saying, are you ready to catch an arithmetic exception? Do I have a catch for arithmetic exception? Absolutely, I do have it. So I'm going to put the catch block on line number 13, and then I'm going to continue with my rest of the code from line number 30 onwards. So let's go ahead and see. So when I enter 5 and 0, Then over here, I should be printing line 13, and over here, going to hello. I caught the exception and I went ahead. My program did not terminate. I handled it gracefully. And if there was no exception, then the JVM would never generate that object at all. So I will just go ahead and do my code normally. So I will have 5 and this is 2. No problem. It is going to do line number 10. After line number 10, it's going to go ahead and do the line number 15. What is it? You said that there can be only one statement in the try? No, there can be any number of statements. So over here, if I have something like this system dot println by. Now the thing is, over here, the moment any statement within the try is throwing an exception, the rest of the statements within the try are not going to get executed. And I will look for my appropriate catch block. Over here, let's go ahead and check that. Again, I'm going to execute with 5 and 0. And then see 5, 0. Over here, by never got printed. I generated an arithmetic exception. I was handling the exception. I handled it and I went ahead with the rest of my code. Now, instead of arithmetic exception, I said we also know if it is array index out of bounds. So let us try the array index out of bounds exception. Now the thing is, this code on line number 10 is not generating that exception. An array index out of bounds exception has got nothing to do with the arithmetic exception. So although we have a catch block, it is not catching what my code can generate. So the program will terminate and it is as if there was no try catch block at all. Let's go ahead and check that as well and see what happens. Again, I'm going to enter 5 and then 0, 5, 0, arithmetic exception. The JVM is saying I have generated an arithmetic exception, and your catch is array index out of bounds exception has got nothing to do with it. Instead of array index out of bounds exception, what would have happened if I would have just written exception? We just discussed the concept in inheritance that the exception over here is the base class of arithmetic exception. The base class object, can it store the object of a derived class? Absolutely, it can. So that means although the object being generated is an arithmetic exception, the catches of a base class, can it catch it? Absolutely, it can catch it. So it should work and the exception should be caught. Let's go ahead and execute that and check over here. So Java C, it's getting compiled. 5, 0. Yes, it's getting caught. So I can put the catch of the base class as well. Is it necessary that you can have only one catch block? No, you can have any number of catch blocks. And you can go ahead and write. So for example, over here, can you have array index of bounds exception? You can have any number of blocks that is there, and you can handle it the way you want to handle it. Over here, this is arithmetic exception. This can be arithmetic exception, right? So the thing is, however, but remember that although I can have multiple catch blocks, only one statement, the moment any one statement within the try generates an exception, I am going to go and check whether there's an appropriate catch block for it or not. And then I'm going to go ahead and execute it. So now let's go ahead and let me create an array also. So int arr is equal to new int say 3. And then I am trying to generate system dot out println. So we are 4, trying to access a position which does not exist. And copy this over here so that array index message. Now let's go ahead and see what happens. Now I'm going to first give the value 5 and 0. In that case, line number 11 is going to get executed. And over here, since the line 11 itself is generating an exception, I'm looking for the appropriate exception. I got it on line 18. I went ahead and I did it. Now, let's try to see what happens if I give 5 and 2. Line 11 won't give a problem right now. 5, 2. Line 11 is not giving a problem right now. Line 12 was not a problem, but line 13 was a problem. It generated an array index out of bounds exception. I had the appropriate catch for it. I got it, and then I went ahead and did it. So I can have try with one catch. I can have try with as many catches as I want. And you can also have at the end of all the catch block, if you want, is something called as a finally. The finally is a block which is always going to be executed. Always, always, always going to be executed, irrespective whether you are handling the exception or not. Now, the thing is, in this particular case, if I do 5 and 2, let's understand what happens when I do 5 and 2. Over here, I have 5, I have 2, I have 5, 2, line 11 was not a problem, line 12 was not a problem. Line 13 generated an exception of array index out of bounds. Is there an appropriate catch? Yes, there is. On line 15, I did that whatever I want to do over here. Then before I exit that, I check whether there's a finally block. There is a finally block. I printed that and then I continued with the rest of my code. Why did I continue with my rest of my code? Because I actually handled the exception. Now, what I'm doing is I'm commenting this catch block. I'm not handling the array index out of bounds exception. And now let's see what happens. Arithmetic exception can't catch array index out of bounds. So 5 and 2. By happened. 5 divided by 2 gave me 2. By happened. Line 13 generated an exception. It did not have an appropriate exception. I came on line number 22 because there was no appropriate, but so I will execute the finally thing. Since I did not have an appropriate catch, I went ahead and I stopped my program over here with a normal exception. So this is the basics of try, catch, and finally of exception handling and the hierarchy of how exception handling really works. Now, there's something about exceptions that we need to know. There are 2 types of exceptions which are there. And Java programming is very specific about those type of exceptions. So one type of exceptions are called as checked exceptions. Which are these exceptions? The exceptions which are related to the exception class and the class is directly inheriting the exception class. The exceptions which are the subclass of runtime exceptions, they are called as unchecked exceptions. Now, what's the difference between checked and unchecked? We're going to look at that very soon. Now, what does checked exception and an unchecked exception, what is it over here? Right now, over here, the thing is, if you're using any built-in method, erase all of this stuff, comment this out. If you're going to use any built-in method which is capable of generating an unchecked exception, and if you do not have any try-catch block in your code, the compiler will not come to you. The compiler will be like, okay, this is an unchecked exception. If you're not having the ability to handle it, it's fine. It's okay. Now, over here in this particular line of code, is anything capable of generating an unchecked exception? Actually, yes, there is. Which particular line? This particular line. Next to it. This is a method of the scanner class. And if you read, this method can throw an input mismatch exception. How does it happen? Let's see how you can generate it. So I'm going to enter a number. I'm going to enter hello. I'm not entering an integer. I'm entering a string. Input mismatch. That means this method was capable of generating an exception, but we didn't handle it with a try catch. Now let's look at input mismatch exception and see which class is it inheriting. So input mismatch exception. Let's see that class. Documentation over here. If you see, input mismatch exception is inheriting runtime exception. Because you're inheriting runtime exception, it is unchecked exception. The compiler says, okay, this can generate an unchecked exception. You don't have any protection against it. It's fine. However, there is another way that if your code is generating a checked exception, or I wouldn't say is generating, has the ability to generate a checked exception, then the compiler thinks that the protection against this is a must. Over here, checked exceptions are like terrorists. Over here, they are like terrorists. You need protection against terrorists compulsorily, even if terrorists actually don't come. Unchecked exceptions are like chota mota thieves. Even if you don't have any protection against it, it's fine. It's okay. Let's see an example of how use a code which can generate a checked exception. Now, if you want to take input, we have been taking input from the keyboard. In reality, you can take input from a file as well. Now, if you go to the scanner class, let's go to the scanner class. So here, in scanner class, there is an ability to create an object to take input from a file. And if you look at the constructors over here, the first one, it takes a file source. Remember, file is another class. But let's look at this constructor. This constructor has ability to throw a file not found exception. And over here, let's look at a file not found exception. File not found exception is inheriting exception. That means this constructor is a capability of throwing a checked exception. Let's go ahead and try to see what happens when you do it. Let's first understand this file is of which package. File is of IO package. So I'm going to go ahead and import java.file. I already have imported scanner. First, I'm going to create an object of the file class because it's taking a file. So over here, yes, there's a file which takes a string path name. Just for understanding purposes right now, it's kind of code. And I'm saying file obj is equal to new file. And I'm going to give a name of the files abc.txt. This is the file which I want to be doing it. And instead of passing system.in, I'm passing obj as a parameter. Now, the thing is, see, it's giving an error. Unhandled exception type. The code is saying that you are supposed to have protection against checked exceptions. So, the main difference between checked and unchecked exceptions are normally checked exceptions are external exceptions, exceptions that happen because of external environments, not related to the program as such. Unchecked exceptions happen because of some problem in the code of your logic and they generate like divide by zero, accessing a position which does not exist. These are all normally unchecked exceptions. That's the difference between checked and unchecked exceptions. Now the thing is over here, the thing might be in a lot of software projects, one of the requirements is that your code should be generating exceptions or scenarios for your software requirements. For example, if you're applying for a university, the age in that particular thing, if the age at the processing comes out to be less than 18, then it's a problem. Right? Java is not going to give a problem for that kind of a value because 18 is a valid integer or 15 is a valid integer. But the thing is, if it is coming less than that, then it should be a problem. So your code should be able to generate, you can generate your exceptions as well. And you can have methods which are generating your exceptions. So let's go ahead and create a method. So over here, public static, I'm creating a static method for static void boolean is valid. Now the thing is, for I'm taking an age as a parameter, and the thing is, for age as a parameter, is how can an age be a valid age? Over here, it can be a valid age only when the age is a positive number. If it is a negative number and if it is more than 18, then I should be having that. So the thing is, if age is more than 18, it is return true. And then I'm saying else or whatever, else return false. And this is true and false that is being returned. But the thing is, if I give a negative value to age, that should not be processed. This method checks whether it's a valid age or not, but if it's a negative value, it should not be processed. That is an exceptional situation to your particular scenario. So then what I'm doing is over here is I'm going to say age is equal to 0, or I would say age is less than or equal to 0. This is not an acceptable situation. I'm going to create my own exception. So I'm going to say throw. The word is throw. Throw is equivalent to returning, but this returning is returning for exception objects. Now, throw, I am going to create an exception object over here. Now, do you want to generate a runtime exception or a checked exception? It's up to you. Let's generate a checked exception. I will throw new exception. I'm creating the object of the exception class itself. Now, let's see the exception class. Let's try to go to the exception class from here. And the exception class constructor summary, there is a which takes a message, a string as a parameter. So I'm going to just generate this particular throw new exception and say age cannot be negative. This is a situation that should not be happening. Since your method is capable of throwing an exception, you need to add a throws clause. Throws, and what is it supposed to throw? What can it throw? It can throw an exception object. It throws exception over here. Now, over here, if you want to go ahead and use this particular thing, in this case, let's go ahead and on the site. I'm going to first say age. I'm going to give some values of 15. I'm going to put it in my try and catch block. I'm going to call this method, since this method is generating a checked exception, I'm putting it in the try and catch block. And since it's returning a boolean, so I'm saying boolean val. Static method within the same class can be called directly. So I'm just going to say is valid age, and I'm going to say age over here. And this catch is exception, and right now I'm not doing anything. I'll just print it very quickly. Exception thrown. Right now, this particular method is not going to generate an exception because it's not less than equal to 0. But if it is negative 15, the control will go to the function. Line number 8 is going to get executed. An exception object will be generated. It will come on line 43. You're catching that exception and exception thrown. And by the way, you can go ahead and print the object and see what is going to happen. Remember, when you print the object, what gets called? The toString method gets called. And the toString method, let's see whether it's printing a message or not. Let's go ahead and execute and check very quickly. Yes, exception is thrown. Again, for the spelling mistake. And Java or Latin age cannot be negative. So we can have our methods which can throw exceptions. Sometimes, and actually most of the times, people actually go and create their own classes which inherit the appropriate exception class, either a runtime exception or an actual one of the actual exceptions or an IO exception, any of the exceptions, and then they give more attributes and more features to that particular class. So this is all about exception handling. It's all about handling errors which happen at runtime and handling them gracefully. And we just saw how you can create your own exceptions, which can be used to handle scenarios which are specific to your particular application. And this is something which is very, very much recommended. So let's go ahead and look at the other important framework called as the collections framework. Now, let's look at collection of objects, right? We have seen how to create one object of a class. Now, this is the same student class which we have seen earlier. It's a dumbed down version of it. Only one data member, age, the constructor, and the display age function. Now, you know how to create one object using the constructor. What if I want to create a one-dimensional array to this? Can I create it? Absolutely, I can do it. It is a students is equal to new student. And then I'm going to mention the size. So 3 students. Int ARR square bracket is equal to new int. That's how we created that integer array. So over here, I can create the student objects as well. But the thing is, what really is happening in this particular case? Let's understand in the memory what is really happening. Students, the name of an array is a reference. This is pointing to the location 1800. At 1800, there is the provision for 3 student objects. But what are these locations? These are actually going to be the references to the objects again. Remember an object, when you say student, OB is equal to new student, it is a reference to that particular object. Right now, an integer array by default has a value of 0. Array of references has a default value of null. And the thing is, over here, that means the actual object is never created. I've just created the memory for the references. And the references are not pointing to anybody right now. So if I actually go ahead and do students of 0, that's the first one. It's an object. And if I do, I'll call the display age function. Let's see what is going to happen. Dot display age. Let's see what's going to happen when I run the code. It is not pointing to anybody. The reference right now is null. An exception is going to be thrown called null pointer exception, which, by the way, is an unchecked exception. Another unchecked exception for you over here. Why? Because students of 0 is not pointing to any object at all. That means I will have to create the object. To create the object, what do we have to do? We have to call the constructor. And we do that just by saying the students of 0. The first reference is going to be new student. And I'm going to say, now, after this over here, I have gone ahead and I will be creating the object of the student, which right now has only one data member called age. The constructor is giving the value 10 at location 3000, and students of 0, which was 9, will now become 3000. That is what is going to happen. Now, this particular line is going to work absolutely fine, and it is going to get executed. So I'm going to say this, I'm going to compile, and this is working fine absolutely. Students of 0. Remember, students of 1, still an issue. Students of 1 still pointing to null, and it is going to give us the same null pointer exception only once again. This is an array of objects. There is a limitation of an array. What's the limitation? The limitation is once an array is created, over here, you cannot go ahead and change the size of the array. If you want to reduce it, you can't do it. If you want to add, you can't. You'll have to create a brand new array and then go ahead and do that. What Java has done is implemented something called as a collections framework, where they have created different collections which help in doing things faster. Now, which things? It can be inserting, deleting, searching, sorting, many of the things that can be done faster. Accessing, that's another thing which can be done faster. One, the information of the collections framework is given over here in this document about all the collections that are there. This table over here is summarizing the main collections that are there in the collections framework. If you see, these are the interfaces that are created: set, list, DQ, and map. I'm not going to get into too much details of this, but there's one of them which I want to pay attention on is list. It's an interface. Remember, interface, it has abstract methods, and these are all the classes which have implemented this interface. There's one class which we're going to look at is the array list class. Let's go ahead and look at the array list. Now, when I look at the array list class over here, an array list class is, as you saw the name over there, was a resizable array. Resizable array, that means this array can grow as and how you want. And you can add objects or anything to it as and when you want. Over here, you can create an array list. And then it is in the angle bracket, it's mentioned E. The angle bracket is an indication for you to specify what is this an array list of. E can be any class. Remember, it can be any class. That means I can go ahead and create an array list of students if I want. So let's go ahead and create an array list of students. Let's first check the package. It is in util package, so I would have to import it. So let's import the things. Import java.util array list. Now let's go ahead and create that. The thing is, I will be creating an array list of students. In my angle bracket, I'm going to write student. Students is equal to. This is an object of the class. Let's see, there is a constructor. And yes, there's a default constructor. It creates an empty list. So I'm going to say new array list. And again, I mentioned the type student only. This is an empty array list. I haven't added any objects to this particular list. So let us see. Yes, there is an add method, non-static method. It is returning a Boolean. Boolean saying that can you add? If it returns true, it can be added. If it does not get added, it returns a false. It appends the specified element to the end of the list. It's going to add at the end. The parameter type over here is E. E is an indication that it has to be of the same type which you created the array list of. That means over here, this has to be a type student. So I'm going to go ahead and I'm going to call the add method students.add, and I have to add a student object. That means a student object has to be created. I can simply say new student, and I can pass 10 over here. This is the student object that I created, and I have added that in the array list. Let's go ahead and add one more. So over here, copy pasting. This is an adding of 20. Now, is there a way to access a thing from this particular class? Is there a method to do that? Let's see if there is get, which takes a position. Remember, it's an array list and not an array. We have to use the methods to access it. It returns E. E again over here is student. So I can go ahead and write that over here. So I'm going to say student OB is equal to student dot get 0. 0th position. Again, position is same. Now, if I do OB is an object of the student class, OB dot display age, it should be printing 10. That is the object that is there over here in this particular case. That was the first object that we added to the array list. Now, a very important point that comes to our mind is that over here, that array list takes E. The angle brackets is E, and I just said that E has to be a class. Can it be string? Yes, it can be string. Can I create an array list of strings? Yes, because we just saw that string is also a class. However, can it be int, the normal int that we have been seeing right from the beginning? Unfortunately, it can't be because it's a primitive data type. And over here, what array list needs in B is a secondary data type. To handle the collections framework and for many other purposes, there one thing that Java has gone ahead and done is for each of the primitive data types, it has created a corresponding class. For int, the corresponding class is called integer. For double, it's double. For char, it's character. For boolean, it is boolean. These classes are called as wrappers. So whenever you need an object only, something that can work only with objects of a class, and if you intend to work with the primitive types, Java says, go ahead and use the wrapper classes. Now, over here, how can I use the wrapper classes over here? So let's go ahead and want to comment this for now. Let's see how do we work with the wrapper class. Let's see the integer class, integer platform. This is 7. These are the static data numbers, max value, min value, and size. You have the constructor summary. You can create an object by passing an int as a parameter. That means I can go ahead and create an integer object. Integer n is equal to new integer 15. I can go ahead and I can do that. Now, if you see over here, it is giving some green thing over here. It says it is the constructor is deprecated since version 9. What it is basically trying to say is basically you can actually go ahead and directly give the value. Remember, this is only for the wrapper classes, what I'm showing you right now. Integer t is equal to 20. There is an automatic conversion of int to an object of the integer class. This concept is called as auto boxing. You're boxing the primitive into an object. Auto boxing. Similarly, a T is an object of the class. If I want the corresponding int, let's see if there is any method which can give us that particular thing. Over here, int value returns the value of this integer as mint. Let's go ahead and do that. So over here, I'm going to say int val is equal to t dot int value. Now again, it is saying something over here. It's saying, okay, it's saying the value is not being used. I thought it will show something else. But what I'm going to show you now is if there's an auto boxing concept, there is an auto unboxing concept as well. That means instead of you writing int value is equal to t dot int value, you could simply write int value is equal to t also. I can directly assign t, which is an object, to a primitive data type because of the concept of unboxing. Line number 20 implicitly gets converted to line 19. Line number 17 implicitly gets converted to line 16. And if I go ahead and print the val, you will see it will be 20 old. Let's go ahead and run and check. Yep, we are getting 20. So you have a way of using the wrapper classes. So you can use the wrapper classes and you can create an array list of integer and not array list of int. And then you can work with integer objects. And the whole concept of auto boxing and unboxing makes it easy for you to not worry about creating the object and converting it back to int. And using the methods auto boxing and unboxing takes care for you for itself. So this is auto unboxing. This was a quick overview of an array of objects. An array list which was a collection made by the Java framework, and how wrapper classes come into the picture. Now let us get another very important topic is there. I'm just going to give you a brief overview of what it is and what you can, of course, explore more in depth, and it is used quite widely. The concept is of multi-threading. What is multi-threading? Multi-threading is the ability of a process to have different parts of the same program running concurrently. Very important and you have also used it in your daily life all the time. Now, say for example, within a big program that you have written, a big piece of code that you have written, there is some piece of code which has gone ahead and which is hogging all the resources and doing some heavy computation. But there's some other part which has got nothing to do with that particular part. The thing is, if you write everything sequentially and serially, everything is going to get everything is going to go on a halt, on a stop, because the other part of your code is still not doing any work. Let's take a real life scenario of how that thing particular is. Now, say for example, when you open any app, which is music playing, the thing is now when you open the app, you open and there is an option to play a particular song. The thing, the moment you you said, okay, this is the song which I'm going to play. What really happens is the screen is not does not become that okay, only now you have to listen to the song and that's it, nothing else you can do. The thing is this kind of goes over here, goes to the bottom, and the song keeps playing and there's an option to pause and all of that stuff. And you can still interact with the remainder of the app, which is there. It's the same app where you're doing multiple things at the same time, doing two things at the same time. This is a thread. The playing of the song is happening on a separate thread, and the whole interaction with you while changing the name or doing anything or whatever, making your playlist or whatever, that is happening on a separate thread. And that's a very important concept used quite heavily. In many banking applications, in many real life applications of the same process, multiple threads are created so that over here the process is faster. And if there's something which is independent of the other, it doesn't really affect it. It just keeps on executing. Now, in your program, you have been writing class. The thing which is necessary for every program is class name. And inside class name, there is public static void. A fun fact, when you run the program, the JVM actually creates an object of the class thread. There is a thread which is a class, just like how exception was a class. Over here, thread is actually a class. And your main method is actually executing on that particular thread. So far, in your entire program, there was only one thread that was getting created, and your entire execution was happening on that particular thread only. Now, what thread class allows us to do is that you can go out and create multiple threads, and if you want, you can execute them concurrently. Remember, at any given instant, only one of them might be hogging all the resources, but over here, they can execute. You will get a feeling that they are all happening at the same time. For that, first we need to understand there is a certain life cycle that a thread follows. If you want to create a thread, how do we get it into the actual way that we want it? So we need to understand the life cycle. The first thing is we create a thread. We create a thread, and when I mean by create a thread, there has to be an object. We have to be creating an object of this particular class. Normally, there are two ways of doing it. We'll be discussing those two ways. The other thing is after you create the thread, you need to get it to the ready to run stage. How do I get it in the ready to run stage? We will be looking at the thread class documentation and we'll be doing it. Whenever a thread gets an opportunity to run, the thread will be going in the running stage. Then, based on what work you are doing, it can enter into a blocking stage or a waiting stage. And finally, once the work is done, the thread dies, exits. The thread automatically terminates. Now, let us look at the thread class over here. So I'm going to go ahead and share my screen. And let's go to the Google Chrome browser. And let us open. Let us open the documentation of the thread. So thread class in Java. Thread platform 7. Thread again inherits the object class. And the thing is over here, every thread over here has main attributes. One of the attributes of the thread is the name of the thread. The other is which group it belongs to. And the third property is the priority. So in the field summary over here, you can see what the priority of the thread is. Which thread do you want to execute first? Min priority, max priority, and norm priority. They have all some values. They are static data members. You can go ahead and you can do that. Now, after you create a thread object, to create a thread object is basically creating an object of the piece. And you can get it over here to the ready to run stage. In order to get it to a ready to run stage, there should be a method. Start. We need to call the start method to get it into a ready to run stage. In the running stage, this is the method which is going to be executed, and automatically the JVM is going to execute the run method of this particular thing. That means whatever logic you have should be in the run method of this of your particular class. Now the thing is, since you are going to be creating your own thread and you want to provide your own meaning to the run method, what is the best way to do? Inherit the thread class. So I'm going to say class my thread extends thread. And what I'm simply going to do, I am simply going to go ahead and override the run method. In the run method, I'm simply putting a for loop for I is equal to 1, I is less than 10, I is plus, and I am putting a try catch, and I'm deliberately going to be calling the sleep method. Now the thing is, there's a sleep method, a static method, so that I can demonstrate to you what happens when a particular thread is gone to sleep or it's waiting. So it's a static method of the thread class. So I'm going to say thread dot sleep. And I'm going to say it's taking in milliseconds. So I'm going to say 1000 milliseconds. It says milliseconds. Milliseconds. And I've put a try catch block. Why? Because it's throwing an interrupted exception. Interrupted exception is a checked exception. So I hate the try catch block. I can't avoid it. So I'm going to have catch. And I can write exception base class can have it. This is not going to happen. I'm not providing any body right now. So that is the thing. And I'm going to do system.out.println. I'm going to say this is what the run method is doing like that. This is our thread. This is what we want the work to be done. Now, in order to do that, remember the execution, the JVM is only going to create the object of the main thread. The main thread, and that it is your execution is going to begin on line 17. That is, it's your responsibility to create an object of your thread. So I'm going to say my thread open is equal to new my thread. I will create an object of my thread class, okay, and then I have to get it to the ready to run stage. Ob.start. Remember, right now there will be two threads be running. So let me show you diagrammatically how it is going to work. The main thread got created by the JVM. Your program is executed. At this point, you created one more thread called the my thread. I'm just calling the or class names like that. That's not really the name of the thread, by the way. This is just the class name. And then over here, the moment I do start, this is in the ready to run stage. Currently, this is the thread which is executing. The moment the main thread waits, my thread, if it is available to run, if it's not waiting or anything, it will start executing immediately. So what I'm going to do is I'm going to put this main thread also in the seek. So and copy that try catch over here. Say I'm going to put it for sleep for 500, 1500 milliseconds. And also have a form over here as well. Actually, I'll copy the same thing. Let's copy the same thing. Yep. This is a for loop here, and I'm putting it for a sleep 1500 milliseconds. Now let's go ahead and execute. Remember, the output of this particular code cannot be predicted because who sleeps for how much time, what is the, even the switching takes some time. So the execution can be varied. So over here, let's go ahead and execute and see what happens. So, okay, we are not understanding which thread is being executed. So I'm going to put one thing over here. I'm going to say main, and here I'm going to say our thread so that it's clear which one is going to get called. Let's understand. Our thread main, our thread main, our thread. So you see, our thread happened two times. Over here, it is very unpredictable. Sometimes our thread is happening twice, sometimes our thread is happening only once. And then the moment it happened, our thread got completed, that thread got over, and the remaining statements of the main thread are executed. So this is the basic concept of what multi-threading is. Over here, remember that it is not the other way to create a thread is to, since I'm only interested in overriding the run method, the other way is to create the runnable interface. Runnable interface in Java. If you look at the runnable interface, and it has only the run method. That means you need to implement only this particular method. And in the thread class, using the runnable interface, over here, if you create an object, let's see whether there is an object which is there, which can be created. Yes, there's an object which can be created, which is runnable as a parameter. So that's another way to create a thread object. Life cycle once again, create the object, ready to run stage using the start method. You need to override your run method, do whatever work you want to do over there based on the priority, and whenever there is a resource available, your thread will get the chance to execute. And if your thread is waiting, the other thread can jump in and start executing from there. There are many other aspects to multi-threading as well, but this is a good enough idea for you to get started on this topic on multi-threading. Now, the last thing that we'll be covering, a very quick one that this will be, is the concept of command line arguments. Now, what are these command line arguments? arguments. You've been wondering right since day one, what is this string args? These are the command line arguments. Now the thing is, if you also remember in the console, whenever we ran the program, there used to be two commands that came. One was the command to compile in Java C, and the other one was to execute. We can also go ahead and give this command. So over here on Repl, there's an option called a shell. In a Windows machine, you'll have the command prompt, or in the terminal called in the Mac, and same way in your Linux machine as well. You will go to the location. You will go to the location. This is the location where this particular file is present called moving.java. You can go ahead and you can compile the file using the Java C command. So you can say Java C space the name of the file. The name of the file which we want to compile right now is main.java. Now, before I press the enter key, let's write something in the file. So I'm going to go ahead and write. This is an array. So I'm going to print the arguments as an array. So I'm just going to say args of 0. I want to print the first value right now. So right now we'll compile the file and we'll see if everything works or not. Let's go here and press the enter key. It's compiling. It's taking a little longer than expected. Compiled successfully. Alright. So the thing is, if there's no error, it will compile successfully and give you the answer. Now let's generate an error and see whether the things are coming. If you want the previous command, you just press the up arrow key over here, and the previous command will come in. Again, it is compiling, and now you should get the error. Same compiler error you used to get. So you got the error over here. Coming back to this, let's go ahead and compile it over here. Compile it. There should be no compilation error. Now, after compilation is going to be successful, now we will execute it. So the execution command is Java space the name of the class which has the public static void main. Which class has it? It is the main class. So I'm going to say main. And if I want to give the arguments, this is where I will give the arguments. Give a space, and with every space you can give the arguments. So you can say hello, say okay. But they're giving 3 arguments right now in this particular case. Right now, and I'm just printing out the first one. So the answer should be hello. Yes, hello got printed. Now, what would be the benefit of running the command line arguments? The thing is over here, in many programs, based on the main thing, your entire program's flow completely changes. One very simple example could be the thing that, okay, if you want to start a game, before you even start the game, based on which version of the game you are playing, the whole setup keeps on changing. So probably you can give it as a command line. Just give me an example over here. There is very helpful over here to pass anything, and based on args value, I can go ahead and I can do more processing. I can call different class. I can create objects of some other class. I can go ahead and make some kind of a menu-driven program also using these command line arguments. Remember, the Java C and Java commands only come if you have installed Java properly in your machine. So JDK has to be installed and from the Oracle's website, and the proper paths have to be given. You don't see that over here, but you have to explore that, get those paths, and then only these commands will work for you appropriately. The last thing which I want to discuss is the concept of debugging your code. Now, debugging your code is a thing which is it is one of the most important tasks as a software developer. And you should be able to debug any program, whichever you want to do. Every IDE that you install, we have done the entire thing using Repl over here. Also, professionally, you will go ahead and download IntelliJ or Eclipse. Um, and the thing is, in all those IDEs, there is a concept of a debugger. Debugger over here in REPL is also having a debugger over here. This is in the beta phase, so let's try it out over here. And the thing is over here, it says to add a breakpoint. So the thing is over here, breakpoint. Now, what does breakpoint really mean? So I'm going to comment this line and I'm going to uncomment this particular thing. A breakpoint is a point in your code where you want the execution to halt and see what the status of all the variables is in that code in that particular thing. So I'm just going to go ahead and is it allowed? Yep, that's it. If you click on the line number 8, I have the blue dot is done, that means it's a break. In an IDE, there is a concept of a debug. So when you run in the debug mode, wherever there is a breakpoint. Now, where will you put a breakpoint? You put a breakpoint around the code which you think might be an issue. And then you will go ahead and you will stop the thing over there. And then in that case, you will go ahead. So I'm going to go over here and see and going to run it. In an IDE, what's going to happen is you are going to have the option. So if you see it is compiling over here. Over here, you're going to have the option of actually going ahead and putting a breakpoint. A whole new window pops up and everything. And that is what is going to happen. This is a little time consuming, so let's wait for it for some time. Okay, so over here, after a long time, because it was an online IDE, it took a bit of time. Then this over here, your program has stopped over here. And it is, at this point, it is saying that val has args as an array of strings, and val has the value 45 right now. And now, let's go ahead and go to the next step. Next step over here is that number 10. After this, val should become 49. Let's see if this becomes 49 or not. Yes, val has become 49. So I only have one variable right now, but you can have multiple variables and you can keep track of all the variables. And it is really helpful for us to do that. And once you're done with your work, you can just go to the next breakpoint. There's no other breakpoint. That means the program will terminate to print the value 49 and the program will stop. Okay. So debugging, having a breakpoint, very, very, very important. This is the concept of object-oriented programming, and we saw how we used it in different aspects of collections framework, inheritance, how inheritance was important, how exception handling it was used, multi-threading, how it was used, and I really hope that you have understood this. And, yep.
So that is it. That was our last concept in the field of Java programming. It's Java, everything that we have covered, not really, to be honest, but it does cover, I would say, the majority of the concepts that is used in the industry. Once you understand this, any new concept that comes in the field of Java programming should be easy for you to understand, as long as you get these basic fundamentals of what's a class, what's an object, and all the other concepts related to object-oriented programming. So I hope you guys liked the video. If you have, please go ahead and please like the video once again. And also, I would like you to please go ahead and share and subscribe to this channel of Scalar Academy. We will be coming with more such content and more such exclusive tutorials. Watch out this space for more. And as always, if you have any questions or concerns, please go ahead and mention that in our comment section below. Thank you so much. And I wish everyone the best of luck in the field of Java programming. All the best. Thank you.
Hello everyone, I am Yogendra and today we are going to show you how we can install Java or the Java development environment or the Java Development Kit, which is commonly called as JDK on Windows 10, and how to install an IDE, which is Integrated Development Environment of Java as well. In this video, the IDE which we'll be installing is Eclipse, which is quite a common IDE among Java developers. It is quite common just because it is easy to collaborate and work with. And companies like Apple, Citigroup, Qualcomm and Bank of America use Eclipse, so it will be a bonus to add this on your resume as well. So the agenda for today's video will be installing JDK and then proceeding with the Eclipse IDE installation. But before moving on with the video, for more such videos on Java, do not forget to hit the like button, and it would mean a lot to us if you could subscribe to our channel. So without further ado, let us now go ahead with the demo. So let us now proceed with the installation of Java on Windows. Let us go to Google Chrome and search for JDK or Java. And also you don't have to install Java runtime environment as a separate installation. If you install JDK, the JRE will already be installed or included in the package. So we don't have to download it separately. We need JRE or JDK to run Java applications on our computers. So let us just install JDK so that it will be JRE also will be included with it. So let us go to Google Chrome and search for JDK. So let us search for JDK installation. And over here you can see that the website over here is Oracle. So Oracle is the company which developed Java. So we can click here and see what we get it. So here you can see that the latest version is 17.0.1. So LTS means long-term support. So that means, the support is still going on for that version. As you can see over here, we have different OSs, but right now we are interested in Windows. So let's click on Windows. And over here we have 3 installers. So there's zip installer and just the executable file, that's exe file, and the MSI file. So we are interested in the MSI file for 64-bit. So let us go ahead and click this. Okay, now that we see that the download is complete, the file has been downloaded. But before installing, let us check if Java is already installed in our system or not. Like, is there any version of Java which is already present in the system? So to do that, we'll have to go to command prompt. So you can press the Windows R button in the keypad or the keyboard. So if you go to the command prompt, and there's a command called Java. So that's Java -version. So what it does is, if Java is already installed in the computer, it will give the version of that particular Java version. Or if it isn't, and in my case it is not installed already, so we'll see what we get if it is not installed. So you'll get the Java is not recognized as an internal or external command. That's because Java is not already installed in my computer. And there's an alternative way to do this as well. So instead of Java, the command now will be Java C. So the C here represents compile. So that's Java compile, Java C. Java C is nothing but the Java compiler version. So, and the same thing, -version. If we check this, again we get that Java C is not recognized as an internal or external command. So this does mean that Java is not already installed in my system. And now let us move ahead with the installation by just opening it and installing it. So you give the necessary permission. So after doing that, the setup configuration will start. Yeah, you can see that it's preparing to install. So this is how the setup configuration guide will look like. So you can click on next, and this is the path or the folder where all your JDK files will be installed. So if you want to, customize it based on your choice, you can do that using the change button and browse particular path over here. You can just copy paste it here. So I want to install it over here itself. So I'll just click on OK and then click next again. There's no other customizations to choose. Okay, so as you can see, the Java development kit or the JDK 17.0.1 has been successfully installed, and we can close this now. And now, since we've already installed JDK, we'll close the command prompt and try to look for it again. So we'll close this first and do the same thing, open the command prompt again. So over here, now if you give the Java command and the hyphen version thing, so I think you'll get the version because Java is already installed in our system. So if you click on enter, so we have the Java version as 17.0.1, which is the version which we installed today, and the same command, the Java C command. So that's Java C hyphen version. If you press enter, you have the Java compiler version also as 17.0.1. So this confirms that Java or JDK has been installed successfully. And now let us go ahead and put Java or Java home as path or environment variables. This is to run Java from command prompt so that it's easier to access. So let us do that, and for that you need to go to settings. Okay, so here you need to go to environment variables. So and click on edit the system environment variables. And over here you have a button in the advanced tab saying environment variables. So click on it and you have a numerous number of variables over here. So over here go to path and then edit this one. So click on edit. Over here you can give the path of Java where it's installed. So for that you need to go to this file explorer and go to the Java path, go to C drive. For me it's C drive and for you it would be different. So C drive, program files, Java, and over here JDK 17.0.1. And always remember that bin is the important folder inside JDK. So this is where all the executable files or the DLLs are loaded from. So this is the path we are supposed to give in the environment variables path. So copy this and just paste it over here. Get a new one. So over here you can paste the given path. So that's C, program files, Java, JDK 17.0.1, and then bin. If you click on OK, you can see that the path variable has changed over here. If I click on edit, you can see that the path has been added. So that's how you add Java to path or Java as an environment variable in Windows. So after that you can click OK. So now that we've added Java to our environment variables list, we can proceed with the installation of Eclipse. Eclipse is mainly used for Java, and which is the programming language which Eclipse is built on. But along with many plugins, we can use Eclipse for languages like C, C++, Python, and so on. And for Eclipse to run, we need Java to be installed already in the system. So that is the reason why we installed JDK first and then we are installing Eclipse. So let us go to the browser and install Eclipse first. Let us do that now. So Eclipse installation. So over here you can see that the official website pops up. So that's eclipse.org. You can click on it. So after clicking on it, you'll get the official page and you can allow cookies or whatever. So over here, as you scroll down, you have a button saying download x86 for 64. So you can click on this button. So that's Eclipse 2021 version. You can click on that button and it starts a download prompt. So it will give you the nearest location. So that's something. And you can just click on the download button over here and we'll wait until the download starts. So over here you can see that the file is around 113 MB for the current version which we are downloading. So it might differ in the future, it might increase or something. Okay, so we can see that the file has been downloaded and we can open it. now. So here you can see that the Eclipse installer has started now. Okay, so here you can see that there are a wide number of languages that we can use Eclipse for, like I told before. Since we are interested in Java, we'll be clicking this. So you can use Eclipse for C, C++ as well. And you can use Eclipse for embedded systems development. You can use Eclipse for PHP as well. And you can use Excel for Python as well. Since we are interested in Java, we can go ahead and click this. So these can be used with the plugins later on as well. So that's one thing. And we can start with this, the Java installation. So over here, you can see that the path is Java JDK, which is we've already installed. That's the JDK path, and installation folder for Eclipse will be this. So that's users interview bit Eclipse Java, and you can change it using this button as well. So that's one thing, and we can proceed with the installation. So if you want to change the path, you can do it using browse button. So since I don't want to change it, I'll just click on install. It'll create a desktop shortcut as well now. So these are the software user agreement. You can just go ahead and accept it. So as you can see over here, it will create a start menu entry and also a desktop shortcut for us to access it easier. So yeah, here you can see that the Eclipse has been installed, and you can launch Eclipse from this button itself. So you have a desktop shortcut which we chose while installing it, so you can open it. So here you have a workspace path where all your working data will be saved, or the worksheets will be saved. This is the path which the workspace will be working on, and you can use this as a default workspace, and so that it won't ask you again. So I'll do that and launch Eclipse again. So it is starting the Eclipse IDE, as you can see over here. Yeah, over here you can see that this is the starting page of Eclipse. So we have successfully installed Eclipse IDE for Java developers, and that brings us to the end of this video. With that, I conclude this video. I hope you're clear with how we can install both Java Development Kit and Eclipse on Windows. In addition to this, we have also looked at how to add Java to path or environment variables. So if you guys like this video, make sure you hit the like button and don't forget to subscribe to our channel. Thank you.
Hi guys, my name is Devi and I am back with another video for you all. So today's video is going to be really helpful for anyone who is looking for basic beginner level projects based on Java programming language. But before we move on with the video, I would request you to please like this video and share it with your friends and family. Also, do not forget to subscribe to our channel because we keep bringing you new videos based on multiple technologies and trends every single day. So in this video, we are going to look at two different projects which are very basic yet very easy to understand and are going to help you clear your concepts of Java programming. We will be looking at two different projects. The first would be an ATM machine interface, and the second project is going to be a calculator application. One by one, I am going to show you how you can work with these two projects, how the code is executed, what functions, what methods, and what all features of core Java have been used in creating these applications. So let us begin. Okay, so the first application that we have is the ATM machine interface or an ATM application. Now this is a very basic ATM machine interface or application that we have created with the help of core Java concepts and OOPS concepts. As you all must be knowing how an ATM machine works, like you can probably insert your card into the machine and then perform operations on your account. It could be your current account, your savings account, and you can perform different types of operations on your account, such as you could view your existing balance, or you can even withdraw or deposit funds into your account. So that is exactly what we are going to look at today in this application. So as you can see, I have created a project ATM, and within this project we have three different classes. Now the first class that we have created is the ATM class. The next class that we have is the main menu class, and then again we have another class which is the account class. So one by one, I'm going to show you what all code we have inside these classes and how it is going to function. So starting off, the first class is the ATM class, which extends the main menu class, as you can see here on the screen. Now the ATM class consists of this public static void main function. Now I'm sure you know that the entire program starts running from this point itself. Like the main method is the first method that gets executed, and this is the point or the initial point from where the program starts getting executed. So here, as you can see, we have the main menu class, and then we have created an object for this class which is also termed as main menu. You can see here this object calls the getLogin method. Now this is all that we have inside the ATM class. Again, let us have a look at what is this getLogin method. Moving on to the main menu class, you can see here we have different packages. You can see we have used decimal format, utility packages. We have the IO exception as well. Now, once we begin this main menu class, you can see it is extending the account class. First, we have the scanner class here. Now, I'm sure you know why we use the scanner class. It is basically used for accepting user inputs. Next up, we have the decimal format class and the money format. Now, what is this money format here? We are actually specifying the format in which we want the currency to be displayed. That is your account balance. Again, next we have the hash map. Now, what is the purpose of using a hash map here? What we are basically going to do is we are going to give a set of records here. As you can see on your screen, we have different set of records here. Now, what this hash map does is it creates a record or a mapping wherein we have a customer number and a PIN number which is associated with a particular customer number. Now this is exactly what is the purpose of using a hash map. It basically creates a mapping. Now once we fetch the set of records to the application, moving on, we have our first message which is going to be displayed. This is welcome to the SMB ATM, enter your customer number. Now this is the message which is going to be displayed initially. Once this message is displayed, we have the set customer number method. Now, what does the set customer number method do? Let us have a look at it. In this account class, as you can see, we have the set customer number method which accepts the argument customer number. It is of integer type. Now, this customer number is the user input. That is, the user or the customer gives in a particular number which is taken as the customer number. Okay, now once this is done, the application again asks for your PIN number. This message is displayed, enter your PIN number. Again, we have the set PIN number method here. Let us have a look at what this method consists of. Here, as you can see, we have the set PIN number method. It accepts an argument which is again of integer type. This would be the PIN number that is entered by the user. Once you have entered the customer number and the consecutive PIN number, here you can see we have a catch block as well. Now, why do we need this catch block? Suppose you make any mistake while entering your customer number or your PIN number, as in you could probably enter any invalid character in place of your PIN number or customer number. In that case, what happens is this catch block gets executed and this message is displayed which is invalid characters, only numbers. This message gets displayed on the screen. Now, suppose you do not make any mistake, as in you enter any number, any set of numbers as your PIN number and customer number. Next up, what happens is we have these methods which is get customer number and we have this get PIN number method. What these methods consist of? Here, as you can see, we have the get customer number method. Now, this get customer number method, it returns the customer number which is input by the user, and the get PIN number, let us have a look at that. Here's the get PIN number method. Now this get PIN number method, it accepts or rather returns the PIN number entered by the user. Once all of it is done, we have another validation section right here. This is actually an if-else block right here. Suppose you enter the customer number and the PIN number, but they are not associated with each other. Like we have these set of customer number and PIN numbers which are mapped onto each other. Suppose you enter customer number which is right here and the PIN number that you have entered is this one. Then what happens in that case? Then you have an error message which is displayed, and that error message is wrong customer number or PIN number. So once we are done with this section, we move on to the next method. But before that, let me just minimize this section. So the next method that gets executed is the get account type method. Now what is there inside this get account type method? We have a list of few statements which get displayed one by one. Here's the first statement, which is select the account you want to access. That is, the machine is asking whether you want to work with your current account or whether it is your saving account that you are going to work with, or the last option says exit. That means if you do not want to work with any of your accounts and you just simply want to exit this, then you can choose the third option. Then you have to select either of these options. Either you can go for option 1, 2 or 3. Here we have used switch case since we are working with options right here. So we have listed out 3 cases. As you can see, the first case is get current method. The second case includes get saving method. The third case displays a statement which is thank you for using this ATM. And the default section has a statement which is invalid choice. So one by one, let us take a look at these methods. First up, we have the get current method. Okay, so as you can see, we have the get current method right here. Now, inside this method, we have another few statements. First is the current account. Then we have 4 options listed out for the user. First option says view balance. Then we have press 2 for withdraw funds, press 3 for deposit funds, press 4 for exit. And then it is asking you to choose either of these options. Okay, so if here you choose to work with your current account, then you get this section displayed right in front of you, wherein you have to select either of these options. Okay, now suppose you select the second option, which is the saving account. In that case, what happens is case 2 gets executed. Now case 2 has this get saving method. Let us see what is there inside the get saving method. Here you can see we have the get saving method. Again, inside the get saving method, we have saving account, and then we have 4 options, which is the same as the current account options. And then you have to choose either of these options. Okay, now suppose you choose to exit this operation. Then what happens? You get this statement displayed in front of you, which is thank you for using this ATM. And suppose you do not choose either of these 3 options and you enter a number, say 4, 5, 6 or any number other than 1, 2 and 3. In that case, what happens is you get an error message which is invalid choice. Okay, so now we have seen what is there inside the get current method, and we have also seen what is there inside the get saving method. Suppose you decide to work with your current account and you choose to view your balance first. In that case, what happens is, again we have switch case here. The first case gets executed, that is, it displays your current account balance in the money format specified by you. So here we have the get current balance method. Now what is there inside the get current balance method? Here you have the get current balance method. What it does is it returns the current balance in your account, that is the existing balance in your current account. Again, suppose you decide to go for the second option. Now what is the second option? Second option is to withdraw funds from your account. In that case, what happens is this case gets executed, which is the get current withdraw input method. What happens here? Let us take a look at it. Here's the get current withdraw input method. The first statement which gets displayed is the current account balance or the existing balance in your current account. Next, the machine or the application asks you the amount that you want to withdraw from your current account. You need to input the amount that you want to withdraw. Then this if-else block gets executed. The amount is deducted from your current balance and the new current account balance gets displayed right in front of you. In case the amount that you want to withdraw is more or larger than the existing balance in your account, in that case what happens is this else block gets executed. Then the statement which gets displayed is balance cannot be negative. Now here, as you can see, we have another new method which gets executed. This method is the calc current withdraw, which also takes argument which is the amount you enter. This is the amount that you need to withdraw. Now let us take a look at what is this calc current withdraw. Okay, so here's the method that I was talking about, calc current withdraw. This takes the argument which is the amount you need to withdraw, your current balance here, then the amount gets deducted from your current balance and the new current balance is returned. Okay, so once this is executed, you have your new current balance. Now suppose you want to deposit funds into your current account. In that case, the third case gets executed and the get current deposit input method gets invoked. Now let us have a look at this method, what is there inside this method. Now here we have the get current deposit input method. First, the existing balance in your current account gets displayed. Next up, you need to enter the amount you want to deposit to your current account. The user input is accepted. Then this if-else block or the validation takes place. The amount which you need to deposit is added on to your existing balance and the calc current deposit method is invoked. Now what is there inside the calc current deposit method? Here, as you can see, the amount you want to deposit gets added on to your existing balance and the new current balance is returned. So the new current balance, it gets displayed right in front of you as you can see here, and if there is any sort of mistake or error, the error message gets displayed in front of you. Now again, if we go back here, suppose you decide to go for option 4, which is exit. In that case, the message thank you for using this ATM gets displayed in front of you. Again, if you choose any number other than these 4 numbers, which is 1, 2, 3 and 4, say you go for number 5, 6, 7 or any other number. In that case, the message invalid choice gets displayed in front of you. Now, once you are done with this section, next up we have the get saving method. Now this method is quite similar to the get current method. The only difference is that here you can perform operations on your saving account type. Again, if you want to go for option 1, which is view balance, in that case what happens is the first case gets executed and the message displayed is your saving account balance and your existing balance in the saving account gets displayed in the money format which has been specified by you. Next, if you decide to withdraw funds from your saving account, in that case what happens is the second case, which has the get saving withdraw input method, it gets invoked. Now what happens inside this method? Let us have a look at it. Now suppose you have the get saving withdraw input method gets invoked. Here the existing balance in your saving account first gets displayed. Next up, you are asked to enter the amount that you want to withdraw from your saving account. Once you put in the amount or the input that you need to withdraw, this if-else block gets executed. Here, as you can see, again we have the calc saving withdraw. This method gets invoked and inside this method, the amount that you need to withdraw gets deducted from your existing balance and the new saving balance is returned. Then what happens is the new balance is displayed in front of you, and suppose you have entered an amount which is greater than the existing balance in your saving account. In that case, this error message that is balance cannot be negative, gets displayed in front of you. Next up, suppose you go for option 3, which is to deposit funds. In that case, what happens is the third case, which has the get saving deposit input method, it gets executed. Now the get saving deposit input, this method is right here. What happens first is the existing balance in your saving account gets displayed in the money format specified by you. Next, the machine or the interface asks you for the amount you want to deposit to your saving account. Once you have entered the amount, this if-else block gets executed. Now what happens is the amount that you have entered, it gets added on to the existing balance in your saving account. For that, this method, which is the cal saving deposit method, it gets invoked. Now let us quickly have a look at this method. We have the cal saving deposit method right here. The amount you want to deposit gets added on to your existing balance and the new saving balance is returned. Then what happens is the new saving account balance gets displayed in front of you. And in case of any error, this message gets displayed in front of you. Suppose you do not want to perform any operation on your saving account and you simply want to exit this. In that case, you need to choose option 4 and the result or the message which gets displayed is thank you for using this ATM. Suppose you choose any number other than number 1, 2, 3 and 4. In that case, what happens is this error message, that is invalid choice, gets displayed right in front of you. Now, we have had a look at the entire code for this application. I'm quickly going to show you how this application or this interface can work. As you can see, first we have this message displayed here, which is welcome to the SNB ATM. Enter your customer number. So here we have different set of records that we have already have a look at. Let me just quickly take any of these customer numbers. Suppose I want to go for the first this number here. Now it wants me to enter the PIN number. It displays the error message wrong customer number or PIN number. Again, if I enter this right here and I enter the correct PIN number, so here it is. So now it is asking me to choose whether I want to work with my current account or whether I want to work with my saving account. In that case, I need to choose either of these options. Suppose I decide to go for my current account. I'll choose option 1. Okay, so now I have all these options listed right in front of me. Whether I want to view balance or withdraw funds or deposit funds or whether I want to exit. Suppose I want to view my existing balance. As you can see here, the existing balance in my current account is $0. Then again I have to choose either of these accounts. So I decide to go with my current account and now I want to deposit funds. Okay. So the current account balance or the existing balance in my current account is $0 and I need to enter the amount that I need to deposit in my current account. Say I want to deposit $500. Okay, so the new current account balance is $500. Again, I have to choose the account I want to work with. I want to work with my current account. Now again, I have to decide whether I want to view balance, withdraw funds, deposit funds or exit. Next up, I want to withdraw funds from my current account. So I have selected option 2. Now I need to select the amount that I want to withdraw from my current account. Say I want to withdraw $600. Okay, so here's the error message, that is balance cannot be negative. Since I have $500 in my account and I decided to withdraw $600 from my account. So this operation cannot be performed. Hence, balance cannot be negative message gets displayed. Again, if I choose to work with the current account and I want to withdraw funds. So I'll go for option 2. Now I need to specify the amount that I need to withdraw. Say I need to withdraw $300 from my account. So the new current account balance is $200. And again, I have these 3 options listed in front of me. So I'll just go for exit now. As you can see here, the message has been displayed. Thank you for using this ATM. Now, suppose I want to work with another customer number. So I'll just enter a second one. Okay. See, I want to work with my saving account. So I'll go for option 2. First, I want to view the existing balance in my saving account. So I chose option 1. Now the saving account balance is $0. So again, I want to work with my saving account. So I'll go for option 2. Now I want to deposit funds in my saving account. So I'll just choose option 3. Here, as you can see, the existing balance in saving account is $0. I need to specify the amount that I want to deposit to my saving account. Say I want to deposit $700 to my saving account. Here you can see the new saving account balance stands at $700. Again, I decide to work with saving account, and now I want to withdraw funds from my saving account. So I choose option 2. You can see the existing balance is $700. Again, I need to specify the amount that is to be withdrawn from my saving account. Say I want to withdraw $400. So what happens is the $400 amount is deducted from my existing balance, which is $700. So the new saving account balance is displayed as $300. Again, I need to withdraw some more. So I'll just go for option 2, which is for saving account. Again, I'll go for option 2, which is to withdraw funds. And the saving account balance, or the existing balance in my saving account, is $300. And again, I need to specify the amount that needs to be withdrawn. So I'll just write $100. Now the new saving account balance is $200. Okay, so now say I want to exit. So here's the exit message, which is thank you for using this ATM. So friends, now you know how this simple ATM machine interface works, how you can create this simple application with the help of core Java concepts and OOPS concepts. Of course, this is a very basic application and this does not have many features or many high-tech functions. You could improvise as per your needs. This is just for your reference purpose, or if you want to understand how a basic application can be made with the help of core Java concepts, you could definitely refer to this application.
Alright, so the second project that we have today is a very basic calculator application which has been developed with the help of core Java concepts and OOPS concepts. Now, anyone who has just begun learning Java programming language can surely refer to this application example for their better understanding of the language. So let us begin and have a look at all the types of classes that we have created for this application. As you can see, we have 1, 2, 3, 4, 5 and 6 classes in this application, and we also have one interface. We are going to look into each of these classes and this interface one by one in detail. Now, starting off, as you can see, we have worked with arrays, we have linked list, we have queue, and first the class calc, which has the main function. This is where the execution of the entire program begins. Now, the first statement in this main method, here you can see there's a string input exp, which calls the main input class and the read method. Now let us take a look at this main input class. As you can see here, we have a static method, which is the read method. Now inside the read method, we have used the scanner class. I'm sure you all know why we use the scanner class. And for those of you who do not know, scanner class is basically used to accept command line arguments from the user. Next, we have a statement which is printed at the beginning of the application. This says input expression. That is, the user is asked to input any expression, and you also have an example which is given right here, 5 plus 2 multiplied by 9 divided by 6. Any similar expression could be entered by the user. Now the input is accepted from the user and this input is returned back to this string, which is input exp. Now once this has been done and the input expression has been accepted from the user, then moving on, we have two different arrays here. Now what is the purpose of these arrays? Let us see. First we have the array of numbers, which is right here, and the second array is for the array of operators, or you can say array of operations. Now why do we need these two different types of arrays? So the first array, which is the array of numbers, basically stores all the numbers which are there in the expression. Which expression? The expression which has been entered or input by the user. Now all the numbers are selectively fetched into this array of numbers. Again we have the array of operators. Now what is stored in this array? The expression consists of different operators, right? So those operators are fetched selectively into this array of operators. Now let us take an example. Say we have an expression which goes like 3 plus 5 multiplied by 2 and divided by 1. Okay, so suppose this is the expression that has been taken by the user. Okay, now we want to get the result of this expression by performing the entire calculation on the application that we have created. Okay, so now let us see what we can do with the calculator application. Once we have entered the expression, the numbers from the expression are going to be stored in this array of numbers, and the operators, which is the add operator, subtract operator, multiply operator and divide operator, those operators are going to be stored in this array of operators. Next, as you can see here, we have also used queue. Now we have again two different types of queue has been created, and these queue are of string type. Basically, we are storing the operators in one queue and the numbers in another queue. So we have created the operations queue and we have also created the numbers queue. Now, once we have created the arrays, what we are going to do is, with the help of this line, we are changing, or rather we are converting the array of numbers into a very generic list here. And this generic list is again being created, or rather converted to a linked list here. And this linked list is being stored in this queue of numbers. Similarly, what we are doing here is that we are taking the array of operators, we are converting it into a generic list. This generic list is being converted into a linked list of string, which is again or further converted into the queue of operations. Now, moving on, we have this line of code. Here we have the res variable. Now, what is there stored in this variable? Here you can see we have written numbers.poll method. Now, I'm sure you all know that the poll method is used whenever we want to fetch the topmost element from a queue. That is, the first element which is there in a queue is fetched with the help of this poll method. So here the topmost element from the queue of numbers is fetched and stored in the res variable. Okay. Now again we have the while loop here. Next, inside this while loop, whatever the condition you want to apply could be put here. In this case, we are applying a condition where we are saying that the numbers queue should not be empty. This means that this entire while loop will be executed till the queue becomes empty. Okay, as long as we have elements in the numbers queue, this entire while loop will keep on being executed. So the first line inside the loop is this operator string that we have, and we have termed it as OPR. Now this string stores what? Here again you can see we have used the poll method, but this time we want the poll method to extract the topmost element from the queue of operations, and that operator, that is the topmost element in the queue, will be stored in this OPR variable. Moving on, you can see we have the interface operate, and here is the reference. This reference is for the interface operate. Okay. Next up, you can see we have made use of switch case here. Now this switch case block is very important for this calculator application. Let us see how. Here, as you can see, we are passing the OPR variable value into the switch case functions. Here are 4 case blocks that we have, and these case blocks are based on the expressions, or rather the operators within the expression that has been input by the user. Now, here I have made use of dynamic binding. How? I have taken the reference or the interface reference here, and here is the object that I have added onto the interface reference. As you can see, here's the divide object, multiply object, subtract object, and the add object. Now, whenever the expression is being executed or we are fetching the operators, one by one they are matched with these 4 cases. Suppose we encounter the addition operator. In that case, what happens is this add object is invoked. Here we have the class addition or add, which you can see implements the interface operate. Now first let us see what is there inside the interface operate. You just have one single method inside the interface, that is the getResult method, which takes the argument, which is the queue of numbers. And this right here means that it is a variable argument, which means that the entire length of this array, it depends on how many arguments you want to pass on to this method. Although it has a fixed length, but it still depends on how many elements or how many arguments you are passing on to this getResult method. This array could have a single element, it could have 2 elements, it could have 3 elements. It totally depends on how many arguments you want to pass on to this method. Okay, so going back to the add class that we have here. Now inside this add class, since the operate interface already has the getResult method, so in this case it needs to override this method. Now inside the getResult method, we have to perform the addition operation on the arguments that have been supplied to it, and once the addition has been performed, the end result or the sum is returned back to where? It is returned back to this case or the interface reference, which is the operate. Here we have the sum returned back to it. Now once this has been done, this entire while loop gets executed again. Why? Because the queue of numbers is not empty yet. So here's the example that we are considering: 3 plus 5 multiplied by 2 divided by 1. So first what happens is the numbers 3, 5, 2 and 1 are stored in the numbers queue, and the operators addition, multiplication and division are stored in the queue of operators. Then what happens is once the while loop starts being executed, the number 3 gets stored in the res variable. Then we perform the switch case block, we encounter the plus operator, and 5 is stored in the num. I'll just show you where 5 can be stored. Here, as you can see, we have the num variable. Now what is the num variable going to store? You can see we are again taking the poll method. This time the poll method is going to fetch the topmost element from the queue. At first, in this line of code, the element 3 has already been fetched into the res variable. So now the topmost element in the queue of numbers is 5. So 5 is stored in num variable, and then what happens is the res variable is equal to operate, which is the interface reference, dot get result method, and the arguments which are passed inside the get result method is res and num, that is 3 and 5. So we have the addition operation being performed on values 3 and 5. So the result that we get is 8. So one by one, the entire expression is performed and all the operations within the expression take place one by one, depending upon the cases or rather the operators which are encountered within the expression. All the classes that are listed here, it could be the subtract class or the multiply class or even the divide class, they have very similar kind of coding. Here you can see again we have the get result method which needs to be overridden. Here the division is performed and it is depending on the for loop here. Okay, and the end result is returned back to the switch case block. So now I'm just simply going to show you how we can execute this one. Let us run this application. As you can see, we have the statement input expression, which means the user needs to input any expression that you want to execute. So I am going to perform a very simple calculation. As you can see, I wanted to calculate this expression, which is 2 plus 6 minus 3. So 2 plus 6 is 8 and 8 minus 3 is 5. So you can see the result is correct. Suppose you want to perform another result and you want to work with another expression, say 4 plus 8 multiplied by 2. Okay, so here again we have the result right in front of us. It is 24. That is 4 plus 8, 12 multiplied by 2, which is 24. So this is a very basic calculator application that you can create with the help of core Java concepts and OOPS concepts as well. So friends, with this we have come to the end of this video. In this video, I have shown you two different projects that are very basic and beginner level and are based on Java programming language. The first project that we had a look at was an ATM machine interface. I have shown you how you can create a very basic, easy to understand and easy to use ATM machine interface with the help of core Java concepts and OOPS concepts. And the second project that we have seen is a calculator application. We have used interface, different classes, and multiple functions and features of core Java in creating these two applications. I hope you find this video useful, and if you do, then please don't forget to hit the like button and also let us know if these projects have helped you in any way in the comment section below. Please don't forget to subscribe to our channel because we keep uploading new videos every day based on multiple trends and technologies.